Hey, is there someone there who can hear me?
I can hear you, Randall.
Okay, looks like I've got my volume down really low. Fix that again.
Randall, I can hear you just fine.
Oh wait, I see what's wrong here. Okay, I can hear you too. I'm just having a it's quiet because I've got the wrong headphones plugged in.
No problem. We have about 84 subscribers on YouTube, and we are live in the way that any of them would know and could. So we're just pre-announcement live. Mm-hmm.
Have you? So the YouTube link.
The links yet.
It should be on the Livestream active page, right? Or the active Livestream. That's where you put it. And then all you have to do is switch the redirect when you're ready to go.
Yep. So I'm getting that going now. Yeah, I'll put the music back on for a little bit.
Oh yeah, and did you still want to put a link on the front page as well? Or is that already there?
To the, it says call.carboncopies.org. Do you see it?
Right on the front page of Carboncopies?
Oh, sorry. Yeah, I'll put it on the homepage. I thought you meant on the first slide.
No, yeah.
I'll put that on there as well.
Mm-hmm. Awesome. Okay.
Grabbing it now.
And how's the Uber conference thing starting up? Is that there?
It's working really well, and it started.
Great. Perfect. Hi, Mallory. Mallory, if you can hear me, can you say something so I know your stuff works? Not hearing you yet. Still not hearing you.
Mallory, we can hear Randall, but not you.
Nothing yet. If you haven't done it already, you can click the settings thing in Hangouts and tell it specifically which audio to use, which microphone to use.
True.
Not hearing you yet.
We did just test this.
Yeah, that's why it's good to get this started like 20 minutes before.
I see Sara is online.
Mm-hmm. That's great. Yeah, we're still not hearing you, Mallory. If need be, when the time comes, I can start it up and then hand it over to you as soon as you figure out your microphone. Alan.
Yes.
When it's 11, you know, either you or I should say something that we're still figuring out a last-minute technical glitch or something like that.
That sounds fine.
Waiting around.
I can do that. I'm just setting the redirect right now to go to the right spot.
I'm going to use this moment to test what it looks like if I'm sharing my slides, because I haven't really tested that yet.
Mallory, nothing, not coming through. You might try turning the computer off and on again.
Share slides.
Oh no, just making up ideas here.
Can you stop sharing slides for a second, Alan, so I can share mine for just a moment?
Yes, actually, you just have to share your screen. So
and then it's I wanted to pick a specific window rather than, okay, this window, share, and now what does it look like? Okay, it looks like that. What if I do...
You'd want to do full screen.
Yeah, I'm going to try to see what happens if I say present. Okay, there you go.
I'm seeing it looking like an Android size window.
Oh, you are? Okay, I might have to change the size of the window. Here we go. Move that. Whoop. Let's see what happens now. Is it still looking like an Android size window?
Nope, now it looks full screen.
Okay, then you so now if I do present.
And then in the bottom of present, you click, it should hover over a little thing and you can click the button that makes it a browser size window. Oh, looks like it's not really showing up for you.
This thing here?
Mallory, I saw that you just jumped back on and we can't hear you still.
Sorry, Alan, does this look about right, or is this still...
That looks the right size now, but I do see the top of your browser.
You see the top of the browser. Oh, okay. Let's see if there's a way to...
Hold your... well, no, that looks right.
Yeah. How does one do that? How about if it's like this? Does that work? Or is this the wrong size again?
That's the Android size now.
That's... Okay, so then maybe the best for me, given the weird way my window's working, I'll just keep it like this.
Looks like we have about 6 live viewers, so I just wanted to real quick. Hi, my name's Alan. We're still testing out a few things. So anyone who's viewing this, we're about to get ready with our our spring workshop for the Carboncopies Foundation. And this has all been made possible by volunteers. So we're all really grateful to anyone who's contributed to making this workshop possible. This workshop is going to feature a few different speakers, including Ben Goertzel, Anders Sandberg, and Jan Tallinn. So we're going to get started here in just a few moments. There may be just some background music for a while, and we're just trying to get one more of our speakers on if we can.
Okay, you can put your slides back up,
Can
Alan.
you guys hear me now?
Yeah, there you are.
Okay, great. Restarting the computer actually worked.
Excellent. And Alan, yeah, okay, there we go. Perfect. So it looks like we're about ready to go.
Yeah, how many viewers do we have, and when should we start?
10, and whenever you want.
All right, I guess we'll go ahead and start. Like Alan said, welcome to the Carboncopies Foundation 2019 Spring Workshop. I'm Mallory Tackett, the president of Carboncopies, and I'll be moderating this event today. Our topic is whole brain emulation and AI safety. The agenda for today will be starting with our chairman, Randall Kuna, who will deliver a few remarks about the topic. At 11:30 a.m. Pacific time, we will show an interview with Skype co-founder and AI safety supporter Jan Tallinn that was prepared for this event. Following that interview, I will introduce our panel and start the discussion of any issues that were raised. This is the first opportunity for any audience members to ask questions. At 1:30 p.m. Pacific time, we will have the interview, or we will show the interview with existential risk expert and computational neuroscientist, Dr. Anders Sandberg. Dr. Sandberg will then join us from Oxford to answer audience questions. Then at 3 p.m. Pacific time, leading AI and AGI researcher, Dr. Ben Goertzel, will present his remarks. This will be followed by our concluding panel discussion. There are two ways for audience members to participate. You can write questions directly in the live stream chat. This live stream chat is monitored by a volunteer who will alert me to any questions that I can then ask the panel. You can also call in and join the discussion at call.carboncopies.org or call the phone number 415-455-3017. This is also
Mallory,
moderated.
hang on for a second. Jesse is just telling us that while he can hear you on Hangouts, he cannot hear you on the live stream.
Oh.
I don't think that's necessarily your problem because you're coming through on the Hangouts, so Alan should be making sure that you're audible on the live stream.
I believe I'm audible.
I also believe she's audible on the live stream.
Yeah, in Google Hangouts, I believe I'm audible. So,
can anyone just verify that they hear?
Anyone in the live stream that wants to verify that they can hear me?
We have 13 viewers testing if the Carboncopies are seeing this. We have a guy named Luke. Helping us out here. Hi, Luke.
Okay, so
this is Alan from Systems. Luke from from the live stream has confirmed, and so is Claire. Multiple people are confirming that they can all hear us. So it's just
okay. Great.
Okay, Jesse, I don't know what's up with your situation there, but others can hear it. Okay, sorry, Mallory, for that interruption. It looks like we actually are live then. Perfect.
All right. I'll just repeat how audience members can join in since we might have had some new people that joined. You can ask your questions just in the live stream chat directly, or you can call in at call.carboncopies.org or call the phone number 415-455-3017. This is also moderated by a volunteer, and it's going to be very similar to calling into a radio. When your question is chosen, you will be able to ask it to the panel directly and speak with the respondent. This second option is still new, so please be patient with any technical difficulties that we have. When the workshop is done, we would appreciate audience members complete our survey at survey.carboncopies.org. Our thanks to our donors, our volunteers, and all the experts that participated in this workshop. With that, it's time for introductory remarks by Dr. Randall Kuna. You may know Dr. Kuna as our chairman and founder of Carboncopies. He's also a neuroscientist with a background in physics and artificial intelligence. He has spent the last 20 years working in neural engineering labs and companies. While doing that, he has also been studying and bringing awareness to the technical challenges for whole brain emulation and mind uploading. If you'd like to know more about his background, his writing, talks, or anything else, you can find that information at randallcuna.com. Welcome, Dr. Cuna.
Hi, and thanks for the introduction. I'm going to take 1 second here just to pop up a few slides, making sure that works out correctly. So I'm going to pick that window, and hopefully I'll do it right. So we're sharing the window. I'm going to make it present. Does this look correct, or does it look like Android to anyone? Does it look...
Android.
That's the Android thing. Okay, so I'll do it the other way around then. Yeah. Just need to...
That looks better.
Yeah. Okay, well, it's better. I don't know if I can get it to be much better than that. I suppose this is slightly better. The problem is that my monitor is actually flipped the other way around, and it doesn't seem that that Hangouts can deal with that. All right. However that may be. Let's get into it. So thanks, everyone, for joining, and thank you for that introduction, Mallory. As you probably all know, let me just get back to the first slide here, too, so that's all making sense. At the Carboncopies Foundation, we primarily focus on the technical challenges to whole brain emulation. Occasionally, we also explain why we think that mind uploading through whole brain emulation is an important part of the long-term future for humanity, and we could get into that, but I'm going to try not to do that until maybe in the panel somewhere. We haven't previously dedicated events to artificial intelligence, even though artificial brains are, of course, a special category of AI. There are already so many who dedicate their time and present the issues around AI. Some people, for instance, let's say companies like DeepMind or OpenAI, laboratories like MIT's Artificial Intelligence Laboratory, and specialized organizations that have been around for quite a while, such as the Machine Intelligence Research Institute, MIRI, OpenCog, which is headed by Ben Goertzel, and the Future of Life Institute, and many, many others. Of course, everyone at Carboncopies is also very interested in artificial intelligence and in artificial general intelligence. And just to be a bit specific, by artificial general intelligence, we usually mean a kind of artificial intelligence that isn't focused on a narrow problem, but that's focused on being able to handle any kind of problem, coming up with solutions for any variety of problems, sort of like people do. Now, personally, of course, I've traveled in circles where AI and AI risk are primary interests for quite a while. As I just mentioned, MIRI is out there in Berkeley, and in the whole Bay Area, there are a lot of people who care about this problem. So many of my friends are dedicating their time to it. And then it's clear that, of course, there are areas where these domains, whole brain emulation and AI, have to interact. If they're both part of our future, they interact in some way. And it's important to consider what the outcomes are going to be. So, when we talk about safety concerns in AI, typically what we're talking about is what happens if artificial intelligence gets to a point where the programs can write themselves, where every artificial intelligence algorithm can come up with the next better algorithm, or can somehow improve itself along a utility function. And then there's the idea that if this happens fast enough, it could happen so quickly that we don't know what's going on, and we can't control that in any sense. This sort of boom, this big explosion of artificial intelligence, the singularity. Now, whole brain emulation is an artificial brain, in a sense. So in what sense is that a type of AGI, we might ask? It's certainly a kind of intelligence, and if it's in an artificial brain, you might say it's an artificial intelligence, even if the sort of mind that it's creating isn't that artificial. It's something based directly on human brains. How general is it? Well, humanity, of course, was evolved to fit into the niche, the evolutionary niche that happens to be present right now, and 2 million years ago. But still, we're pretty general in the sense that we keep tackling new problems using this same brain that we've got and then the tools that we build. So, we're a part of this big ecosystem of intelligence, as we might say. And you could even just look at that whole ecosystem and wonder, where is that going to go? How do all the pieces interact? What can we expect? And when the ecosystem moves in a certain direction, what happens to those intelligences, the ones that are the human intelligences originally? What happens to them? Where do we fit in? So we have to wonder, as all these bits and pieces are interacting, does that increase or decrease what we're calling the risk, possible risk from AI? Now, those interactions and outcomes haven't received a lot of attention so far. There are just a few examples of academic writing on it. And what we're going to try to do is we're going to try to focus on it a bit more now. In fact, that's what we do with all of our workshops. We keep on trying to highlight different aspects, different pieces of a puzzle that is, oh, it says that my slides are not full screen. Sorry, yeah, I know they're not completely full screen. When I do that, then we get the Android version because my screen is flipped vertically. So I'm afraid this is probably the best that we can do right now. Maybe in future, I'll run it on a separate laptop or something when I do this. Yeah, anyway, what we're trying to do is we're trying to highlight different parts of this puzzle. And there are a lot of parts when we talk about whole brain emulation and the whole ecosystem it's in. If you look at what we've done so far in our workshops, for instance, one piece that we filled in is when we did the Transcending Biology, Reverse Engineering the Brain workshop, we were really looking at the roadmap to whole brain emulation and an update on the status of all the technical bits, what was possible now and what may be possible soon and which technologies are going there. Then we did a workshop called From Brain Preservation to Reconstruction. And in that workshop, we were looking specifically at where are things going in terms of being able to preserve a brain, then be able to slice or section it in some way, image it, and from there get to something that is a functional model, and what sort of problems are you going to run into? We were trying to highlight those problems in a bit more detail. And then we've done a workshop on the metaphysics and ethics of whole brain emulation, which was very different from what we typically do because we've been focusing on the technology so much. And now we're trying to address AI safety and whole brain emulation. And I think there are going to be a lot more pieces of this puzzle as we go along. Now, the topic that we're looking at today, I hope it's also going to become an official part of our road mapping effort. And we're going to advocate that it's going to be included in what I'm calling for now the version 2.0 workshop or conference about whole brain emulation at Oxford University, which I hope is going to happen this year. There's no definitive plan yet, but a lot of indicators are that this may happen this year. Speaking of that, when that workshop does happen, to update, let's say, the white paper that came out in 2007, I hope that we bring in a whole set of new people and different angles, because a lot of the things that we would talk about now, they just weren't around back then. For example, now we have Anthony Zador, who appeared at our Transcending Biology workshop, who developed the molecular barcoding approach to mapping a connectome. The Boyden team, including Adam Marblestone. By the way, Adam Marblestone is now at DeepMind, developed expansion microscopy and wrote a set of seminal papers about fundamental neurotechnology. None of those were present at the first workshop. We've had Professor Sheffer come in, who tried to explain how his team has started to attempt to reconstruct functional Drosophila circuits from structure scans, as presented in our From Brain Preservation workshop. And then, of course, the Berger and Song labs that have been working full tilt on cognitive neural prosthesis, which is really the closest example we have of partial brain emulation. Those were not on the radar back in 2007, and that's really just the tip of the iceberg. The white paper that came out of the first workshop focused on how much compute power a whole brain emulation would need and how a preserved brain could be sliced and scanned. The big problems of wholesale functional data acquisition and of how to convert brain data into working brain models, those were hardly addressed, nor were subdomain topics like AI safety, models of consciousness, or societal and ethical issues. Okay, so at this point, much of what's been said about AI safety and whole brain emulation sounds more like hand-waving speculation than careful study. There's been a mention in Bostrom's book Superintelligence, some introductory studies that Carl Schulman has done, about not too much of that has been published yet. Informal communications that we've had with people from the FHI, the FLI, or MIRI. And there was one paper that came out in 2017 that was interesting by Daniel Eth on AGI and neural probes, which connects fairly closely to AGI and whole brain emulation. And then, of course, a few sci-fi situations like the version that was depicted in Transcendence, where you could say they included both whole brain emulation and the danger of runaway AI in one movie. Perhaps that was a bit much to squeeze in there, but it was an attempt to do that right. Now, the people we've invited to this workshop have expertise that comes from several directions. Jan Tallinn has a background in AI safety and existential risk. He's been busy in that for quite a while. Dr. Ben Goertzel has, of course, been working for years on the development of AGI, and he's had a hand in many other sort of tangential parts of that as well. Dr. Anders Sandberg has done a lot of work in existential risk, and he was also, of course, involved with whole brain emulation, specifically with that first workshop in Oxford, where we tried to pull together some of the people at the time who had a lot of interest in the topic. And then, of course, those of us who are on the panel from the Carboncopies Foundation, we've all been involved in some sense or another in whole brain emulation development, even if it's mostly from the technical side. Now, some people that we wish were here aren't here this time, like Carl Schulman, Nick Bostrom, people from OpenAI or DeepMind, and more. But a first workshop can only be so big, and there's going to be plenty to digest in this first iteration of the topic. So, let's see now. When we talk about, I want to get to the next slide here. When we talk about the kinds of interactions that can happen between artificial intelligence or artificial intelligence safety and whole brain emulation, one of the problems is that you get into interactions between different domains and different technological developments, and those are always really complicated and hard to predict. If you look at examples of attempting to predict these things, then often people have to choose something very constrained. Take, for instance, our friend Robin Hansen's book, The Age of M, where he tries to predict from an economic perspective as an economist what would happen if you had wholesale whole brain emulation available and basically infinite compute power. But he leaves out some things. For instance, he does not include artificial intelligence that is not whole brain emulation directly in that. So a lot of the things that in his economic model are done by copying brains, they could be done by using a different type of AI, something more narrow perhaps. So then that changes a lot about this society he's depicting. And you can imagine that the society that he's depicting there could easily transform itself quite quickly into something very different, perhaps something that does include a lot of AI. So, the problem here is that as you explore different angles of the question and questions, you keep discovering that you have to clarify those questions more and dig deeper and uncover more of them. And you're going to notice this in the interviews that I did with Jan Tallinn and Anders Sandberg. Every insight uncovers many more deep questions, but you've got to start somewhere. So I've decided to seed the conversation by asking everyone a series of questions that are based on statements, assumptions, or intuitions that I've run into. I'm going to try to take you through these very briefly before we move on to the next section of this workshop, just so that we're all on the same page. Now, in taking you through this, I just want to mention that typically, when I talk to people who are coming from an AI safety background about whole brain emulation and whether they think that this is something that should receive extra funding or should be pushed hard, that there should be work done on it, I get two different kinds of responses. Some people will see work on whole brain emulation as being something that decreases the risk of runaway AI. And there are a few of these examples that I'll mention in just a moment. And others, they seem to come at it with an intuition that whole brain emulation research is more likely to increase the danger of runaway AI. And again, there are some examples of the sort of thinking that goes into that. But as I've mentioned already, most of that seems fairly hand-wavy at this moment, and it really does deserve more precise attention. So let me just get started on the first one here. I think I may have skipped one. The first one is, well, BCI for AI safety, brain-computer interfaces. In recent years, there have been a few, especially some very well-known entrepreneurs who've started companies like Neuralink, who've claimed that work on brain-computer interfaces, on high-bandwidth interfaces between a brain and a machine, are a route to improved AI safety by causing something like a symbiosis between humanity and AI. But you have to dig in a bit deeper to try to understand whether that's really true or in what way that would happen. And that will be discussed more later on. But here I'm just going to mention a few of the big questions there. So for instance, what is a high bandwidth interface? What does it mean when we say high bandwidth BCI? What are we comparing that with? Are we comparing it with the rate that we can type or speak? Imagery? Does it mean that you target a certain percentage of all of the neurons at the same time and stimulate them? What does it really mean? And if you can make a connection like that between a biological brain and a machine, what's the predicted effect of a connection like that? What's the effect on the human? How does the human experience change? How much does the human become a part of that AI ecosystem? And what's the effect on the AI? How does connecting with this human brain implement something you might call a level of control or a level of supervision in some sense, or anything like that? When people talk about neural interfaces, sometimes in the popular press, they're conflated with neural prosthesis. But they're not. They're not a neural prosthesis. They're just the connection between a brain and a machine. Now, the human brain has about 83 billion neurons, and each of those neurons communicates at a typical maximum rate of about 100 spikes per second. Some of them can go up to 1,000 spikes per second, but not much more than that, which is, a much bigger interval than, say, the nanoseconds and microseconds that computers work at. Also, human thought is based on processes like pattern matching, or giving an emphasis to certain patterns by up or down regulating the neurons in that area, or on regularity, which is Hebbian learning, things that fire together, wire together. And machine thought is typically based on the execution of programs, on arithmetic, on logic, and on sometimes artificial neural networks. I just want to mention that I'm not currently looking at my email. I see that there are some emails coming in. If anyone's trying to actually reach me, I can't see it. A message on my phone, if there's something wrong with me coming through or whatever, please ping me there. So if you create a high bandwidth communication pathway between the brain of a biological human and an advanced AI, how does that affect AI safety? That's a very legitimate question that's not that easy to answer. Now, the other argument that is often made is to urge caution in the development of whole brain emulation, because perhaps whole brain emulation itself could be a risk to humanity, maybe because it could become a runaway AI. But the scenario there isn't often clarified very well. How, for instance, would a human brain be able to follow an engineered or predictable self-improvement curve? How would this compare with the notion of self-improving AI that follows a utility function and uses reinforcement learning as its primary method of improvement? If a whole brain emulation is accomplished and implemented on a suitable processing platform, will a whole brain emulation be able to rapidly self-improve in a manner that's akin to this supposed AI takeoff scenario? Is there a way for whole brain emulation to do that rapidly? Is there something like a whole brain emulation FOOM? That too deserves more detailed thought than whatever our intuitions may be saying. Now, toggling back to looking at this as a potential risk in a different way, concern about the acceleration of risky AI improvement, or the curve that AI improvement may take, that's another reason, a possible reason for being cautious about the development of whole brain emulation. But again, the way that it could happen isn't entirely clear. The way this this is presented is usually that the development of whole brain emulation may lead to insights that will then make the development of AI happen faster. Just like the basic insight of how neurons work that led to neural networks and deep learning, and this is still something that's used in AI. But how much of that is really happening today? How much insight are we getting? And also, how does this really differ from the insights that are gained from general neuroscience research that's happening today? Is there something specific about doing research on whole brain emulation that would accelerate AI development in a way that general neuroscience research doesn't? We need to at least have some examples of that. Now, finally, the last question that I wanted to present at this point is, well, sometimes people will say the best way to achieve AI safety is if we ourselves can develop at the same rate as AI, if we're completely merged with it, if there's no distinction between human and machine, if we somehow bring those two together, thereby getting rid of a competitive race between humanity and artificial intelligence. Now, again, that needs to be clarified a bit more, because we don't really know what it means to say we're linking an uploaded mind with an AI. As we just mentioned, they work in slightly different ways. What does it mean to link, the kind of pattern matching that we do with the sort of algorithms that are happening in an AI? How does that change the way that the human brain thinks? How does that change the way that the AI thinks? How do they control each other? How does this whole ecosystem move forward? And then there's the question, well, even if you do this, if you merge the two and they're moving forward together, this merged ecosystem of intelligence, does that really solve the original problem of AI safety, or is it just taking away that one problem of the competition between humanity and AI, or that one aspect? Because the self-improving AI, which could be, say, something that is reinforcement learning and following a utility function, that might still be a problem in itself. Even if you've got these other merged AI and human brain uploads there, you could still have a separate class of AI agents that are a problem. So it could be that those two things are tangential, or maybe even orthogonal in a sense. So again, that's something that deserves more time. Now, obviously, we can't answer all those questions here, but we can make a start at being more precise and at stating those questions clearly. And that's what I hope I've managed to do here. Now I'm going to stop sharing my slides. I'm going to hand it back to Mallory here. Thank you very much.
All right, thank you, Randall. There's going to be plenty of time for follow-up questions during our panel discussion, but again, you can put those follow-up questions on the live stream or call in at the number. Now we're going to be going to the interview with Jan Tallinn. He is the co-founder of Skype, and he's been a longtime AI safety supporter. So we'll go ahead and show that.
Hey, Mallory, it looks like last minute. Mine was working in our test, but it's not. Would you be able to stream it?
It looks like we're having some technical difficulties. I am going to go ahead and just play the interview on my computer, and I will stream it for you guys.
Thanks, Mallory.
Just need to change my speaker output. There we go, we're sharing.
And, introduce the topic. And we always talk about anything in the beginning that doesn't. I'll just introduce you first and introduce the topic. And we can always crop out anything in the beginning that doesn't really belong right in. Okay. Our esteemed guest for this event is Jan Tallinn, accomplished and well-known entrepreneur, investor, and theoretical physicist from Estonia, who co-founded the peer-to-peer video calling service Skype, among other ventures. He's since been a leading voice on the frontiers of AI safety and effective altruism, and has co-founded the Center for the Study of Existential Risk and the Future of Life Institute. Welcome, Jan, and thanks for agreeing to give us your time today, despite your very busy travel schedule. Now, hi. At as you may know, at the Carboncopies Foundation, we usually focus on the technical challenges for whole brain emulation. And occasionally we explain why we think mind uploading through whole brain emulation is an important step for the adaptability of intelligent species. But everyone at the Foundation is also very interested in artificial intelligence and artificial general intelligence. But since there are already so many labs and companies like DeepMind, groups like the Machine Intelligence Research Institute and others dedicated to AI, we don't often address it in our workshops. We decided that the interaction between those two domains should be addressed explicitly. The possible interactions are sometimes alluded to, but from what I've heard and read so far, there's a lot more vague hand-waving, I would say, than careful study. So we wanted to try to move that along a little bit, especially starting with this workshop on whole brain emulation and AI safety. So if you don't mind, I'd love to ask you a few questions about your thoughts on AI, and from there, maybe we can gently tiptoe into questions of where AI and whole brain emulation meet. Is that okay? All right. So you've got a long history of being concerned about or supporting serious study of existential risk, and in particular AI risk and AI safety. Would you mind telling us a little bit about how your thoughts on that topic have evolved over time and where you stand on that today?
Yeah, I think my thoughts have gotten more and more uncertain in some sense, as I've been kind of exposed to more and more considerations, and like more research has actually come out, and also like there have been kind of particular achievements that AI has made, or progress that AI has made.
When you say decade. More concerned or more uncertain, do you mean you're more concerned, or just that you're not entirely sure what the problem is?
Yeah, like I see like a wider spectrum of possible scenarios now, than I was just seeing when I first got involved. I mean, before I got involved, before I read like the Eliezer stuff, I just didn't think that was an issue at all. Like, I was a programmer, and I wasn't afraid of programs. So, but like then Eliezer pointed out, like, wait a minute, like if you can create a program that's able to create program, and that happens to be get smarter at each step, like we might have a serious problem. And then I got focused on that scenario, and I still do think that this is like we have no guarantee against that, like recursive self-improving runaway AI. However, recently I think Open Philanthropy project, they introduced the concept of transformative AI. So instead of talking about like recursive self-improving AI or narrow and general AI, which are in some sense actually specific, we should actually just focus on the aspect of AI that is important for us, which is like it can be very transformative, even if it's narrow or if it's like not recursively self-improving. It's just for some reason kind of exceeds some threshold and then no longer improves, but still it's going to be transformative. So that's like in that sense, I see like a wider spectrum of transformative situations or transformative scenarios with AI now, which is kind of in that sense I'm more uncertain.
Yeah. So okay, we could go in all kinds of directions with this, and I don't want to spend too much time on it just because we have these other topics that are really the focus of the workshop that's going to happen. But I am kind of curious because you mentioned this, getting real advantages for the species, for all of us, out of narrow AI, out of certain directions. Narrow AI itself also could pose concerns, right? I mean, we've seen some issues with narrow AI even in recent times, like the way that a stock market crash could happen or other things like that, right?
Well, the Facebook scandals, they have to do something with AI. Although I'm not sure how much, but still.
Indeed, yeah. Okay, but it's not as concerning as, say, the issue of AI agents, probably.
I mean, not the current things, but like perhaps like in a few generations from now, we might have something that is just like super manipulative or super addictive, while not being kind of like really good at that kind of recursive self-improving. So still like that kind of scenarios, they're still part of my palette.
Well, if you don't mind, I'd love to know what your idea is of, say, a worst case scenario versus a best case scenario of how we move forward with AI.
Yeah, so like I get that question quite a bit, I usually don't have a sort of very specific answer, because I think that whenever you start thinking about really specific scenarios, like you're almost guaranteed to shoot yourself in the foot, because like it's like each detail basically will make the scenario less likely. So I think it's more valuable to think about general properties or traits that like really positive scenarios or really negative scenarios have in common. So for example, I think almost all existential risk scenarios, be they from AI, from synthetic bio, even from nuclear, although I think that nuclear is kind of unlikely to be existential catastrophe. They have this, one of the traits that I think they have in common is that they're going to look like environmental catastrophes to humans. So that's like there's interesting like point that the first piece of existential risk research that humanity did was the report LA602 by Manhattan Project scientists, where they're were calculating what is the probability of igniting the atmosphere once they do the first nuclear detonation. So like for the rest of the planet, it would have just looked like an environmental catastrophe. Suddenly there's no air to breathe. So I think that that's like one likely common trait in not all, but I would say majority of existential risk scenarios, bad scenarios. Like the existential hoop scenarios, one of the traits that I can think of they have in common is that there's an increase rather than decrease in optionality. So like one thing that technological progress has given us is this increase in optionality. Like I do have an option to like easily visit other countries these days that like 100 years ago very few people had, or like at least not that in that quantity. Whereas in future, if things go well, we might indeed have options to travel to other places, or options to upload ourselves or not upload ourselves. That's also an important option to keep. So like that's another common trait. I think that positive. That's another common trait that unifies like a set of futures and specifically a set of positive futures.
Yeah, I can totally see the point that you're making, because I mean I also see optionality as being one of the most important things for us. It's sort of something that for some reason as human beings we care about, that sort of thing. We care about.
I think that's more general than human. I think that's agents in general that have preferences over the world states. Like all other things being equal, they would prefer more options than less options because of the uncertainty that they have. Like things like it's a meta value. If you have certain preferences, but you don't know what are the correct actions to take right now, then like it would be valuable to have more options, because in the future you will have more information about what options are actually best to pick. So that's I think general agent.
It gets into some interesting sort of philosophical directions there, because when you think about having as many options as possible, then of course that includes things like options to do things that we currently simply can't do because maybe we can't even think that way. So something like neuroprosthesis or mind uploading would be necessary even to just be able to do those things. Like let's say, for example, be aware of and react to things that are happening at very short time intervals, like say microsecond intervals. It's a world that we currently can't live in, right? And so optionality might include changing who we are in a sense. And but that stands, well, it gets interesting, because some people would say if we change ourselves a lot and we're not really who we are anymore as humans right now because we've changed a lot, then perhaps that's very similar to a scenario where, say, a worst case scenario that was mentioned, where suddenly the environment no longer supports humans as we are. You know, that there could be scenarios where that might look very similar.
I think like it's important to kind of be more precise about what do we mean by optionality. How do we measure the increase in optionality? So like you can certainly have like a increase in optionality that one person or one group of people, like Manhattan Project scientists, had to detonate a potential like Earth-ending device. That's an additional option for them, but that might result in like everyone else losing all their options by going extinct. So in that sense, like a more general version of it is that like we should really measure some kind of like aggregate optionality that humans and more general sentient agents.
But even that's very, very difficult to measure, because you might then argue that you should be measuring the aggregate over all possible future descendants of humans, as opposed to just the people who are here. Because let's say that something takes optionality away from 90% of the people, but then the 10% of the people who have more optionality, that creates a much greater future with more optionality for many more people than the alternative.
Yeah, but we will go into population ethics and infinite ethics even.
Right.
That is like active research topic, and it looks like we need to solve it sooner rather than later.
Yeah, again, I'm saddened by the fact that we can't talk about every topic at length, because these are super interesting things, and I've always wanted to dive deeper into this question of how do you decide what's good, right? How do you decide a good solution?
As a meta point, don't you find it like kind of almost suspicious that there's like a very strong overlap between like super interesting topics and super important topics? Like it's not always why it should be like that.
Okay.
But there is, which kind of makes me a little bit suspicious.
Yeah, that's suspicious. Yeah, that could point to something as well. That's true. Yeah. Okay. Well, I guess maybe we'll have to have another workshop someday on what is good, or how do you decide good. But that falls more into, say, the domain of effective altruism or something like that, I think.
Yeah, but also I think it's like you can always kind of like make progress by going like up on the level of meta. So like you say like it seems really hard to decide like what is good. Then you go like up one level of meta. Go like, okay, so what kind of things should I do now that would give me more optionality to decide in the future what is good? Or like what are the, like, for example, at the recent conference in Puerto Rico, the Future Applied Institute organized, that there was like someone who was kind of making a really good case that it's probably going to be really likely that there's massive value in having like this contemplative period during which we basically kind of like as humanity think about what's going to happen in the next like trillions of years, as opposed to like just like rushing along with the first thing that comes to mind, because it's like just we have like good reasons to think about that we're going to be better at creating value during that period than we would be basically losing from not acting in this first period. That's another meta point.
Yeah, I think that's probably true. It's unfortunate that when you look at the decision makers across the world, very often that's exactly not what happens. It's more the opposite, that the next quarter is what matters the most. Yeah.
But that's also like it's like an opportunity, because like you see like why this is happening. You see the game theoretic underpinnings of these situations, and once you can realize that, you can perhaps take a step back and think about how do you solve those like what's called coordination problems.
Okay, well, having created this context and putting it in a setting like this, maybe this is a good moment to dive into the whole brain emulation aspect of it. So just kind of introducing here where this is coming from. When discussed in the context of AI safety, I get different reactions to the notion of whole brain emulation sometimes. Sometimes people will be seeing it as a potential benefit, something good that will help us not have as much AI risk, because humans will be able to keep up better, will be better integrated with a changing world of technology. But sometimes I get the exact opposite reaction, which is, well, whole brain emulation seems like something that adds another unknown. It adds something else that could accelerate the development of artificial general intelligence or agent AI, and that it could be its own risk in some sense as well, which kind of relates to what we were talking about before about, which changes on optionality are good and bad, and the sort of figuring out what the difference is there. So I was wondering if we can get into a few specific questions there, because there are some main avenues of thought or critiques that come up from time to time. So the first one that I wanted to ask about is this idea that making a connection between the human brain and a computer, so brain-computer interfaces, that is somehow a very important step towards uplifting us to a point where we are more integrated with machines, and where the gap is made smaller between human minds and artificial intelligence, and the differences in our capabilities, that somehow this is going to create a symbiosis, as one well-known entrepreneur has said, with artificial intelligence. Have you thought about BCI? And I'm not, so just keeping that separate from neural prosthesis or mind uploading for a moment, but just BCI as a tool for that.
I guess like my clip answer would be that I really like Rowan Hansen's comment about this. He said that trying to make humans competitive with computers by developing like brain-machine interfaces. It's like trying to make horses competitive with cars by developing stronger ropes. So like I wouldn't rule out that there is like something there, but like the bandwidth argument I find just like utterly unconvincing, because like if you think about it, like if you were kind of like partnered up with someone who is like runs 1 billion times slower than you do, then that's basically a person who can say one word per decade, and like it's just going to be a burden. It's not going to be like useful. You already know what the word is going to be. That are useless too.
Okay. Yeah, I think.
So that's the bandwidth.
Yeah.
That's the answer to the bandwidth argument. But that's just not a bottleneck. That's the claim. But like there might be some more interesting arguments that I haven't heard. But like.
I don't know about the rest of you, but I'm having audio trouble here. Not hearing anything on the live stream.
It seems muted, Mallory. Can you pause it till it's on? Uh-oh, Mallory might be muted.
Okay, well, if necessary, yeah, you can. You could take over.
Contingency plan now.
Sorry, everyone who's experiencing this problem as well. This is why we have 2 people who have the interview and can stream it, just in case, you know, someone's bandwidth goes bad or something. So hang on for just a second.
Absolutely, of course, it's very important. But yeah, I agree with you that in itself, that's not
unknown. It adds something else that
so yeah.
could accelerate
Wait,
the development
Mallory.
of artificial general.
Yours is back on, Mallory?
Yes, it should be working now.
All right. We'll leave it with that then.
All right.
Were you able to put it back at the point where we lost the audio?
Hear someday from the people who do advocate that as being the most essential thing to do for AI safety.
That space that I can certainly not imagine that there.
What point should I rewind it to?
Yeah, maybe put it back about 2-3 minutes.
Point.
All right.
Yeah, I think that's probably true. It's unfortunate that when you look at the decision makers across the world, very often that's exactly not what happens. It's more the opposite. That the next quarter is what matters the most.
But that's also like gives like an opportunity, because like you see like why this is happening. You see the theoretic underpinnings of these situations, and once you can realize that, you can perhaps take a step back and think about how do you solve those like what's called coordination problems.
Okay, well, having created this context and putting it in a setting like this, maybe this is a good moment to dive into the whole brain emulation aspect of it. So just kind of introducing here where this is coming from. When discussed in the context of AI safety, I get different reactions to the notion of whole brain emulation sometimes. Sometimes people will be seeing it as a potential benefit, something good that will help us not have as much AI risk, because humans will be able to keep up better, will be better integrated with a changing world of technology. But sometimes I get the exact opposite reaction, which is, well, whole brain emulation seems like something that adds another unknown. It adds something else that could accelerate the development of artificial general intelligence or agent AI, and that it could be its own risk in some sense as well, which kind of relates to what we were talking about before about, which changes on optionality are good and bad, and the sort of figuring out what the difference is there. So I was wondering if we can get into a few specific questions there, because there are some main avenues of thought or critiques that come up from time to time. So the first one that I wanted to ask about is this idea that making a connection between the human brain and a computer, so brain-computer interfaces, that is somehow a very important step towards uplifting us to a point where we are more integrated with machines, and where the gap is made smaller between human minds and artificial intelligence and the differences in our capabilities, that somehow this is going to create a symbiosis, as one well-known entrepreneur has said, with artificial intelligence. Have you thought about BCI? And I'm not, so just keeping that separate from neural prosthesis or mind uploading for a moment, but just BCI as a tool.
I guess like my flip answer would be that I really like Robin Hansen's comment about this. He said that trying to make humans competitive with computers by developing like brain-machine interfaces is like trying to make horses competitive with cars by developing stronger ropes. So like I wouldn't rule out that there is like something there. But like the bandwidth argument, I find just utterly unconvincing because, like, if you think about it, like if you were kind of like partnered up with someone who is like runs 1 billion times slower than you did, then that's basically a person who can say one word per decade, and like it's just going to be a burden. It's not going to be like useful. You already know what the word is going to be. Not something useless to you.
Okay. Yeah, I think.
So that's the bandwidth. Yeah. That's the answer to the bandwidth. But that's just not a bottleneck. That's the claim. But like there might be some more interesting arguments that I haven't heard. But it's possible that I just haven't been paid attention to like some more serious thinkers in that space. That I can certainly kind of imagine that there are some more. You can certainly learn more things if you have like higher bandwidth interfaces, learn more about the brain, for example, and then that could be useful in brain uploading, for example, or useful for other alignment purposes.
Oh, absolutely. So I see brain-computer interfaces as an essential component for data acquisition, for learning about the brain, in order to be able to model brains, to be able to make neural prostheses and that sort of thing. So as a technology heading in that direction, absolutely, of course, it's very important. But yeah, I agree with you that in itself, that's not really solving a problem of this gap between the two. So yeah, so I guess we don't have to get into that much deeper, since we're both on the same side with this one. I would like to hear someday from the people who do advocate that as being the most essential thing to do for AI safety. I'd like to understand where they're coming from or how they imagine this should work. So
sure, like if there would be like some serious, careful thinkers in that area, that would be like super interesting to talk to.
Yeah. Okay, so the next critique or argument that I often get is that if you work hard on building neural prosthesis, and then from neural prosthesis or partial brain uploads, you end up getting to whole brain emulation or some kind of artificial brain like that, that this is in itself, of course, a type of artificial intelligence or artificial general intelligence, if you like, although other people would call it natural intelligence emulated, and that it would be fairly easy to make it superhuman just by, say, increasing the speed or something like that, or making sure that the memory is never fading, something like that. So then that there could also be some sort of takeoff scenario, either a slow one or a fast one. Now, I'm not exactly sure how self-improvement works with a human brain. I'm sure there is a method, and it may be a bit more patchy and a bit more complicated than with something that has one specific algorithm that is following. But before we even get into that, do you see ways in which whole brain emulation itself could be an existential risk to humanity?
Oh, sure. Like the way I haven't thought like much about it. So in that sense, my thoughts are not super careful here. And so mostly I like to like outsource my opinions to like more careful analysts like Carl Schulman. I think is like excellent in this topic. And he considers brain uploads as net positive. So in that sense, I'm like working on fires that come from him. But I do think that there's like this almost like uncanny valley. Before we get the brain uploads, we will get to something that is potentially capable, but not really human yet. So it's like we might have like a potentially very capable non-human agents on this planet, which is like almost isomorphic to unaligned AI problem. So that is like one scenario definitely that might be problematic. Another scenario is basically when it turns out that there's some kind of like competitive situation or something where you get some advantage in some competitive access by sacrificing a piece of humanity, a piece of values, which means that like we have like some race to the bottom thing with brain uploads. That would also be another existential disaster potential. So like those like either like getting fake humans might be problematic, or ending up in some weird arms race would be problematic with brain uploads. But also like if you get things right, then that might be really awesome because we might just buy more time when it comes to solving problems that humanity faces.
Yeah, but it's clearly so complicated because there are so many different details about how the research evolves and how you get from the very first bits you're doing, say you're just making, like Ted Berger's hippocampal prosthesis or something like that, or you're trying to emulate the brain of a Drosophila. And what happens if you start building agents based on these Drosophila brains? There's so many different paths, as you said, that makes it a really complicated question of how do you make sure that you end up with the net positive of that versus you end up going down some path that has, risks associated with it. But of course, that's also true for any technology development. Every time we develop some new technology, there are many different possible outcomes and products and things that could have net negatives and net positives as well. It's just, it's too hard to. Okay, all right, so there definitely are some ways in which it could be an existential risk, but it's not that clear. Yeah, I was kind of curious about this case of, say, how could people using a neuroprosthesis become an existential risk to all of us or something like that. But again, that sounds like a great sci-fi scenario. But
like this weird cyborgs.
Yeah, it's hard to
that
evaluate.
Speak in metallic voices.
Yeah. But then you also again have to think, if this is again weighing optionality versus staying the same. And you mentioned competition, but what if that competition itself is something that has ultimately a long-term net positive or something like that? You have a species that is a little different than humans, but that ends up
technological competition seems to have given us a lot of fruits that are clearly useful.
Okay, yeah. All right. We're actually making pretty good progress through these questions, even though I thought it would take forever to.
At least it's so long. I'm trying to kind of like.
Yeah. You're giving short answers. All right. Okay. Well, that's good. Let's get into the next critique then, or the next argument. The next argument I've heard that cautions against a strong push for neurotechnology and whole brain emulation is that work in those areas may accelerate advancements towards runaway self-improving AI. And, well, does it concern you? And how do you see this different, say, working on whole brain emulation versus just the way neuroscience is currently investigating the brain?
So, yeah, intuitively, it doesn't sound too dangerous to me. I think because the sort of like lower hanging dangerous fruits, like just throwing more compute at the stuff, like simple algorithms that people are doing already anyway, and trying to like create AIs that create AIs that create AIs, like architecture search. Whereas like if you're kind of tinkering with something that is like a spaghetti code, like and trying to get insights, that seems like possibly problematic, but like just doesn't strike me as like the most dangerous thing to do. You know, like just digging around in a spaghetti code that is human brain.
Okay. Yeah, I was trying to think of examples of specific things that I might think that would be discovered by doing research on whole brain emulation, as opposed to the way that most neuroscience is conducted today. It's not obvious to me, even with things that are still problems in AI. Say, for example, that deep learning requires exponentially more learning as you try to train up more complicated knowledge or a better understanding of context around it. That's something that we would love to understand better, how it is that humans manage this, especially since we can only digest very few examples for everything that we learn. But it's not really something. Yeah,
there's definitely there's possibility to stumble upon that, but because it's human minds as spaghetti code, it's just not super likely that they're going to.
It's not clear how you would learn this from trying to do whole brain emulation, right? Yeah, it's more something that, you know, cognitive science, AI research itself, something like that is more likely to come across that solution.
Or just AI itself is able to figure that out when it's doing architecture search. So it's like, if there's like a humans doing like kind of architecture reverse engineering with human minds, or AI doing architecture search in AI space, like my money would be on AI right now. That might change in the future.
We can simply do so many more searches so much faster.
Yeah, it's like way dumber search, but like evolution was even dumber still.
Yeah, I think so as well, yeah. Okay, that brings us to the fourth big argument, and this one is one in favor of whole brain emulation, and the idea is, of course, this idea of symbiosis, so the merger between what is, you know, the human mind and the merger with AI and its capabilities, and the idea that you can reduce AI risk, or the risk to us in a sense, by being more closely integrated, completely entangled with everything that's going on in AI, so that a whole brain emulation, a mind uploaded person could benefit more directly from what is developed in AI, because AI modules can be part of them, or they can be part of it. It's kind of hard to describe because I don't really know how to imagine it, but it's sort of this join them rather than compete with them. This idea of, in the past, royal families used to marry among one another to avoid competition and to consolidate their power. It's a mingling of a DNA in a sense, except that, you could say that this is alien DNA. It's AI DNA is somewhat different than human DNA. Have you given some thought to what this merger might look like?
Yeah, I think that's like you brought up the mixing with alien DNA. Like we should be kind of like wary for a very similar reason. I mean, AI is going to be more alien than aliens. If you have biological aliens, they're likely going to have similar arts, because the guys have been invented at least on this planet many times, and like they're similar. So like there are pieces in that DNA that's going to be similar if you're going to merge with aliens. But even that would sounds like a little bit like icky to me, just to say the least. So like with AI, it should be way more icky, even though it doesn't feel as icky as merging with aliens. And also, I think it doesn't strike me as a sufficient rigorous thought exercise when you talk about solving a complicated problem by just ignoring most of it and just doing something that feels intuitively warm.
Okay, so that's, yeah.
But I mean, having said all that, I wouldn't I would leave open the door for some serious thought in this space, and perhaps people actually would come up with some interesting scenarios that involve things like transparency, for example.
Right.
Transparency. How can we make it more difficult for AIs that are improving to do like what we Boston call treacherous turn, and the more ways we have to monitor them, the more difficult it would be to do that for AIs. So it's like the better we would be kind of steering those critical in those critical phases. So that would like one angle of attack perhaps that would be value in this like sort of merger scenarios.
Okay, yeah, so I completely agree that it's necessary to get more detail to think more rigorously about these examples, because what we're doing now, I mean, it's useful to discuss like this, but it's still kind of hand wavy. We're just sort of saying, you know, in general, one could think of how the two can merge, and in general, we might think of how this might help in supervising how AI is developing and stuff like that. But when I try to think in real nitty-gritty detail about how AI and human minds can merge, then I start to think about things at a smaller scale, not the scale of an entire brain, but something like, okay, let's take an example. Let's take, because it's here, because it's a real example, let's take Ted Berger's hippocampal prosthesis. Now, Ted Berger's hippocampal prosthesis, when implemented on, you know, either software or in a chip, it's really just a model that is learning to approximate functions from input to output, and it's searching for those best matches and then using them to do what that piece of brain tissue is supposed to do. Now, there are many different ways you could implement that. And of course, even now, that's where AI comes in. He's using machine learning techniques to build those models. So there is a lot in which there are a lot of ways in which developments in AI can find a home in these pieces that are then developed as replacements for bits of the brain. It could be very small. It could be at the level of an individual neuron or an entire area. It could then lead to differences like, say, hippocampi that allow you to directly select which memories to keep and which ones to forget, and that sort of thing. Or, you know, you can imagine that there could be other ways of strengthening connections between different patterns than the normal Hebbian learning, but another way to do that. So I can see a lot of ways where at this very fine scale, where AI immediately starts to become integrated into neuroprosthesis and whole brain emulation, because it's just the natural way to try to solve these problems, to implement things in there. And that's the first part of it. And then the second part is where you would intentionally want to make it possible to feel that you have the capabilities of some AI system, and that it feels as natural as, say, being able to retrieve something from your memory, so that it's like a part of your brain. Human minds.
All right, is this audio working now?
Yeah, it's back on.
Okay, great.
Have insight, as you say, transparency into what's going on. So that's still not really an automatic thing. It still feels like, even if you're trying to create this merger, because, you know, whole brain emulation uploaded minds are already closer to software code, and I mean they can be software code, and therefore you see this at a small fine detail. You see these mergers happening. It still feels like the problem of AI agents that self-improve rapidly and could go off in a wrong direction is kind of a tangential problem. It's still something that needs to be explicitly dealt with, and isn't automatically dealt with by having.
Not just like individual AI agents, but also like some weird races that we might create as like in this like whole brain emulation scenario. I think the same kind of threat model applies there. Like the opportunities is like kind of similar in kind of augmentation and in whole brain emulation, that we will just create smarter humans, and we definitely need smarter humans right now to figure out like how to actually stabilize the future. However, the threat model again is like we might be creating smart non-humans by doing careless augmenting, or we might create some weird race to the bottom in competitiveness, and basically then lose all optionality and all humanity.
Yeah, and that is what feels like not good to me when you say
for a very correct reason. Yes,
yeah.
yes.
Exactly.
So yeah, but I definitely do think that there is opportunity there in having just. I mean, simple thing is like I think as a lot of like augmentation advocates point to is that like we're kind of like we already augmented, right? So
yeah, of course.
So in some sense it would be a natural progression, and so far it seems to be. I mean, with a few setbacks, it seems to be like so far so good. Now the question is like how much runway we still have until we have to be kind of like more careful and more planning when it comes to augmentation.
Okay. Yeah. Right. So we've run through pretty much all of the main questions, and I do have a concluding question. But I wanted to ask first if there is something in this whole topic that you feel that we haven't addressed or haven't talked about that you think really should be mentioned.
Yeah, because like I haven't specifically spending a lot of time when it comes to augmenting and uploading humans. And by the way, like another kind of adjacent scenario that we like a pursuit of research or research area that we haven't talked about for right reasons, especially genetic modifications and either kind of embryo selection or direct gene editing, which I mean, kind of like a little bit outside of the scope, but it has like very similar, perhaps milder threats and opportunities than augmentation and brain uploads have. So that's another interesting kind of alternative to keep in mind. Like if you say that you want like augmentation for X, then one question that you have to be prepared to answer is like, why not just like gene edit humans to get that X? Might be safer or might not. Depends on the X.
Yeah. I mean, there are probably a lot of things that you can't simply genetically modify humans to do.
Yeah, but the cool thing though is that it seems to be, like I said, like it seems to be like a milder version of augmentation. Both in opportunities, there are fewer opportunities probably, and but there are also like fewer threats, because in some ways some interesting point that somebody made was that you get humans, you get like a superhumans by just averaging humans. So like I guess I'm not an expert, so like it sounds plausible. I mean, the fact is that like if you average human faces, they become attractive, which is like interesting phenomenon, which basically you smooth away the irregularity, so they cancel out, and you get like really nice attractive faces. So it's, and for similar reasons, like when you average humans, you get rid of the deleterious alleles. So and the deleterious alleles are basically some things that keep us from our potential. So in that sense, it's just like what could be like. It seems like not so drastic thing to just start averaging humans. Like in some ways, we naturally do that anyway. That's
what communities, organizations, and companies do by combining a bunch of humans together in some structure?
In an abstract sense, yes. But I think that's like a fairly different sense of averaging. Basically, you're not averaging humans. You're aggregating humans.
Yeah. I was wondering how that compares with averaging. I mean,
but averaging. That was just pointing to the specific thing that like the low-hanging fruits in gene editing are actually sound pretty good. It's just like just get rid of the bad stuff, and like why not? Like but like of course then you can go beyond, and then you have all this like uncanny valley.
Yeah, that's true. Yeah. Okay, so then let me get to my final question for you, which is really the question about action. If you want to, and as I know you do, you want to see to it that humanity can maximize sort of its long-term chances for survival and thriving, optionality, as you call it. What is it that humanity as a whole should do, say decision makers or individuals as well?
Yeah, I think coordination and cooperation, more coordination, more cooperation seems to be like really good. A lot of the problems. I mean, one of my favorite essays is Meditations on Moloch by Scott Alexander and Slate Codex. And like it's a book-length essay about coordination problems.
Mhm.
Where, like a lot of the problems that humanity has, they can be just summed up as their coordination problems and bad mesh equilibriums. So yeah, figuring out how to cooperate more, because and like realizing how much there is at stake. Like if you think that like if you're kind of used to there being like I don't know, the world is at stake, then like just don't forget that like planet Earth is just like a tiny speck in the universe. I mean, Eric Flexer, although like he doesn't like the fact that he likes the he doesn't. Eric Flexer has an interesting point, which I'm going to ruin now by saying that he doesn't like his ideas to be associated with him because he thinks that ideas spread better if they're not associated with any person. So like there's this idea from somewhere that Paretotopia, where you have basically you're building utopia with this additional constraint that every step should be like a Pareto improvement. It should like shouldn't make anyone's situation worse. Like I mean, there are some like pathological cases, like somebody just like wants to be the king of the.
But you know, that's not always how solving a difficult error landscape works, right? Sometimes you have to nail down.
But the interesting thing is that like we do have like this additional resource that most people are not aware of, which is the rest of the universe, and the pie is just like so vastly more bigger than anyone who's playing kind of zero-sum games and kind of defecting.
Well, that totally makes sense if the pain point that people feel is resources, which it is currently. But I mean, there are other possible pain points, like we talked about. What if if there is a change in some set of or subset of people, and that is somehow different, and there could be some pressures that are experienced as painful to some other subset of people. So these sorts of pain points, if you want to avoid all of those as well, that can be difficult.
Yeah. So like more general, like there are some like values that are zero sum in some sense. So like those values are going to be problem no matter how much resources we have. So the idea is to kind of like try to satisfy them by kind of segregation. Like everyone who wants to be the king of the world can have their own world in
their own planet. Yeah.
Yeah, their own planet. So like and like just accept the meta value that like other. You shouldn't kind of have like increased optionality. You're going to have like way more optionality than you have now, way more resources than you have now, way better future than even considered. It's just not going to be like relatively good compared to others. Like everyone else is also having a great time.
Yeah, but pointing to the universe, one big important thing that you've mentioned there is perspective, because in addition to cooperation, I think perspective is extremely important.
Yeah.
Having a good perspective on what's really going on, not just being focused on what you think is super important right at this very moment. And that I think is, I think that's a big problem is long-term thinking is not very common.
So that's
and probably because our lives are short,
That's one of the reasons why I'm being like somewhat cautiously, but still pushing the AI risk as framing it more like an environmental risk than social risk, because like social risks, if you say that like AI could be like really bad for society, which is true, it also creates like really bad competitive intuitions in people. It's like, I want like my social values trump over like Chinese social values, and that's just not great. It's way better to frame it as a problem that we have in common, and like environment is like one thing that we have in common. So that in that sense, like that framing is better, I think.
So framing could be an important thing to work on.
Yeah,
better frame problems. Yeah. Okay. Well, thank you. This was extremely interesting, and as I mentioned very much at the beginning, we could have gone off for hours in just one direction, like how do you think about good or something like that. So that was wonderful. Thank you. Thank you so much.
Thank you very much.
Okay.
And good luck.
Stop recording now.
Yay.
All right. Can everybody hear me?
Yep.
Okay. Now I have the screen sharing off. Sorry for my audio going out randomly like that. That was a really interesting interview. I liked it a lot. We're going to follow this up with our first panel discussion. These questions are going to be in relation to the Jan Tallinn interview that we just watched. But after that, we're going to take a short break and we will resume at 1 p.m. Pacific time for our general panel discussion. Again, you can ask questions directly in the Livestream YouTube channel, or you can call in at call.carboncopies.org or call the number 415-455-3017. This information is also on our events page. Before we open to questions, our panelists will have an opportunity to discuss the interview and our workshop topic, and then we will move to our questions. Our panelists today are Dr. Randall Kuna, Dr. Abulfaz Alipour, and Dr. Keith Wiley. I already introduced Dr. Kuna, but again, he's our founder and chairman for Carboncopies, and he's known for his efforts to advance research in whole brain emulation. Dr. Alipour has his PhD in pharmacy and is pursuing a double PhD in psychology and neuroscience at Indiana University, Bloomington. In his research, he is developing new neural network architectures that are inspired by cortical column circuitry, and he is testing their predictions through large-scale in vitro neural recording. Dr. Wiley has his PhD in computer science, and he has expertise in artificial intelligence, evolutionary algorithms, various artificial intelligence techniques, and machine learning. He is also author of the book, A Taxonomy and Metaphysics of Mind Uploading, which is available on Amazon. Welcome, panelists. Thank you for joining me.
Yeah, thank you, Mallory. So just to add to the things you've already said. By the way, could you mute yourself? Or can everyone mute themselves when someone else is speaking, just in case? Okay, there we go. Then we don't have an echo.
There we go.
Yeah. Mallory, you're not muted at the moment. I don't know. Well, anyway, it doesn't show up as muted, but you probably have a different mute button on your headphones or something. So just to add quickly here, I don't see Abulfaz Alipour on the Hangouts yet. So I'm assuming that he hasn't logged into that. That's not a problem. He can join. And there he comes. He's joining right now. And just so you all know, there are a few other people from the Carboncopies Foundation who are also logged into the Hangouts. And you guys, you're all welcome to directly participate as well, of course, just like our viewers who can call into that phone number or use call.carboncopies.org. I wanted to just quickly say, there are a bunch of questions that came in from the audience, and we're going to try to get to as many of them as we can. Some questions can be a little bit difficult in the sense that we may not understand exactly what you meant in your question, and so we might answer it the wrong way. If you want to be sure that we get it right, that's where calling in, either using the phone number or call.carboncopies.org, is an excellent way to prevent that problem. Because, you know, if you hear us getting it wrong after you've asked us the question yourself, you can just correct us and say, no, I really meant this. Could you please answer that question? So there's a slight advantage over typing it into the live stream chat. Okay, with that, I just wanted to throw out a first question or present this to the panel. One of the things that, that we got into in that conversation is we really started talking a bit about what does it mean to have a good outcome for humans? Because when we talk about AI risk, you know, I guess the simple version is where you assume that AI becomes smart and then there's a Terminator scenario and all the humans get destroyed. That's the science fiction version of AI risk. But that's not the only outcome you could have. You can have an outcome where AI is simply going about its business and it just, you know, humanity is just this tiny little thing in the corner that doesn't have much to do with it anymore. We don't participate much in their exploration of space. They just kind of keep us alive in a zoo, you might well say, right? And then the question is this a good outcome? And people may have different views on that because, okay, humans are still alive. Our society still exists. Maybe we don't have all that optionality that Jan was talking about. But maybe if you look at it from the point of view of a whole intelligence ecosystem instead of what are the humans doing, maybe some people still think that's good. So determining what a successful or good outcome is can be the first thing you have to do. And I'm wondering what the people on the panel think about what is a good outcome for us and why.
Am I coming through? Well, so with regard to this sort of preference to sort of protect our specialness and therefore sort of make sure that we don't get pushed into a sort of corner of obsolescence or something, you know, you could reframe that question as, what if we discovered eventually that there actually are you know, other intelligent you know, species in the universe, which is you know, a popular position. It's actually not one of my preferred positions, but you know, if we found that was true and we found out that they were sufficiently, you know, pretty far advanced beyond us, then we would have the exact same feeling of mediocrity. It would be like, oh, well, okay, we're just some podunk, relatively dumb, intelligent species in a corner of the galaxy. You know, so then the prescription would be, oh, well, to preserve our specialness, we need to somehow keep those aliens down or something. So barring the technical challenge of sort of countering some alien species that's already ahead of us, it just sort of is philosophically unconvincing. Like, why is the solution to our bruised ego to go sort of crush all the other aliens out there that have gone further than us? So then if you rephrase that, you know, like, then it's like, okay, so now do we have a good motivation to try to prevent AI or you know, sort of enhanced versions of humanity from coming into being? Does that rationale really make any sense when you look at it the way that I just phrased it?
Yeah, I see what you mean. Before I try to answer that, I was wondering if anyone else on the panel has an opinion.
No specific opinion on this particular topic.
Okay. Yeah, I'm, you know, I try to grapple with this question as well, because of course, when we talk about whole brain emulation, we're talking about changes to that, at least optional changes that some people could choose for themselves. It could be that we all go in different directions, that some people develop in one way and others in another. And in the end, if you look at the end result, again, just like what Keith was saying, this could look just like bumping into aliens, with the only difference being that there's this common origin. And then you start wondering about things like, you know, the rate of change. Does it matter how quickly we sort of develop into lots of different kinds of intelligences? So, you know, all of this is hard to pin down, and it's hard for us to determine in advance, before we've thought through all these questions, what are the criteria, the parameters that that we think are valuable or important about humanity and what we've accomplished, that we say this is why we should all survive. You know, this is why either humans as they are now, biological humans, should continue to exist into the future, or at least minds that think like humans to some degree, or whatever intelligence evolves needs to be derived from the way we're thinking because of certain values that we think are really important and that we want to carry them over. Or we could just say, well, this is all way too analytical, and ultimately it's just the drive to continue to exist. And as long as we feel that whatever is happening is because we choose to do it, then it's us, and therefore, yeah, it's okay. That's success. And if whatever's happening to us is not something we've chosen, then it's not success. But as you'll see later when I talk to Anders Sandberg, that isn't quite as simple either. That this, you know, when are you in control? Anyway, so yeah, that was that question. Does anyone else have a question from the panel about Jan's conversation before I bring up another one, or before we go to an audience question?
Sorry, nothing comes to mind.
Okay. Yeah, so I think we'll switch to an audience question in just a moment. I want to throw one more question out there before we do that. And the one I want to put out is, towards the end of the conversation, Jan mentioned that another issue we should look at is biologically enhanced humans, or that whole other different technology, not using computers, not uploading, but what happens if we can genetically modify to achieve whatever augmentation we want. And I'm wondering, does anyone here have an opinion about what that means, either in terms of being a risk or a benefit in itself? How does that compare to something like AGI and whole brain emulation? What do you think about this biology as the root?
So are you referring to when he was talking about the sort of hopelessness of trying to bring horses up to competition with cars?
There was that, but then, he said that, and then at the end he kind of switched back and said, well, another thing that we should really not forget about when we're looking at, we're trying to plan ahead for humanity, is we should also look at the biological augmentation angle, because, a lot of things might be achieved that way.
Well, I think my response would be the same thing that he said about the horse, which is that there are certainly, there's no particular reason to think that blind evolution has converged on some sort of biological maxima. We just are kind of whatever evolution was able to cobble together on what's called a local optima. So we're good at what we are, but in the space of all possible DNA configurations, there's very little chance that we're as good as we could be. But it's still seriously worth considering whether we believe that biology has any capacity to compete with non-biology in the long run. Right now, there are many ways in which biology is the better technology, and in that sense, I just describe biology as sort of successful nanotechnology. But once you sort of escape the sort of protein and lipid and sort of need for water, and once you kind of remove those biological variables that are incidental to what you're really trying to accomplish, but they're required at the chemistry level, then it's hard to believe that biology is really buying you anything intrinsic. Biology is just how we do it. It's how nature does it. It's how evolution does it. But there's no reason to think that it's really competitive. And we have all sorts of evidence that points that way. So our relatively simplistic 20th century computers on certain metrics just outperform biology in ways that are really, there's no conversation to have about it. And I'm not convinced that won't be the pattern for everything as technology sort of scoots along eventually. I can't see an obvious counterexample where biology has to be better than just going at a problem without having a preference for a particular solution. Instead of leaning toward biology or leaning toward the full space of all possible physics and chemistry, I'm doubtful that biology is going to win very many of those races.
Yeah, and I agree with Keith, because from the AI standpoint, I totally agree with the horse analogy of that was discussed before, and I think it would be somehow meaningless sometimes to think it like that as a method to catch up with AI. But from another perspective, if you think of non-destructive whole brain emulation, you would eventually need some sort of a brain-computer interface or some sort of a neuroprosthetic to transfer information from biological brains to some artificial medium. And I think from that perspective, BCI neuroprosthetic is extremely important. But from arguing for advancement of BCI and calling for more attention to BCI or neuroprosthetics, because in order to catch up with AI, I think that would be a little bit improbable or implausible, at least.
Okay. Yeah, I think those are all really good points. And yes, Keith, as you mentioned, I think you're right. What Jan was basically alluding to was the idea that you can look at biology as getting to the point of what you might accomplish with some nanotechnology. In a sense, it is nanotechnology. But yes, as you both pointed out as well, there are limitations to that. So I noticed that I've sort of taken on the kind of moderator role in this bit of the panel. I'm sorry about that, Mallory. You can always jump in and do that if you want to.
All right. Are we going to be moving to audience questions now? Okay. So the first audience question that we're going to ask is from Leslie Seymour. He asks, Skype moved voice and multimedia communication from conventional POTS to open protocol, scalable internet with firewalls and similar security architecture constructs. Do you see any similar changes, at least at the metaphoric level, when the internet payload content reaches the wet brain directly? Could somebody maybe rephrase that question or can answer to that or has knowledge pertaining to that question?
I can try, but I'd love to let someone else have a first go at it.
I'm still thinking, and I spoke first last time. You go.
Abul Fazl, how about you?
So if I understand this correctly, the question is, what would happen if you are able to connect so in a super simplistic way, and correct me if I'm wrong, it would be, what would happen if you're able to connect a search engine into your brain? And do you agree that that would be a simplified version of this question?
Yeah, I'm not 100% sure. This is where, as I said, if people asking questions were on our call line, it would make it easy for them to clarify. A little easier than typing into the chat there.
I'm sorry. I'm curious.
Maybe you're right.
If Leslie,
yeah.
I'm curious if Leslie is asking about. Sorry.
Oh yeah, sure. Go ahead, Keith. Sorry.
I'm curious if he's asking about the benefits of sort of open source or open standards as opposed to walled garden approaches to security. I completely forgot what the acronym POTS stands for. I'm trying to just read that. At any rate, I certainly think that there is, in most cases, security is better served by open standards that embody secure algorithms, sort of like the way public encryption works, as opposed to security that is achieved by trying to make sure that, oh, thank you, Rose, for decrypting that algorithm, that acronym. As opposed to security that basically depends on making sure that that no one even knows how your security works, and that is the method of security. That's an inherently weak form of security. So, one thing that we definitely have to take very seriously as technology becomes ever increasingly incorporated into our brains is we've really got to get security right in a way that we have clearly completely failed at in the last 30 to 50 years. When I was in graduate school, one of the professors who I was inspired by in terms of artificial life, one of the people who sort of drew me to the school I chose was David Ackley. And he was interested in computer security, and he had, since he was one of the pioneers of artificial life, his approach to it was very sort of evolutionarily inspired. And he and Stephanie Forrest and others at the University of New Mexico took an approach to computer security that was intentionally inspired by biological immune systems. And I think we have seen some of these analogies crop up in our sort of attempts to build these sort of auto-adaptive, sort of self-monitoring, on-the-fly security systems. We do sort of try to do some of this in the modern era, but I'm not sure if we have a very refined sort of underlying philosophy for how we do it. But just to get back to the original question, I think that as this becomes increasingly incorporated into our bodies, it will just become that much more serious, just because it'll put lives more directly at risk. We're already concerned about hacking, pacemakers and Parkinson's brain implants, and this is just going to become more and more serious as time goes on.
And just to add to that, so imagining that the question was, what would happen if you have brain implants, and what would you do to secure the communication in these brain implants? So I was actually, when you talk to people about brain implants, one of the common concerns is that how would you secure that brain implant? How would you make sure that someone cannot upload some virus or some bad software into my brain implant, or someone could basically hijack my brain implants? And I think possible approaches to this challenge might be to use, so one possible idea would be to use some sort of a distributed ledger technology that is currently developing for Internet of Things devices, and one other approach would be to use quantum switch. But the way I think about it, I think at the moment, one possible viable option to secure communication in brain implants would be to use some sort of a distributed ledger technology. That's what I think about it.
Okay. It looks like the person who asked the question, Leslie Seymour, is actually trying to call in at this time. So maybe he's going to be able to clarify his question in person, which would be very useful.
Yeah.
I'm not sure he's ready yet, but we'll see in just a moment.
Is that the phone number he's attempting to use supposed to go into the Uber conference?
It goes into the Uber conference, which Alan can then connect directly to our Hangouts. I'm not hearing him yet, so I'm assuming that Alan hasn't.
And
one second, I will just let them know that you're on.
Oh. And we have Leslie, who had a question from the audience. He's here live on the call now. Go ahead, Leslie.
All right, Leslie. So how it'll work is that they will just one of them.
I'm afraid the audio just cut out. Couldn't hear it.
I think she's just explaining to him how it'll work, and then he'll be on.
Okay.
Leslie's live on the air.
Leslie, can you hear us?
I didn't mute Leslie. Oh, sorry, Leslie.
Can you hear me?
Now we can. Thank you.
All right.
Hello?
Yes, we can hear you now, Leslie.
Hello?
Hello?
So you can hear me, right? You can hear me, right?
Yes, we can hear you.
Okay, so I believe that
Leslie, can you hear us?
I didn't mute Leslie.
Leslie, if you just stop the YouTube that you're watching, then you'll be able to just hear us, and then you can join it back in on the live stream once you're off the call.
Okay, why don't I try again? So if you just stop the YouTube that you're watching, then you'll be able to just hear it, and then you can join it back in on the live stream once you're off. Okay, I'm gonna try it. Okay, I have no YouTube.
All right.
I assume you can hear me.
We can hear you just fine.
So a simplified model would be that we have a brain implant or something, some neuro dust or something. So you got some sort of the infrastructure, and so the question is, there are two questions. One is how to protect it from direct interference, just like when you have a cell phone, right? You make sure that no one is listening, no one can inject any information as the wireless signal goes up. Now in this case, it's not a wireless, maybe a wireless signal, but the signal is basically translated from neural signals, internal neural signals. And at the infrastructure side, there will be an agent, I would assume, which represents you as a person, and that agent is intercepting your brain to infrastructure communication. So that brings up basically two major questions. One is how to protect the pipe between your brain and the agent and in the cloud or whatever they are going to have at that time. And the other question is how the agents of different people communicate to one another. So what would be, so it seems to me that just following the paradigm that the telecommunication industry is following, all of these protocols are standardized, or I would expect that when it becomes reality, there will be a standardization effort. And really how secure your brain will be, it's basically will depend on the quality of the protocol and the firewalls in between those agents. And if there are any central servers where all the agents are talking to, how that central server is protected, or something equivalent, some blockchain or something that's going to replace the central server. So basically the question was kind of poking other people's ideas that what kind of systems architecture arrangements with someone envision. I didn't see any of these issues being addressed, not even in the list of question level, in the futuristic communities that investigate the merger of AI and wet brain. So basically that was the intention. If anyone has any kind of vision that what would be the roadmap and how the whole architecture would be regulated by the industry, similarly to all the telecommunications standard bodies that operate today with a conventional and IP-based communication.
Okay. So Leslie, I hope you can hear me as I'm responding. I don't know how the sound is going back with Alan's trick, if you hear it straight through.
How much of it was transmitted and understood?
You came through fine on my end anyway. Some people are saying that they heard a lot of echo, but I didn't hear that. So maybe this is.
Hello.
I'm hearing you fine. Can you hear me?
Hello.
I think that Leslie. I don't know how the sound goes back to the Uber conference, Alan. If that's
he should be able to hear you directly, so we can talk to him, and you can.
So you don't need to. He doesn't need to turn on the live stream or something to be able to hear me, right?
No, he should be able to hear you. So I don't know why not, but Well, it came through well, so if you want to ask the question.
In any case, I will try to address the question. So you're right, Leslie, that the question of safety for the communication protocol when you build a BCI, or the safety of a whole brain emulation in an ecosystem of AI, that problem was not addressed clearly, at least so far in this workshop. And it also, to my knowledge, hasn't been addressed very clearly or explicitly by most of the talking points or the writing that's come out of the AI safety community. And I think that's partly because they sort of constrain themselves to the problem of what to do about the intelligence of the AI and the possible dangerous runaway scenarios of that. Whereas this other problem, you can kind of set that aside and say, well, this is a problem for the encryption community, because this is all about data paths and encrypting that and about not letting people hack your brain. It's easy to dismiss it, and I don't think it should be dismissed, because it's clearly not simple. All of our systems today are pretty, hackable. Hardly any of them are foolproof. So I can only say that, in my own background, I did some encryption stuff because, information theory, you learn about that sort of thing to some degree. And back then, the professors were all saying, well, even though our systems are not foolproof today, in theory, you could make them all pretty unhackable. And now add on top of that blockchain, which didn't exist back then, maybe that would make it even better. I'm not sure, because at this point, I'm no longer, I couldn't call myself an expert in that area. All I know is that it's definitely an issue because currently everything seems pretty hackable, or a lot of things do. And that's going to make a big difference to how secure people feel, in the sense that, okay, I want to connect myself to this machine out there, to these other agents, or I want to have my brain emulated and be an upload. And these agents, again, how those agents represent us and how they communicate, and whether those could be faked and other things like that. This is additional problems and hurdles you could have there. It sounds to me like just the general problem that people try to hack and misuse every technology out there. And in the future, it might not just be people trying to do that. It could be other intelligences, other AI, trying to do the same thing too, trying to use it to their purposes. So every little point needs to be, be analyzed in that sense. And maybe this is why going to open standards is, where you end up, because then you have the most people paying attention to at least one protocol and trying to get it right, instead of lots of people having their own little thing and each of them being very breakable, not getting enough attention, discovering all the holes. So I think something that standardizes is probably, it's what you would typically see. So in that sense, wrapping all the way around, my answer to your question would be, yeah, I think it would probably go in a similar direction that way. I don't know if this answers your question, because it is a complicated question. It's not really in my domain, but that was my attempt. If anyone else wants to make an attempt, please go ahead.
Go ahead.
Okay, I just want to say that I agree with Randall, and nothing is 100% foolproof, unhackable, and there's always a concern, and it would be much better if we have a system that defines a standard and everyone is using that. That would be much more helpful. Yeah, I'm looking forward to hear what you think, Keith. Yeah.
Right. Well, we're sort of mirroring each other. I would just reiterate, it has been, I think it even was mentioned, I think Leslie mentioned it, that, in theory, there are notions of quantum security. There are notions of security in which, even if you can't prevent someone from breaking in or listening in, you can make it possible to detect that it has occurred. Even if you can't prevent someone from breaking in without also breaking your own channel, you can make it so that if someone breaks in, the whole thing collapses, so that at least, again, they don't succeed, and then you can rebuild afterwards. There are all sorts of approaches we have all become sort of jaded in the last decade or two. You know, every time someone says that they've got a new approach to security that's going to solve all the problems, we learn that that's not true. I think quantum mechanics is trying to bring a whole new level of confidence to that discussion, but for my part, I've just kind of lost confidence in the whole thing, which is why I go back to what I said earlier. The research that was being done sort of around my graduate department, although not directly by me, was to sort of accept that security is not a perfect thing. Just the way your body's security is not a perfect thing. You are subject to viral and bacterial and parasitic attacks all the time. And evolution's solution was not to ever attempt to evolve the sort of metaphor of an ironclad wall. Instead, it detects and responds and reacts and fights back and just sort of does its best. And the truth is, it doesn't always work. Things that attack biology sometimes get through and kill you in various ways, but that is what the system attempts to do. It just attempts to detect, adapt, and fight. And I think that ultimately the right approach to security is to be adaptive. And we're just going to have to make our computers, and especially our computer bio interfaces and everything like that, we're going to have to abandon this idea of a mathematically perfect system. And that'll be very hard for society in general to come to terms with, because we need our bank accounts to be, not some sort of computer version of.
I think we might have lost Keith there.
Yeah, that's too bad. But it gives me an opportunity. Oh,
he's back.
Yeah. No,
sorry, Keith, we lost you for a second. Maybe you want to repeat what you said the last half minute or so.
Oh, well, I was wandering around aimlessly anyway. But yeah, I was just wrapping up that we really do have to accept the idea of these computerized immune systems that detect, adapt, and fight, and sometimes lose, but that the war wages on even if the occasional battle is lost, and that is our overarching philosophy to computer security. And I don't think we're there yet. I don't think our society is ready for that. I was saying I don't.
Yeah, I want to quickly latch onto that.
Entities is going to allow us to do that.
So first of all, I wanted to say, Keith, that answer was probably the most lucid answer of the lot, and thank you very much for saying all this. I wanted to latch onto it because when you mentioned, you have to come to terms with the fact that nothing is going to be a perfect solution for security, and you sort of have to learn to live with that, but society may not be ready for it. Suddenly, on a meta level, I'm seeing this as something we may encounter with the whole AI security or AI safety issue, which is that the attempt to analytically figure out AI safety, which is really what the FHI, the FLI, MIRI, and others are trying to do, is an analytic approach to how do we accomplish AI safety. It may be that ultimately we'll discover that it's always going to be the same thing as this immune system approach, where there is no perfect solution. It doesn't constantly work, and you may just have to come to terms with that, just like in security and communication. So maybe this applies to the bigger topic as well.
Okay, I think that kind of concludes the answers for that questions, unless there was anyone that wanted to add anything else on our panel. Doesn't sound like it, so I'll move on to the next question. This is from Ree Rose. She asks, BCI technology could be very positive and enhancing. How do we prevent potential malicious usage and unintentional consequences? And I think that kind of wraps back around to what we were just discussing. She goes on to say, for example, control of a person's mood, voting, consumer preferences, etc. But I'd also like to add, what about indirect control, such as when we have the kind of controversy we have right now with people's data being available and that being used for marketing campaigns and targeting people specifically directly for certain things, if that's going to be an issue once we're able to upload our brains, and there's some way that could be accessible. And I also just wanted to mention I am incorrect about us taking our break. We're actually going to be taking our break at 1:45 and then coming back at 2 p.m. Pacific time.
Okay, yeah, thanks for that correction. I'll take a quick first stab at this. And yeah, thanks for broadening this from just looking at how do you make sure that there's no malicious, say, signals going into the brain or that your signals are being misrepresented outward. But even what Mallory was saying, how about control of a person's mood? This is actually part of Rose's question too. How about control of a person's mood and that sort of thing? And I think it's very closely related to Leslie's question in the sense that ultimately it's a security problem. It's a matter of who, what are the rights that we bestow first of all when we have these systems. Like when we started messing around with DNA, there was the same sort of question. What are the laws going to be about this? How can you use someone's DNA? Are you allowed to use a person's DNA without their explicit consent? And if they give their consent, do they really know what they're giving consent to? Similarly, when you talk about brain-computer interfaces, you're going to want to have informed users. And the person using it is going to have to have a fairly good understanding of the security that they've got coming along with that, and that security has to be pretty good, very good, in fact. But in addition to that, there are all these indirect ways that that people might find that there is some control seeping in from elsewhere that they wouldn't want. If you can give somebody images directly into the brain, for instance, if you can put them into a virtual reality of sorts, there's the potential that virtual reality can be shaped by those who create those programs, and that can influence what a person thinks, and it can be very subtle. Now, the same sort of thing, of course, is happening today with advertising and political campaigns and all the rest, and the whole concept of fake news and all of this. So it's not a completely new question. It just becomes more pressing when you're so much more directly connected. And so it's not just the question of security and protocols. It's also a question of having laws that people and agreements they have to make, and education, understanding what those agreements actually mean and what you can think that you are, how secure you are and how secure you aren't. So this happens today, even on the internet. People don't realize how easy it is to fall for something. Say you receive an email, what happens if I click on this link? So the informed user is the safer user. So education is going to be an important part. I know this doesn't sound like a perfectly technical solution to everything. A lot of it's kind of messy and requires bringing a lot of people up to speed and all of that. But I think that's exactly how it's going to be. It's going to be a bit messy. And the only good thing about this, assuming that not everything goes boom, is that hopefully we won't have to adapt to everything all at once. Hopefully it's a stepwise process. First, some people are going to get, say an artificial retina, or if they're a locked-in patient, they'll have some way of controlling, their new robotic exoskeleton, something like that. And those are some fairly limited paths through which communication happens. And you can figure out how to safeguard that and explain to the user how to use it. And then we become used to those sorts of things. And then it moves to the next level where maybe people have brain-to-brain communication of a kind. And first it's a thin channel, and there are ways to secure that. And then that becomes a broader channel where more is possible. And they've already learned to live with it to a degree. So hopefully this gradual and iterative process allows for the learning that we all have to do to make it happen. Anyway, I'll leave this to someone else now.
I just wanted to add to what you said, and I think there are interesting, promising technologies on the horizon. As I talked about before, a little bit about the distributed ledger technology. So, for example, blockchain is an example that is immutable. You cannot change it. So I believe that in the coming years, with the advent of Web 3.0, with the Internet of Things taking over and becoming more and more prevalent, I think there might be technical solutions for these concerns and these problems that not 100%, but to a good extent, they're covering all these different issues that we're dealing with. For example, controlling someone's mood or voting and consumer preference and all these different hot topics that we have to consider when we want to think about neuroprosthetics. For example, imagine that I have a neuroprosthetic that is for depression, for people who have depression, and then what happens if someone can hack into that, and instead of making someone better, just worsen their condition? So how would we secure that? I think one technical answer to that would be to look into the common technologies like something like Hashgraph or IOTA's Tangle technology, the DAC technology that is coming. And I think that might provide interesting solutions to deal with these problems. Yeah.
That's, I totally agree that there are probably a lot of new solutions coming down the pipeline, but I'd like to caution that, just because something seems hot right now, since it hasn't been used much yet, we don't really know what all of its holes are, and some of them can be insidious. So take, for example, what you just said about, the person who's receiving treatment for depression.
Mm-hmm.
Now, let's assume that there are 20 million people in the world who are receiving the same treatment, and there's a company that's providing this. Now, the company, therefore, has probably got some data about how often each of these people are receiving their treatment. And the user may have signed an agreement where they said that the company is allowed to use this data to improve their services or something like that. And they interpret that to mean that they can use that to improve services to these people, but not just for their treatment, but also to sell it to advertisers to send them stuff that's good for people with depression. So again, you've created a loophole here where, some unexpected things might start to happen. You might suddenly notice that all of the, advertisements that are popping up for you, they're all based around depression, but they might even be subtle advertisements where they're not directly about depression. They're just advertising things that typically appeal to someone who happens to be going through depression at certain times of the day. And strange stuff like that. So it can be very hard to locate all of the problems in advance. That's where I think the analytical approach fails, and it has to be this iterative learning approach for how do we really safeguard what we're going through right now.
Yes, that's correct. I totally agree with that.
Okay, it sounds like we're done with that question. The next question that I have is from Alexei Potapov. I don't think I'm pronouncing that correctly, but he asks, why are we so concerned about AI threats while staying in the body is 100% fatal? Should we better discuss whole brain emulation in a context of mind uploading or evidence-based cryonics? And I think maybe what he's asking is, why are we so concerned with artificial intelligence safety when there are still issues to be solved with mortality? I'm not sure if I'm interpreting that correctly or not.
Well, hopefully we were interpreting it correctly, but he could of course call in to call.carboncopies.org if he wants to elucidate further.
If you'd like to clarify on the YouTube channel, we can also look at that.
So, yeah. I mean, there's one obvious way in which the question of AI threats is relevant, even though biology is sort of the guaranteed death we're all sort of thinking about solving, although it's not necessarily my primary motive in mind uploading. But the obvious response is that people, how do I phrase it? Everyone's concerned that AI might end not only your life but end humanity. So if it's a choice between letting humanity continue to hobble along for a few more centuries while we slowly figure this out, and accidentally, creating some existential, sort of, eliminative event, then clearly the choice would be, okay, let's not go straight at AI now, even though it's tempting. Let's just, keep hobbling along with our 100-year lifespans or 60-year lifespans or whatever, and let our technology get to the point where we can do AI without wiping humanity out. I think that's the obvious sort of go-to response there.
Yeah, I would agree with that obvious response. And just to sort of emphasize the second part of his question, shouldn't we be discussing whole brain emulation in the context of mind uploading or evidence-based cryonics? Yes, of course. And that's what we normally do. Say, for instance, in our previous workshops, that's exactly what we did. We talk about the technology to get to mind uploading, which is, whole brain emulation of one sort or another, and the different paths that go there. We've talked about ways to work with preserved brains and how to get to whole brain emulation. And then we've expanded that to look at a few other topics as well. So I don't know if you were there when I was giving my opening remarks, and I pointed out that this is a big puzzle, and we keep adding in more pieces, and our workshops are trying to address a whole bunch of them eventually. So now we're trying to address this overlap area where AI safety and whole brain emulation may interact. And that's an acknowledgement of the fact that, yes, we personally may be, we may really care about whole brain emulation as a technology, either because we think it's super important for individual people, or we think it's super important for, humanity as a whole. But we have to acknowledge that you're not working in a vacuum. If we create whole brain emulation, if we're doing the research towards whole brain emulation, the things that happen because we're doing that work may interact with the other things that are happening around us, say in the world of AI development and where that goes. And that altogether can have an effect on where we all end up. So the outcome isn't just dependent on our thinking about mind uploading and cryonics. So I think that's why we're trying to, find these corner situations, these tangential things, these places where domains overlap, and to think about that as well.
And from another perspective, I think it's still important to think about AI threats. So let's, in an imaginary scenario, let's imagine that we have the first whole brain emulation, and that one becomes an AI threat by itself, and it takes over, and it makes it impossible for everyone else to perform the whole brain emulation. And so it wipes out the entire humanity, and that would be the only thing that exists on the planet. So I think still it's really important to consider AI threats, especially when it comes to whole brain emulation. What happens, and I think this is one of the 4 topics of this workshop as well, that whole brain emulation itself would be a runaway AI. And I think from that perspective, it is really important to consider this AI threat topic in whole brain emulation. Yeah.
All right, I think we'll move on to the next question. So let's see. I believe we will do the question from Roman Sitalu. Is whole brain emulation necessary for mind uploading? Could a far simpler model be sufficient to simulate the human mind of a particular person? And I also, just to keep it kind of in the context of our workshop, I'm curious to know if this simpler model would be generated by AI algorithms instead of necessarily completely doing a one-to-one copy of the biological brain.
That's a great way to put an extra spin on it. I'm going to jump in right away because it so happens that there was a part of the upcoming interview with Anders Sandberg that got into this. And this is because, of course, you can make a distinction between a simulation of a person's brain or mind and an emulation, where the distinction we'd make is a simulation is something that to the outside looks like perhaps this is a person reacting the way they should be reacting. But on the inside, perhaps it's really not all the same. There isn't really the same person behind it. It could be more of an actor, And that's precisely where Anders, for instance, pointed out, well, our systems are best when they understand us best. So we can see with a cell phone, for example, that it works better when the interface kind of understands where we're coming from when, let's say, Siri learns something about us or whatever, or Google learns what our likes and dislikes are, and then they can go out and find the things we enjoy. They become our agents, looking for the answers we want to find, or the things we want to buy, and so forth. Now, as you get better and better at that, if you have an AI that keeps on making better predictions of you, at some point, that AI could go out there as an agent and basically pretend to be you and go shop for the right things, invest your money the way you would be doing it, talk to your kids to make sure they feel like you're paying attention to them and all that sort of thing. And it gets to a point where you could say, yeah, there's a pretty good simulation of that person there. But the question is that simulation the same as an emulation? Is something that can pretend to be you and other people won't notice it's not? Is that close enough? Is that good enough? Is that what you're going for? And that wraps right back around to, I guess, what is always the fundamental question that we bring up whenever we talk about whole brain emulation and research towards it, which is, what are the success criteria? What do we mean by mind uploading and whole brain emulation? What is it we want to accomplish? Do we want to make agents that can pretend to be us online? Is that the main purpose? Do we want to create something that can improve us, ourselves, where we have the ability to say, think faster, notice things at a microsecond split interval and react to those things? Do we want to be able to live longer ourselves by being, able to emulate our brains and run as a mind upload in another body, have an artificial brain, as it were, whether you decide to do this by replacing bits one at a time or do a scan the whole preserved brain, or which approach you want to use. So part of the question is always, why is someone interested in it? What is the success criterion they're going for? And so this part of this is reaching a consensus. What do those of us working on it really think the success criteria should be? What are we aiming for? And some of it is perhaps, something you can derive more analytically, where you can say, well, if people are interested in mind uploading, it really only makes sense to go after this if we at least care about X. Otherwise we could just make any old AI or something like that. So there are reasons why we would. Oh, sorry, somebody wants to go on. Okay, I'll finish my thought right now. Okay, next person.
We actually have Roman on the Uber conference line. I think he's going to discuss his question. So we're going to have Roman on now. Oh, actually, he just said his question was answered correctly, so that's great. Is there anyone else that was wanting to add any thoughts to that question?
Yeah, I just wanted okay, go Keith, go ahead.
I'm not sure if I had anything around the safety angle that we're trying to put on it. Randall's very good at phrasing the underlying question here of what's the criteria we want. There are a couple ways in which I've seen this sort of issue come up. There's always the question of philosophical zombies, this notion that if you emulate, well, no, actually that's not the, so philosophical zombies are just, if you, no matter what level you emulate, have you actually sort of achieved the goal of identity, of consciousness, sort of reinvigoration in some metaphysical sense. Of course, the best way to just sort of respond to that quickly is nobody knows, and let's just move on for the time being. Now, there is this other question, and there are companies that have done this. I can't remember if Randall touched on this. There have been companies around for several years now that are sort of trying to get a foot in the door with this sort of, what would you call it? Sort of mind archival. They don't even call it that, but just this notion of, let's capture as rigorous a snapshot of a person's sort of life as possible and see if we can turn that into something that we would call an imperfectly preserved mind and identity. There have been multiple approaches to this. I can't remember where I read this article. There was some guy who he was a journalist, and he interacted with a company that was doing this, and their goal was to basically they would do several things. They would run interviews with you and try to sort of compile this sort of chatbot-like they try to refine a chatbot that responded, increasingly like the person does in an interview. They would scrape your social media profiles to try, or websites, or anything available to try to build as complete a picture as possible of a person. And you can sort of see where this is all going. And then, the larger question is there a fundamental error in the assumption that this is all predicated on? Thank you, Leslie. I see that in the chat, the replica chatbot with a K. Mindfile, Jan. Yes, I remember that name. See, I've been loosely...
Yeah, that's the TerraSem movement, right?
I've been aware of these projects for so long, I've forgotten them now. So we're all, okay, so it sounds like we're all aware of this together. So yes, there are people who have asked the question of whether, you can achieve something like mind and identity preservation, and then the secondary question of whether you can actually achieve any consciousness preservation with these, very high-level kind of black box approaches to what personhood means. You basically take a Turing test approach to the whole thing, which is that a person is just what you can get in and out through the I/O interfaces of the system. So basically, what can you put into it through its eyes, and what can you get out of it through its mouth? And if the patterns are sufficiently like the person, then did we achieve our goal or not? And I'm going to safely say I don't know. But we've been trying to figure this out for a while now. I kind of go over this some in my book, but Randall and I have kicked around the idea of at what level do you perform your your system identification, is the term that Randall may be very familiar with. At what level do you cut your system identification cutoff at, and say, if we don't system identify at this low level, whatever our threshold we choose, then we just say, it's just not good enough. How do we set that threshold if you're really achieving the same behavior eventually? So I don't have an answer to that, but it's definitely a question that people have been thinking about for a while, because that's kind of all I have to say on that.
That was an excellent answer that went into a lot of detail. Yeah, exactly. It's about, what is the good, the level of separation between what you would call a successful upload, having captured what you care about, and all the stuff underneath. Yeah, perfectly said.
Yeah, and just going off of what Keith said, and I think so, yes, we all want to have the simplest program that can preserve the identity of a person. And so one of the things that we need is, as Keith just mentioned, is consciousness. So what is the simplest thing that you can do to preserve consciousness? And that goes back to this idea of scale separation. So should I be able to simulate or emulate all the ionic channels, or should I be able to simulate all the neurons or the brain regions, or at what scale and then at what level I can stop and then say, okay, this is enough to recreate that consciousness or recreate that mental experience, that phenomenal experience. So, and I think we don't know yet, but many neuroscientists may say it's just at the neuronal level. You need to emulate your system, your artificial brain at the neuronal level to be able to recreate that consciousness and preserve the personal identity. But we don't know yet. That's a great question, but no one knows yet.
All right, is there anyone that wants to add anything else to that question? I don't think so. So our next question comes from Vitaly. And I believe this is actually a question that we've kind of addressed before in previous workshops. He asks, how detailed is the emulation of electrochemical processes you intend to use? Subthreshold dendritic potentials, are they taken into account? Are features of spines taken into account? What approaches are used to emulate chemical synapses and neurotransmitters? And one thing that I kind of like to add to that, will we use, as we experiment with whole brain emulation and with going down to different levels of detail, as Vitaly asks in his question, are the insights that we gain from that information going to help with developing artificial intelligence?
Hi, Sarah. I lost it there, so I missed a bit, but I got your question.
Okay.
Very nice. Towards AI. The way I get to this next part where the panel discussion.
I think you're having some connection issues, Randall.
Time is sort of, we should people who are joining now because they want to see that. Me?
Yeah,
okay.
Randall. I'm not sure if it's you, but try again, Randall.
It's me because I lost connector.
Randall, while you're figuring that out, could you mute yourself and maybe we'll have Abulfaz or Keith try to answer that question?
Let's see. I was definitely thinking Randall was the guy for it. Let's see. So the question is, at what neural level do we want to attempt these brain emulations? And of course, no one has decided yet. One of the most popular answers to that question, one that I personally favor, is to take that sort of input-output function I was describing earlier at the action potential level of neurons, which is to say that when you ask about dendritic spines and such in your question, I am, with reservation, actually writing off that requirement. I'm proposing that maybe the better level is the one at which you build a system that can propagate signals through a network in a pattern that is similar to the way that a brain propagates action potentials through a neuron connected network. So whether or not the synapses actually have the exact same properties would be irrelevant so long as the action potentials do actually get through in a statistically similar fashion. That's not to say that that's the right level. It's just one of the more popular levels to go to. I actually personally believe that can't possibly be the level we have to go to, because when people lose neurons from a variety of medical maladies, at least at a low level, it seems to have very little effect on our health and our personality. You can lose a couple of neurons here and there and it doesn't make any difference. I personally suspect that something along the lines of cortical columns or other conglomerations of neurons that we would have to decide what our grouping criteria is, but some sort of unit of groups of neurons that performs a function, and this might be as large as thousands of neurons, like cortical columns, is probably sort of the Lego brick we're looking for in all of this. But again, I don't really put a flag in the sand very deeply on any of this. We don't know. There are, of course, I'll let somebody else speak in a second, but just to quickly, there are definitely people who propose much lower levels. Hammeroff and Penrose are well known for proposing, the microtubule structures inside of neurons, as a critical component of, certainly of consciousness, and then of course, presumably of identity preservation and everything else we're trying to get at. People have taken this as an interpretation that they're against technologies like mind uploading and such, and I believe that they've been cornered in the occasional interview on this and have actually said, no, we're okay with it all, but you do have to take into account, this quantum mechanical requirement that we, Penrose and Hammeroff, are stipulating. So many of us are not actually on board with that requirement, but it just says the same thing. It says, okay, well, there is this level of perfection, sort of inside of atoms that you've got to replicate, or else we're gonna, not say that the process has been successful. So you can make this decision at several levels of abstraction, and surely the right answer at this time in history is we don't know yet.
And yet, just talking about Penrose and Hameroff's orchestrated objective reduction theory, or OR, and the whole bunch of other quantum mind theories out there, I think so. These theories are really interesting, getting consciousness to the molecular level. However, at the time being, these theories have not been able to show a mechanistic description of how this quantum effect or quantum phenomena happens that can give rise to consciousness. For example, Penrose and Hameroff idea had a real big pushback from the neuroscience community about the validity and how it could work in the brain, given its temperature and noisiness and all the other criteria, the other conditions that exist in the brain. And I think, as you mentioned, probably at the neuronal level or at the circuit level, we would find a good enough information so that we could be able to somehow recreate the mental phenomena on an artificial medium.
Okay, since we did say we are going to do Anders' interview at 1:30 Pacific, we're going to go ahead and skip our break and end the panel for now, but we will address any further questions from the audience members in Q&A sections later. So, with that in mind, we will commence with the second part of our workshop, which is the interview with Dr. Anders Sandberg. He is with the Future of Humanity Institute at Oxford University. This interview was conducted by Dr. Randall Kuna. And I'll just have to play it on mine. Unless Allen can play it.
Yeah.
I'm not sure if Allen's going to be playing it.
Allen, if you can, maybe we can give yours a try and see how that one goes.
I'm queuing it up now.
Awesome.
People walking past here on the street, so yeah.
This happens. Yeah. There may be some noises in the background here too. Eventually,
yeah,
but, it shouldn't matter too much.
We can overpower them with our own charisma.
Indeed.
Not seeing it yet, but I can hear it.
Okay, so I'm going to introduce you first, and then we can get into our discussion because we're going to be using this in our event, of course. Okay, let me get started then. Our expert guest for this event is Dr. Anders Sandberg, who also happens to be a longtime friend going back at least to 2007 and the first whole brain emulation workshop that was organized by the Future of Humanity Institute at Oxford, possibly even further than that. Dr. Sandberg worked in computational neuroscience, which means we could geek out about that at length if this were a private fireside chat. Anders is a senior research fellow of the Future of Humanity Institute, of course, impact of future technologies and artificial intelligence and whole brain emulation. He's also an excellent speaker and debater, and as always, I've really been looking forward to this conversation with you. Welcome, Anders. Thanks for agreeing to
Okay. I guess our backup option is not viable, so we'll just go with our original option. So anytime my microphone goes out, I'll just be paying close attention to our chat, and I'll make sure to turn it back on.
shouldn't matter too much.
But we can overpower them with our own charisma.
Indeed. Okay. So I'm going to introduce you first, and then we can get into our discussion, because we're going to be using this in our event, of course. Okay, let me get started then. Our expert guest for this event is Dr. Anders Sandberg, who also happens to be a longtime friend going back at least to 2007 and the first whole brain emulation workshop that was organized by the Future of Humanity Institute at Oxford, possibly even further than that. Dr. Sandberg did his PhD work in computational neuroscience, which means we could geek out about that at length if this were a private fireside chat. Anders is a senior research fellow of the Future of Humanity Institute at Oxford University, and of course he's highly respected in fields of philosophy that deal with existential risk, the impact of future technologies, and artificial intelligence and whole brain emulation. He's also an excellent speaker and debater, and as always, I've really been looking forward to this conversation with you. Welcome, Anders. Thanks for agreeing to do this interview and to try to join in on the Q&A on the day of the event, even though you'll still be returning from travel that day. Thanks.
Well, thank you so much, Randall. This is exciting. It's fun to be not quite here, but communicating.
Right. Yeah. So you're of course familiar with the goals of the Carboncopies Foundation, and I imagine that it's okay. I imagine that you can also see that people who are working on whole brain emulation and people at the Carboncopies Foundation are also really interested in artificial intelligence or artificial general intelligence. Now, we don't very often talk about that in our workshops because there are already so many groups out there that are doing that. But we did feel that the overlap and the interactions or possible interactions between work towards whole brain emulation and work on artificial intelligence is something that hasn't really received sufficient attention yet. So if you don't mind, I'm going to ask you a few questions about your thoughts on AI and about risks and benefits and about this area of interaction. Is that good?
That sounds excellent.
Okay. So you've got a long history of dedicated concern and supporting some serious study on existential risk, and in particular AI risk and AI safety. Could you tell us a little bit about how your thoughts have evolved in that time since you got started?
I vividly remember being on a train ride to Yale University back in the early 2000s, reading Nick Bostrom's recently published paper on existential risk. And I had this knee-jerk reaction. This is preposterous. This is so stupid. This is just going to be used to slow down science, and we need more science and technology more rapidly. And then gradually I became aware that actually that knee-jerk reaction might be a little bit too naive. Gradually I warmed to the idea that actually existential risk is a pretty dominant concern. Not the only super important concern, but certainly it matters a lot. But the problem is, of course, just being concerned is not enough. You need to start picking apart the probabilities, risks, and uncertainties to try to see where can we do the most. There are some risks that we simply cannot budge. Super volcanoes for the moment, for example, there is a finite risk that we all die of natural causes. There is no point in worrying too much about them. The other risks that are relatively intractable, but many people are also working on them, like nuclear war risk. And then there are those risks that are more tractable. And at this point, it gets interesting. If they're neglected but tractable, then you should probably put in more effort, especially since even a small amount of effort, if it's a very tractable risk, can help a lot. So to me, future technologies are interesting because they have a fair bit of tractability simply because we're making up these technologies as we go along. We're inventing and discovering things. And that means that we can also regulate them and safeguard them in various ways. If we're careful, if we make the right choices, which is not always possible.
And besides artificial intelligence and related areas, are there other examples that you would say are areas where we could put in more of an effort than we're doing today? You know, maybe not super volcanoes or something like that, but other areas?
I think biorisks are a good example. So there's certainly a fair bit of people working on pandemics and biosecurity, but many of the emerging biotechnologies probably pose entirely new kinds of risk. And I think it would be a good idea to make a serious inventory of what we might find there and trying to preclude some of those risks. And that might require various forms of disease surveillance and innovative methods of actually stopping, for example, gene drives, etc. And I think this might be true for other technology. One good example is actually quantum computers, which are not an existential risk, but a risk for encryption and privacy. The solution is, of course, quantum safe encryption, which both NSA and Google are trying to develop. And then we need to promulgate it before the quantum computers become too good. We want to have it around for so long that our secrets are kind of safe, because the ones that can be cracked by the quantum computers, well, they're meh by this point.
It's interesting that you mentioned that, because I was just out at South by Southwest, and there was a startup company presenting there. Unfortunately, I didn't catch their talk, and I don't remember their name, but they were explicitly saying that they offer quantum encryption as a way to safeguard your data. Even now, I don't know how they're doing it, but they're out there.
So one interesting thing is that you can, of course, encrypt data using quantum encryption over a communications line. And it's not as easy as people thought, but especially the Chinese have been working very assiduously on developing this. But then you also want to have a quantum safe encryption method, and that might actually not involve any magical quantum computing. But it might be good for your branding if there's quantum in the name anyway. But I think this is going to become more and more urgent.
It's interesting that we're going down this path right now, because that's a great segue into something I wanted to talk about, where Dr. Ben Goertzel is concerned. He's a mutual friend of ours and a researcher in artificial general intelligence. And he sees things a little bit differently than, for example, Nick Bostrom does or Eliezer Yudkowsky does. He wrote a paper in 2005, so it's a few years old now, and the paper was called Superintelligence, Fears, Promises, and Potentials. And it seems one of the things that he explicitly talks about is that that the probability of different risks isn't addressed very well, and it's very hard for us to judge which risk is really the one that we should be paying attention to the most. And then, for example, is it a case where other risks are so great that the potential benefit of artificial general intelligence in helping us prevent those risks that might be on balance more important than, say, worrying too much about the existential risk of AGI itself. So I think you're probably familiar with his thoughts on that, and I was wondering how you would balance those approaches.
So that argument is a bit similar to an argument I heard for trying to send messages to extraterrestrial intelligence. Again, we are under so much risk here, so even though maybe there is some risk of getting unfriendly aliens on the phone, if we get friendly aliens, that might actually save us. Now, if one is really desperate, I think that kind of Hail Mary strategy really might make sense. But I don't think we're necessarily that desperate yet. We got some years until we get the artificial general intelligence, maybe quite a lot of years, and we actually have a decent track record of surviving so far, which might, of course, not indicate that risks are small, but at least that we can do something about it. So I do think that we should do this judgment, but there is quite a lot of things we can do about that. So, for example, demonstrating that on the net AGI is going to be better than no AGI, well, I think that is fairly doable. On the other hand, showing that safe AGI is much easier than dangerous AGI, I think that is going to be tough to demonstrate. I think you are not going to be able to prove that with any rigor.
Okay, but it is still kind of hand-wavy, isn't it? Because you said, for instance, that you don't think we're very desperate in terms of any of those other risks, but are we desperate in terms of the risk of dangerous AGI, right? It's that's the same question.
Well, the thing about right now, when we look at the existential risk to humanity, I think nuclear war still is in the top. And you can even make a Bayesian estimation of naively. We have seen, 73 years of no nuclear war. So if you apply a beta function, etc., you end up with between 0.1 and 1% risk per year, which is disconcerting. Maybe a nuclear war is not an existential risk, but it's still a certain amount of probability that is kind of worrisome. Now, budging that nuclear war risk is important work, but it's also it takes a lot of effort. You want a lot of diplomats, you want a lot of people in peace studies to do their job. Now, AI risk is relatively mobile right now because we're still at a very early stage. A few insights might actually change the risk profile quite a bit. So what I'm arguing is not so much that we know that unfriendly AI is super likely. I know some people who actually think this should be regarded as the default position. I'm not entirely convinced by that argument. They might be right, they might not be right, but I can certainly see that by moving kind of AI safety research earlier in time, we can reduce the risk and probably do quite a bit of useful risk reduction that way.
Mm-hmm. That makes sense, yeah. I mean, if we simply ignored that there was any risk at all and didn't have any people interested in AI safety, that would definitely open up, I guess, bigger potential for the worst case scenarios. I'm sort of curious about both of those things, actually, the worst case scenario and what to do about it, because now we've spoken very abstractly about the risk from AI, and we've also spoken in a very abstract sense about, well, we should do something about that. I'm kind of curious, you know, what do you think is the worst case scenario that should be expected if, say, an unfriendly AGI is developed, and what do you think is the best way to try to prevent this? So if we do have people interested in AI safety, which route do you think is the most promising?
I do think, because I think most scenarios we can imagine, we can start imagining ways around, and I think we could actually have at least some chance of reducing the impact. So I would expect the worst case scenario to be very bad and totally not look at anything I could formulate. So you could imagine a scenario like, well, actually, rapidly and self-enhanced intelligence is possible. So there are some systems that generate that, so you get a fairly hard takeoff with some random utility function, and then it goes off and does something random, but instrumentally very, very competent. So it does everything it needs to prevent us from ever being able to stop it. So now basically you're in the same universe as a force that you cannot by definition stop, and is going to do something that's likely very dramatic. Whether that is taking apart Earth to use the atoms or doing something else, very hard to say. Now, I think it's very likely that we're going to run into other bad AI problems long before this. So in many ways, the worst possible scenario is that AI works really well, and then we improve on it, and it works really well, and it all keeps on going super well until it suddenly just turns super bad. On the other hand, I think it's more realistic to assume that we develop AI, we do stupid mistakes, bad things happen. We fix those. We keep on doing things. We discover new problems. This keeps on iterating and happening. And in the nice scenario, we robustly figure out ways of actually controlling the AI, setting up motivations, and other kinds of safeguards we currently don't understand before we get to the truly dangerous territory. The more scary scenario is, of course, the one where we don't learn anything, but we create incentives to use it. So companies that don't use AI to direct their activity are going to be doing badly on the stock market. So everybody will be using them, and then these systems get more and more powerful, and the world gets crazier and crazier. But if you don't use AI, the craziness crushes you. And then you end up in a world that is not suited for humans, yet nobody has won very much. Now, the ideal scenario is, of course, that we figure out useful things early on and fix that. And in the best of all possible world, maybe there's some simple mathematical theorem that you can prove that gives you a safe AI. And it's also politically very easy to convince everybody that we should be implementing this everywhere. In a more plausible world, it's going to probably be a whole little science of safety, just like we have the safety in a lot of other domains. And this is going to be fairly messy. Just think about computer security, and think about how we're failing at computer security today because the incentives are all wrong. The software companies are not held liable for the insecurity of products, yet we buy them. And the end result is that we have built an entire infrastructure on systems that we can't fully trust, that in fact have enormous glaring security holes. We kind of all know that, and we all choose to ignore it because living without a modern smartphone is not practical.
Mm-hmm. Yeah. Motivations and having holding people accountable, holding companies accountable is really important. So I like that you went into this. What is a more plausible scenario, and sort of looked at all these. It's obviously very difficult to really predict anything because it's so many different routes that are possible. It's very complex to look into the future. But it's you know, that takes us a little bit away from just focusing on you know, something, assuming that the major AGI or AI out there is always going to be something that has a fixed utility function and maximizes the utility function, that's where the danger comes from, whereas the reality might be more messy than that, which I think is also something that Ben touched on in his paper.
And I do think this shows the importance of trying different approaches to AI safety. So while our friends at MIRI are taking a fairly axiomatic approach and are thinking in terms of very fixed structures, around FHI we have some people who are working very much on learning systems. And I'm hoping in the future we're going to see even more approaches, because right now we fully don't understand what the domain is, and we might actually want to combine different approaches or figure out what are the subtle problems with them. And this even includes the people who are working on near-term AI safety. Quite a lot of them are, of course, not terribly fond of talking about AGI and superintelligence. They think that they have enough trouble with their autonomous cars or how to manage drones well, or even getting out the bias of the credit scoring systems. But I do think there is actually a continuum here from very near-term issues about controlling complex adaptive technological systems to the long-term issues. When these systems become essentially autonomous and super powerful, how do we ensure that we already have enough of what counts as the important part of control?
Yeah, we could talk about this forever, basically, because, you know, every single thing that we say brings up another question. So when we say, you know, timelines, you know, how long-term problems versus near-term problems, how long is long-term, all that sort of thing. But, you know, I'm going to try to steer this towards the whole brain emulation topic. So when I discuss whole brain emulation in the context of AI, when I talk to someone about that, then I typically get two very different kinds of reactions. Some people will give me the reaction where they say, I think that whole brain emulation is an important potential safeguard against you know, humanity suffering the worst case scenario from you know, runaway AGI. And others will say, well, you know, that may be true, that there's something to be found in terms of long-term future benefit for humanity, but at the same time, working on whole brain emulation carries its risks in terms of either whole brain emulation itself being a risk, or whole brain emulation somehow accelerating the development of potentially dangerous AI. So I'd like to start talking about that and ask you a few questions about it. Now, I've already talked with Jan Tallinn. He gave an interview as well, which is being presented in the same event. And he was cautiously optimistic. He felt that whole brain emulation research would probably end up being a net positive in terms of existential risk. And he said that he was basing his opinion largely on what he learned from Carl Schulman, who's also at the FHI, isn't he? Yeah, and so clearly we should probably reach out to Carl in our follow-up to this event. But I was wondering, because he mentioned that, what do you think about the level of study that's been done so far on this particular problem of the interaction between AI safety and research on whole brain emulation? And do you think there are specific people who are the leading thinkers in that sort of overlap area that we should be talking to?
Right now, I don't think there have been enough study of this. There have been informal arguments, and in many cases, these informal arguments go back and forth, and a bit based on personal taste. Maybe one has invested a lot of effort in brain emulation, then that is automatically going to bias you towards thinking this is probably pretty safe. I think the core question is how much would progress in neuroscience push AGI and vice versa? Mm-hmm. So one possible argument would be if we do brain emulation, it's not just that we by definition will have a lot of computing power, but we will also have good ways of scanning brains. That directly doesn't help AGI much, but also a good way of modeling and running these scanned neural tissues. And that's going to, long before we get to a human level, give us quite a lot of access.
The audio has been muted, Mallory. Thanks.
Do neuroscientists figure out things by having actually a really good neural model to study?
Working.
And how quickly do they tell the AI researchers who can actually make use of it? So I think empirically the answer seems to be that it actually takes a fair bit of time before neuroscientists understand the neural issues, even if they have good simulations, because it's very complicated and we're not terribly good at figuring it out. As a former computational neuroscientist, I'm kind of embarrassed by how little progress we've been making, despite our models becoming much bigger. But the reason is, of course, we need better ways of understanding. Now, brain emulation is not necessarily based on having a super profound understanding of high-level stuff that would drive AGI. But the most of the scientific interest is going to be about that rather than achieving brain emulation. And even when neuroscientists have found something interesting, like how the reinforcement learning systems of the brain works, or some of the neural representations, it seems to take a fairly long while before the AI researchers pick it up. So if you take, for example, Russell and Norwig's book on AI, and leaf through the chapter about the history of the field and insights that have driven it, you find a long list of interesting neuroscience insights. And then you try to check how many decades it was between people figure it out and it became a part of the AI project, and quite often it's several decades. So if things stay the same, I wouldn't be too worried, because we might be doing the brain emulations and then a few decades later the neuroscientist gets the memo. However, that might change in the future. It might turn out that maybe AI research and neuroscience meld together much more. It might be that actually people like Google DeepMind, who started by people coming from Peter Diane's group in neuroscience, have learned how to read neuroscience paper and actually get useful ideas from it. Or it might. A favorite example might be that maybe the way the cortex organizes information and does online learning, that is really a simple thing once you understand it, and then you can apply it in AI. I don't know how to assign much credence to this, but I think it's worth investigating much more deeply. And we probably need to develop tools to do that.
Yeah. Oh, wow. You covered a lot of ground there. And yeah, this sort of echoes my thinking about it as well. I do think that there are definitely things that we can still learn from the way the brain works compared to how AI works. Say, for instance, how do you manage to learn a large variety of things in various contexts and do so from very few examples compared to what, say, you pump into a deep learning network these days. Those are the sorts of things where, there's still a lot that we can learn. But it's not entirely obvious how you discover that in the brain. And as you said, so it's not clear how fast can neuroscientists convert that into something AI could use. And for instance, this is a point where Jan mentioned, well, he thought that AI could probably search the space of probable models and probable methods better and faster than, say, neuroscientists would be able to interpret what's going on in the brain. So if you need to solve some issue with reinforcement learning or something like that, it would probably be faster to improve that just pure AI development. I'm not sure that's true because, some problems explode very quickly. Numbers are big very fast. And then when you say we're going to explore all possible models or something like that, if you don't have a good strategy, you could be stuck until the end of the universe. So that's not, yeah.
One of the really interesting things, though, is that hyperparameter searches in machine learning have become much better recently. People had some useful insights and found machine learning methods to improve other machine learning methods. And I think we should expect at least that to continue. That's not necessarily searching this enormously large landscape. It's just maybe 10 or 20 dimensions of hyperparameters, but that's already a pretty high dimensional space. So it might be useful to just keep an eye on this and how good does this generalize to other domains, including trying to find models in other domains. If you start seeing the automatic model making to really take off, then we should expect things to get rather explosive.
Indeed, yeah. But that's also where it becomes much more complex than just predicting a system that will use a simple algorithm to improve its utility function maximization over time, because if you're building completely different modules that work in a different way, then you have different algorithms and everything becomes a lot more unpredictable.
At
So in
least
terms
for
of
a
AI safety,
normal human perspective, it might turn out that there might be tools to do this too. So I think Eric Drexler has made a very good point in his big report about reframing a bit of AI safety. We quite often think about the AI or the neural network as somewhat self-contained systems, but actually the part of a practice of generating things that solve various problems. And most people in business anyway don't care about AGI, they just want to solve some practical problem. So we're developing pipelines and services that generate these things. Again, that is worth watching, especially since when they can be applied to brain emulation, then we might get a pipeline towards better brain emulation. When we get a pipeline for decoding neural tissue and figuring out things about it, then we should expect that to at least boost neuroscience.
indeed, yeah. And what we really should be talking about is an ecosystem of various AI instead of the single AI that's going somewhere. Yeah, indeed. So now maybe we can run through a few very specific points that get brought up, because these are just things where, where I often get an opinion from someone or a statement, but there isn't necessarily that much material behind it. And I wonder if maybe there's a way to slowly push towards a more precise understanding of those particular concerns or questions. So the first one I'd like to get into is the idea of having a brain-computer interface, a high bandwidth brain-computer interface, something that is the target of research and also of some for-profit companies. I'm not going to go mentioning names, but we probably know who they are. And, you get, sometimes you hear from them statements such as, if we can have a high bandwidth connection between the human brain and a machine, then first of all, that will help us avoid AI safety problems, because somehow we'll be more tightly connected with that. There'll be some symbiotic relationship between us. And secondly, we'll be able to benefit very strongly from this connection, and we'll be sort of a part of that advancement. Have you thought about this claim regarding to now brain-computer interfaces? We're not yet talking about neural prosthesis in this case.
Yeah, so I vividly remember a few years back when Elon Musk had spouted off something. It was general face palming around the office. We like Elon, but many people thought, oh, that sounded stupid. And I have a big mouth. I said, maybe there is something to the argument. So then my manager gave me 2 weeks to try to make a steelman version of argument. That's the opposite of strawman. Let's see if one can make this argument work. And I found that the first version of the argument that's saying, if we get brain-computer interfaces, we're going to get enhanced, and then we're going to be smarter than the AI. That seems pretty unlikely. There are real problems in making an enhancement that makes you super intelligent, especially if you need to do that within a relatively short time frame. We might not know how far it is until you get super intelligent AI, but the time it takes to test out anything that deals with human biology, anything that's medical, and then try to develop user interfaces and enhancement, that seems to be something that potentially could take quite a long time. There is another argument, and that is, if you can't beat them, join them. So I get my brain-computer interface, I'm linked to the AIs, and this way I'm going to be on the winning side. Except, of course, that the nature of that link and what we mean by winning side is quite tricky. By some accounts, my mind is already linked to my cell phone because of the extended mind hypothesis. Part of my mind resides in my calendar and other applications. I don't have certain memories in my head, they're in my smartphone. So maybe I'm already linked to machines. And now if the dangerous paperclip AI takes over the world and turns it all into paperclips, in some sense, I was on the winning side because I had a smartphone. But this doesn't sound like winning. This sounds very stupid, in fact. The reason is, of course, what to it. And we want that link to be the right kind of link. And suddenly we're in a very deep philosophical mess. So this doesn't seem very likely to work a priori. But there is something else that actually looked a bit promising. If I'm linked to an AGI system and it can observe my evaluations of situations, it can actually estimate a bit what I would have done. If it's trying to do what I would have done instead, this actually gives it a good chance. So the system might notice.
You know where that's going, right?
Yeah. The big problem is, of course,
once it can predict everything you're doing, it has an emulation of your brain, right?
Well, not necessarily. It might predict my value system, but nothing else. So the naive version of it might, for example, notice that I like helping little old ladies cross the street. And I don't think kicking them in front of a car is a good thing. Now, if it's just optimizing for that, then it might, for example, run away from little old ladies because it wants to avoid them, helping them, etc. You need more rich information. And this is where things get interesting. If it could just get an entire copy of my brain, then we could definitely get the information over. But even my value system contains some useful things to do value alignment. So, for example, if you follow up the causal reason, why do I like little old ladies crossing the street safely? Why do I dislike kicking people in front of cars? Now you might learn something about at least my morality that's actually quite useful. There are two things here, of course. Maybe one shouldn't just use my mind, because I'm definitely morally pretty flawed. Maybe we actually want to make sure that either we take a certified saint, or perhaps even better, have a lot of different people who might give input in order to do general value alignment. And second, of course, it's slightly tricky to get this to work really well, because neural interfaces are tricky. But if I'm just saying, no, robot, don't do that, or if I smile at the robot, that's already sending a signal. Maybe I don't need the neural interface at all. The neural interface is just cool because it might access my orbitofrontal cortex and give some actual evaluation information, even if I can't express it.
Yeah, these are all very good comments. And I like that you said, okay, just even if you don't think about emulation, if we're just talking about something earlier, like being able to understand your values, your value parameters, that can be helpful. And of course, I immediately started thinking about the deep learning networks that learn to be racist because they were learning from us. And yeah, that's where you get into that whole value alignment issue and what are the right values, and should you even care about the right values? Are you supposed to tinker with that when you're dealing with a particular person, or is that invading your freedoms and stuff like that? It gets very complicated. But I also think people tend to jump straight to the assumption that we can talk about a system where you have a strong integration of the machine and the brain, where you have a connection that somehow is tying you very closely into what this machine is doing. And you mentioned the cell phone, and I think it's a perfect example for trying to think through what this actually means. Because when we say you have a high bandwidth connection between a brain and a computer, the computer still can operate at microseconds and even smaller timescales, whereas the neurons can't. So in this link, they're talking at different speeds, and that is very similar to what we're seeing with the cell phone and ourselves. The cell phone has a different language, not just a different speed, it has a completely different type of language. It's using a microprocessor, and we have a neural brain, and we work at a slower pace from neuron to neuron, although we have a lot of them. And we communicate in a very particular way with this cell phone. We can only, press buttons or swipe, that sort of thing. So there's this communication delay or communication constraint built on this. And then you can think about, okay, so how has working with these cell phones, how has that affected the development of cell phones? This is sort of an analog for how does it affect the development of AI and potential AI safety, right? Or how has working with the cell phones affected us? Now, we can say a lot about how it's affected us, and some people think there's some good things there and some bad things there, probably a mix. But it also clearly has affected how cell phones are developed, because cell phones are always developed to try to fit into, say, these communication limitations, to work well with how we interact as interface development, to present information to us in a certain way that makes it easily graspable. We want interfaces that can tell us quickly what we're looking for, but of course that also constrains some features, right? The interfaces that are simple and fast are not interfaces that are highly configurable and very, adaptable and all that. So we've got trade-offs, and this clearly has an effect. I think it's a great example, and I think maybe thinking more about how we already interact with machines in that way is a way to try to imagine what this would do, building a better or faster or wider interface with machines in some sense.
So ideally, of course, if you want an interface, it should be plug and play. It should work straight away. The problem is that probably means that it needs to be very pared down. And if you look at the general design philosophy coming out of Apple, it has always been actually cut away possibilities and just leave the things that people actually will want to do. Hide as much below the hood, or maybe even make the hood closed. You can't actually get onto it. Meanwhile, of course, if you're using any of the Linux or Unix systems, everything is accessible, but, well, reading the manual and learning how to use it is getting very complicated. Once you know it, it's very powerful, but that takes a long time, and most people don't want to do that. So it might be that the transformative neural interfaces would be the ones that actually require a lot of learning. So the most fascinating neural interface I know of is, of course, Miguel Nicoleli's attempts at brain nets, connect brains to the other brains. And as a test of his idea, it seems like if this works, I want to see independent replication of it, but it looks like the brains can adapt to each other and learn how to decode each other's signals somehow. That's awesome if it's correct, but it also seems to take a lot of time. And I don't want to have a system that's not working for months and months, but yet I need to train myself to use it. So it might very well be that the neural interfaces we get at first, they're going to be useful for people who are desperately in need of it and strongly motivated, and the people who got the mindset to train themselves. But most applications are probably not going to be that deep. So instead, what you want to do is something that interprets enough of our signals and use a lot of smarts from the outside to try to figure out what we meant. And the fact that our minds are relatively slow compared to the machines is not necessarily a bad thing. It might be that we have a slow process initiating fast processes. And as long as we get enough feedback in our own pace, we can actually control that. This is a bit like how a constitution governs a state. The constitution is not changing that much. It's not supposed to be updatable at a very high pace. Below that level, you have the laws which are updated at a faster pace, while local regulation and norms can be updated faster and faster. So you might have systems with different levels of flexibility linked together. And if it's actually working well, then you can have a slow system setting the agenda, the fast systems implementing it, and some feedback system checking that everything is working. In practice,
this is really... Sorry, I hate to interrupt, but I just want to say something right there because, you know, before you were talking about the degree to which someone could say that they are a part, you know, they're winning, they're part of the winning side, they're part of the whole thing if they're integrated, if they're connected with machines. Now we're talking about a slow system and a fast system, and that the slow system is somehow still governing and supervising what's going on. And it's interesting to compare that with what's going on in the brain already, where, for instance, we have systems that are slower. You know, our conscious awareness is definitely something that progresses at a different pace and in different chunks than all of that subconscious processing that's going on in parallel throughout our cortex. And similarly, you know, when we're trying to think something through logically and we're trying to make up the steps, that's a very different and slower process than the other one. And that, in fact, is the process that the machines can do very quickly. So it'd be interesting to see what happens there. But it's interesting to then look at how integrated those really are and what's really going on there. So, for instance, we tend to think that our conscious awareness, that our conscious self is in control. We tend to think that that's the part that is really the boss, and we're governing everything that's going on. And yet, you know, you can show experimentally that you have already decided something long before you know that you've decided something, because those subcortical processes are really doing that deciding work. Of course, this makes sense, right? And the rest is just a reflection to yourself. It's just an observation about what's been going on in your brain. And now we can imagine that something similar is the case if you integrate a human brain with the machines, who are operating at a completely different speed. They live in a world of nanoseconds that we can't live in. They live in a world where they can use things like, you know, quantum computers or simulated annealing or something like that to come up with ideas and solutions that we can't think of in our brain. It seems like one of those situations where ultimately you may have a feeling, a sense of control without actually having it.
Yeah. So I think this is a very important point. And generally, I think most people say, yeah, I want to avoid that. There is an my impression of the current state of play is that a fair number of what things we're doing are indeed illusionary. But our top level consciousness and mind can give a veto and intervene, not very quickly, but we can actually
really give the veto, or is it other drives that are informing your consciousness to then give the veto?
That is another good philosophical question. I need to check what the philosophers are saying about that. But I do think it makes sense that you have a top level that is actually getting information from most of our systems. The systems I really have a problem with is the ones that never have an output on the conscious level or never tell the rest of the systems what we're doing. The real kind of secret societies of the brain. I don't know how many they are or whether they play an important role. In general, the brain seems to have connected everything a little bit to everything else. It's just that the degree of control and the degree of information is not as intense as one would expect. Once you start realizing how diffusely connected our different parts of our mind are, you start to feeling a bit like a cloud rather than a person.
Mm-hmm. Yeah, the illusion of control, and whether or not that's a bad thing, that there's an illusion of control, that's really, I think, is core to many of these questions that we're talking about today. Because when we first started talking, we talked about AI risk, and we talked a little bit about what do we imagine that a worst case scenario and a best case scenario is. Now, most of the time, people tend to think that the worst case scenario has something to do with a situation where humans are completely not in control, and where they have no say over their future, and perhaps they're even somehow eliminated. Now, when we're talking about situations where control is mostly an illusion, but there are aspects of it where we're tied in, say there's this veto power that, again, perhaps isn't real, because, you know, free will as such may not exist at all, but there's still something that we value. So really, when you talk about the danger of AI and what it can do to humanity, we should be talking about what are the values that we're trying to preserve? What would we call a successful outcome? Yeah. Which bits do we want to preserve and why? And then what sort of scenarios can incorporate that? And some scenarios may include a lot of change, where a lot of things that machines will be able to do and where they develop into becomes a part of what human society is, right?
Mm-hmm. So I'm reminded of some of I.N.M. Banks' culture novels, where very super intelligent machines play a role in the plot. And in many cases, they manipulate protagonists in various ways, more or less subtly. And the interesting thing is that in many ways, these manipulations can be, in many cases, they are fairly benign. Because there's still respect. The protagonist can do differently, but he's unlikely to want to do it differently because it's a really good argument and the situation is contrived in a certain way. Would we say that this is a bad situation? Well, as long as it's actually a fairly well-intentioned entity that actually has our own best interest and some other good goals, taking that into account, that might be all right. If I have a veto power but never exert it, I might still be pretty happy about that, because I might have my illusion of control, but it still is important for me to function. Normally, we won't have a sense of control because we're agents. We survive by moving around on the Earth's surface and manipulating things. And when we can't act, we're super vulnerable. When we're in a situation where action is not possible, we're at the mercy of everything else. And that evolution has made us really desire to be the actor. Mm-hmm. Now, intellectually, we might sometimes realize that I should listen to a smarter person and do what he or she tells me because they actually know better. But my little inner 2-year-old will say, no, I will do the opposite just because. Then, of course, my inner 20-year-old will try to get the 2-year-old to listen to reason, and there is a lot of debate. And meanwhile, of course, maybe a really smart person will manipulate me because they know I have this internal dialogue. But a good outcome would be that you think that intentions are transparent enough that we can kind of see that these seem to point towards a future that is desirable.
Oh gosh, you just opened up a whole new can of worms. What do we find good and desirable? But I just wanted to point out that you now have also, again, come across something that Jan Tallinn mentioned. He mentioned that he felt that a good future is one with as much optionality as possible, which of course is our desire for control. It's the desiring to have as many different paths as we can take as possible. But, you know, you mentioned that sense, the illusion of control, possibly being important to us. And then I was reminded of how, you know, many people say that what they desire is happiness. And then when we think of a future with happiness, then you get into these wire-heading ideas, you know, where you can just make someone feel happy, even if there's really nothing that's changed about their situation. And in the same way, it could be possible that we could give ourselves the illusion of control when we have zero control. So again, it doesn't immediately solve anything, but you know, if we think through what the real, say, the values that we're trying to preserve are, you know, you have to think about very basic things like the value of, say, something that we consider really human continuing for some reason because we think that very human thing is important or has made the universe a better place than it was without humans in it. Yeah, this gets really deeply philosophical, of course.
So it comes up in a lot of existential risk research too, because maybe if we nuke ourselves and the cockroaches become intelligent, maybe they will have a much better civilization by all accounts than us. In that case, maybe we should say, oh, that was a happy ending for the universe. And of course, some value theorists would say, yeah, just integrate the total amount of happiness and compare that one. Now, others would say, wait a minute, how certain are we that happiness is what should be maximized? There might be other things. There might be deep thinking or paper clips or what have you. So we also have to take moral uncertainty into account. The nature of what is good about humans, our uniqueness, I think many people have an intuition about it. So there is a lot of things one can do here. And right now, I don't think we have any complete theory about what the good is. Obviously, philosophers have been working on this for a few thousand years, and progress has been modest. I think we have learned important things, but it's pretty clear that the list of things that could be the ultimate good, or the list of arguments why then maybe this list will never be complete, are pretty wide. But it's worth noticing that even if you take something as simple as happiness, people are quite bad at identifying what makes them happy. Mm-hmm. And even when they know this action would make me happy, they might quite often not take that one. So there is one of the scariest papers I ever read in Trends in Cognitive Sciences from a few years back, which is just reviewing these results. And to me, somebody who's kind of politically libertarian, this was horrifying. Because if people don't even do what makes them happy themselves, giving them the option of doing that, okay, now that doesn't necessarily work out very well. Now, I still think that most forms of control actually have very bad effects too. But it shows that it's tricky. Our feelings of what makes life better might not correspond to actually making life better, partially because our feelings are evolved things that made sense of the African savannah, and actually the life we're living now, not to mention in the future, might be so radically different that we need to develop new kinds of feelings.
Mm-hmm. Yeah, that makes sense, yeah. So we went down a really deep rabbit hole there for a moment, and I don't want this to go on for too long, but I'd still like to quickly touch on a few remaining questions about whole brain emulation in AI. So I wanted to talk about the idea that whole brain emulation itself can be a danger to humanity. And so I don't know exactly what people mean by that when they say it, but I think sometimes...
Give some ideas. So I wrote a paper a few years back together with Peter Eckersley, who back then was at the Electronic Frontier Foundation, now is at the Partnership for AI. So we were looking at, could you get risk out of having brain emulation? And I think the most primary one would be, if you have software people who suddenly have a radical break with a lot of traditional views on human nature. You would have some people who actually have religious reasons to say these are not true people. They would have potentially economically disruptive effects. If we look at all the ideas in Robin Hansen's The Age of M, that it seems like getting a brain emulation breakthrough might be dramatically disruptive. And you get entities that are in some sense a natural other. So you can very easily tell the story how you could get just a conflict where some people think brain emulated people are not people and they're evil and taking our jobs and so on. So you could get a very natural conflict. That's still, I think, not an argument against doing brain emulation, but rather making sure let's reduce bigotry and improve tolerance. You could also, of course, have the idea that if you get a brain emulation, it's going to be self-improving so fast that now you get some form of hard takeoff. And before you know it, you have all the problems of the normal hard takeoff scenario in AGI.
Well, how do you see that possibility, by the way? How does a whole brain emulation do a fast takeoff?
I personally don't believe this is particularly likely. So the normal way of arguing it would be something like, well, it's running on a very fast computer. The emulated person can do a lot of neuroscience experiments on her brain. You can run a lot of copies, test out things to improve various capabilities. And before you know it, you have some kind of post-human who might now really start doing weird things depending on their value system. I'm not too worried about one person doing this. But you could imagine a society. So at some point, I think it was Carl Schulman who was arguing with Robin Hanson that, well, that brain emulation society he's describing in great vividness in his book, it's not going to last forever because people are going to update and compete and change it to other things. So in real time, it's not going to last very long. And they kind of agreed, but maybe 2 weeks. That's still enough for a lot of history, enough for a book.
We don't have to get into that necessarily. I think Robin's book is beautiful, but I think it has, as a prediction for things that will happen, it has its limitations. For instance, because he left out AI as being a part of it. So many of the things that he has whole brain emulations doing, are things that just a simple AI program could be doing, and that changes a lot about that whole scenario.
And you can imagine that they develop these simple AI sooner or later in the brain emulated world, and suddenly you get an economic transformation that might be just as disruptive for the emulated people as the biological people. So that scenario would rather be that you get very rapid cultural evolution, which might produce actually extremely different kinds of entities. Some people, again, would say, yeah, maybe we're going to be so weird post-human that we don't care about us meet humans, and that naturally leads to conflict. I think a more plausible risk is, this unleashes dramatic changes in a domain that a lot of people will not have access to and will be too slow to react to. And that might, at the very least, look like existential risk. And it might indeed be some form of existential risk if it develops into something that lacks those values that are really humane.
This gets us back to the same problem again, which is what is existential risk? What do we call a bad outcome for humanity? So let's say that whole brain emulation leads to a new Cambrian explosion of different kinds of minds who develop themselves in various different ways, not just minds, but bodies as well, etc. And some of them do better than others. So there's an evolutionary aspect to it. And you can see change happening in a way that's a bit faster than it is today. And when I say a bit, I might just be understating that. But, if that happens, the question still remains, is that bad? Because maybe this is the best possible outcome for whatever we consider valuable about humanity, because it's going to spread everywhere very quickly, even if it changes. So does speed matter? Does it matter if you go from A to Z, by going A, B, C, D, D, all the way to Z and doing that in steps? Or is it just as good to jump from A to Z right away if the outcome is exactly the same? If, let's say, just as an argument for just the question of, does the speed of change matter? Is it important that that rate is slow for some reason?
At least in the case of personal identity, people typically think that the speed does matter. If I change day by day to become a more mature person with different political views, etc., okay, I might be fine with that, but not that one day I wake up and my personality and political views have changed instantly. Now, it seems philosophically that there's something problematic going on here, because I agree with you. Why should we care about those steps? And part of that is, of course, error correction. We might want to be able to go back or notice things. There should be time to realize what am I becoming? Oh dear, I know what I was voting for. I should totally change myself. But I think there is something interesting about that Cambrian explosion situation. To me, that sounds lovely. I think it would be great to have this open-ended future where you get a lot of humanities. And they are all drawing, of course, on originating from the same original species and might retain different aspects of us. However, you can also make a very scary scenario where various things that we care about evolve away. Nick Bostrom has this very disturbing paper about some post-human futures that are essentially devoid of value. So in one of them, the mindless outsourcers, basically people exist in an uploaded form and are outsourcing more and more of their brains. And in the end, there are no minds anymore. It's just an economy growing endlessly, but there's nobody at home. So the interesting thing here is, where does the value come from? And this is, of course, again, the deep rabbit hole, but I think it's worth recognizing that rabbit hole and kind of orbit around it at a safe distance. Part of that, as we normally do, we think, oh, being conscious and sentient seems to matter. Probably if consciousness is lost, then we're probably lost a lot of value. I'm willing to argue that maybe that's not all there is. Maybe there are unconscious systems that are valuable lives too, but that gets me into a big argument in the philosophy department. We can also say that some of our human nature might be valuable just because it is our human nature. We might not care about some famous paintings in a museum, but they're famous paintings that we should preserve because they're part of our past. Just as well as some of the horrors of our historical past, we should never forget about them. Not just because we want to learn not to do it again, but even that we think that if we were to forget about it, all the people who died in that particular horror would in some sense have lost something. There is a fair bit of interesting arguments in philosophy about this. There is a book here by Samuel Scheffler, Why Worry About Future Generations, which I found very fun because he's taking a non-consequentialist view about why we should care about humanity's future. And I find that really weird because I'm typically just thinking about what are the consequences. And he points out that you can actually love humanity. You can actually say there are things about humanity and its nature that we love, warts and all. And we want this to go on. So I think there's going to be a thick bundle in that black hole of what really makes life worth living that matters. And it might be that we need to hedge our bets. We don't really know whether it is our humanness or consciousness or the fact that we originated on this planet or just that we experience happiness. Maybe we want to have it all. We want that Cambrian explosion because it gives us a good chance of having it. I'd rather have a future that has both brain emulation people and biological people as an existential risk backup. If it was just one of them, I think we would actually both be in bigger risk and we might have missed out on true values. It might turn out that just like consciousness might have added a profound new value to the entire universe, there might be the next step. Let's call it consciousness prime, which is even more important. It's unfortunate no kind of matter in the current universe got it. You need to be maybe a brain emulation, a quantum computer, or whatever to actually start experiencing this value. And then the entities on the other side are going to say, yeah, back then, of course, those poor Precambrian humans,
they didn't have this thing. Yeah,
they didn't.
And it might not even be. It might not even be something like, the next level of consciousness. It could be something completely separate from that, say something that we also think is super valuable but has nothing to do with consciousness.
Yeah, but to some degree, expanding the circle to encompass bigger and bigger sets seemed to be a good idea. So one of my common analyses point out so they might say, well, given the capabilities of those post-apes, they call them humans, they could get a lot of bananas. And the apes would say, yeah, that's great. Bananas are good. And indeed, we are really good at getting bananas. We can get more bananas than any ape could imagine by planting them and doing everything. It's just that we're getting constantly sidetracked from the pursuit of bananas and sex by also doing philosophy and technology and politics and art and sports. And we would try to say to these apes, well, actually, you don't know what you're missing out on, actually. Science is pretty awesome. And post-humans or these quantum consciousness prime whatevers, they might say, oh, yes, the philosophy and science, they're so cute, a very nice part of life. We, of course, got these other things that you can't even imagine. But occasionally we do like our bananas. The thing is, if we retain some cores, and they might be somewhat silly things like bananas, that might also be a continuity that means that we care about the long-term future. I think one of the big fears people have is that you get this disruption. There is humans and post-humans, and there is no similarity whatsoever. This is part of the fear we have of AGI, because we might make something that's utterly dissimilar from us, and we actually don't have any way of telling them about what values we have and aligning them. When it comes to brain emulation, I always felt that we're much closer. We're at least starting out very similar. Then it might go off in different directions, but I think we have a good start.
We start with whole brain emulation, we know that whatever you've got there begins with something that is very human. And so whatever these values are that we care about, they're probably contained in there somewhere. Although it'd be great if we can explore the value thing. It's, not right now, but if that gets explored further, and I don't know, we can't make a prediction here. Are we going to solve the problem of what are the values we want to preserve in 5 years, 10 years? Where's our deadline here,
Yeah. So in some sense, doing philosophy with a deadline, I think that's a new thing that Nick Bostrom introduced. And I think it's important to realize that there are some deep philosophical problems that maybe we can't solve, but I think we should try to do practical progress on handling them, because they're actually becoming action relevant. And in some cases, that progress might just be, okay, we need to do more hedging because we will not figure it out before the time is up. But moral trade and moral hedging are possible things, and they can be quite powerful.
Indeed. So I've kept you on this now for quite a long time, so it's probably time for me to sort of bring it to a close. But before we do, and I have a concluding question for you, but even before I ask that concluding question, I wanted to know if you think that there is something important or relevant that we haven't touched upon, haven't covered, that you think should be mentioned here.
I think the core issue I have is we have been talking about many things that have been around our community for a long while. Some of it we have written a bit of papers about, but it's very little. I think there is more work to be done here. Some of that might be done by neuroscientists or philosophers. I think there is quite a lot of room for interesting joint work here, trying to turn this a little bit more rigorous. Maybe measure what is the flow of ideas between different sciences. That's interesting on its own. You can make a good academic paper out of it, but it might also tell us a little bit about the safety issues. I think we need to work a lot more on what can we do safety for neuromorphic computing. Right now, a lot of safety work tends to assume these platonic computers running on little black boxes on whiteboards, and that might be good to prove some things about, but we might want to figure out other ways of doing AI safety and machine safety.
Yeah. And
so there are plenty of things to work on here.
All these questions about values and what values we're trying to preserve, and therefore what a good outcome is, that's really part of that, isn't it?
Yeah, and some of that, of course, is traditional philosophy. There is even a branch of ethics, axiology, the philosophy of value itself. But I think also we have found that there are values here. The orbitofrontal cortex does have value representations, and we're actually figuring out non-trivial things, both from addiction research and scanning of brains when we make choices, about how we do evaluations and how it functions. I think there's a lot of room to do empirical research here that might actually give a good kick to the traditional philosophy to see it in new ways. I think we have seen a rekindling of interest in ethics in many parts of philosophy because of AI safety research, because it actually forces philosophers to try to formulate, can I make my ethical system something that could run on a computer? And most traditional systems are absolutely impossible and too fuzzy and badly defined, or have too big computational demands. And then we can start asking, so what is a moral system that actually can run on a brain or a computer? And what is the philosophical import of that?
Mm-hmm. So you do think that at some point we will have answers to all these questions, or do you think it's just going to be a situation where we become progressively more aware of what all the detailed questions are, and we just kind of lay out all the questions and we sort of swim in them?
Well, philosophy is interesting because many sciences try to advance, we try to move forward, and philosophy tends to try to dig deeper instead. And sometimes that's the right choice, but in many practical cases, we want to move forward. I'm writing a book about the long-term future, and I actually, right now, I have a very loose calculation. Given that we haven't solved these problems yet, what's the likely time until philosophy solves them if we believe there is a Pareto distribution of problem difficulty? And I ended up with something like maybe it's going to take 10 to 20 philosopher years before we figure out what it's all about. Yeah, that's a lot.
Okay.
Might be faster if we have better computers, but it might turn out that actually it's going to be far in the future when finally some super post-human kind of goes, oh, that's kind of obvious.
Isn't it interesting how the Hitchhiker's Guide to the Galaxy already predicted this? 42,
yep. Yeah, and again, it made a very good point. You need to understand the question really well. Then the answer is typically quite easy. So one of the interesting things about this interplay between philosophy and science and practical engineering is that quite a lot of time you get these practical issues that force you to refine your deep philosophical question. I think we're going to find eventually that axiology probably gets solved because we actually do a lot of neuroscience, and then that forces philosophers to think in a different way.
Okay, awesome. So concluding this, my last question, what do you think that, I mean, this is again an impossibly complex question, but what do you think that humanity should be doing, or how should it change how it approaches problems compared with what we're doing today to maximize our long-term chances for both survival and thriving as a society?
So I do think we need to find ways of aiming at an open-ended future, but that doesn't necessarily mean everything is possible. We might want to cut off disastrous possibilities. We want to avoid existential risk. And in order to do that, we probably need better tools for insight and coordination. So right now, it might seem that we're in this world of fake news and international chaos. We're doing really badly about it. But compared to a century ago or 2 centuries ago, the United Nations is a really hopeless organization. But 2 centuries ago, it was unthinkable. What? Getting all nations together without weapons and actually agreeing on at least a few things? In 200 years, we might actually be able to do something much better. Similarly, yeah, we have a lot of problems with fake news, but we also got things like Wikipedia, which is kind of an early stab at creating a common knowledge base. Again, that was the first stab, and it's probably not going to be the last or best. So I do think that we can work quite hard on improving this insight and coordination thing. Better filtering mechanisms of separating true and false information, which includes, of course, science. The replication crisis in especially psychology demonstrates that we need to work quite a bit on building a better engine of scientific knowledge. But even the problems we have when we data mine the scientific papers and try to run that to do medical diagnosis turns out into trouble because many papers are so bad. We need better ways of doing this. And those tools are useful in a lot of domains. We might want to have a better chance of tracking our own truth. We might want to find ways of having discourses that work better. It's a gradual thing, and there's going to be an uphill struggle to get there. Similarly, the coordination. In the long run, we need to coordinate before we start scattering across the universe and become too incomprehensible for each other and too far causally removed. Before that, we might actually need to have a big meeting and decide, okay, this is what we're going to do long-term with the universe. This is how we're going to hedge our moral bet. This is how we're going to move the galaxies and making sure that it stays in the right way. Is
that a meeting the FHI is going to have in 2021?
Let's hope for something like that. So actually, the original idea is Will MacAskill's idea. He talks about the long reflection, but maybe once we got in our act together, we should just sit down as a species and maybe spend 1,000 years debating what to do just to get it really right. And right now, this sounds absurdly utopian. This sounds totally crazy. But then again, so did the United Nations once upon a time. So we should start working on making the tools, to make the tools, to make the tools, to make good insights and good decision making. And of course, making sure that we don't go extinct while doing this. We should never let the perfect be the enemy of the good.
Oh, that can be difficult sometimes. On a more personal note, given all the things we just talked about, and there's so much more, of course, how do you deal with the fact that this is such an overwhelming pile of stuff? I mean, how do you tackle that, or just like go at it and still feel that there is good purpose in moving forward every day?
So the problem is not finding purpose because there's so many interesting and important things to work on. It's rather, how do I choose the most important thing and focus on it? And I'm lousy at that. I'm basically an academic magpie. I see something shiny and I go for it. So over the past 1.5 years, I've been somewhat focused because I've been working on my book about what I call grand futures. And it's broad enough that it actually allows me to, whenever I get distracted, I just write another part of the book. That is one way of doing it. I have colleagues who are way more focused. They sit down and they think very carefully about what matters, spend even more time checking that it really matters, and then they start working on it. And I think we can, again, like hedging bets, you hedge yourself by having people do the different strategies. And then sometimes we compare notes and see, oh, that seems to be something I should be doing.
Okay, that's really good advice. Yeah, there's some different strategies there. Okay, fantastic. Thank you very much. This was a fantastic conversation, I have to say. Yeah, like always.
Well, we should keep it up and make sure that the future continues to have great conversations until the end of time.
Oh, yeah. And you'll be welcome back at the Carboncopies Foundation again and again, for sure.
Thank you so much. Yeah.
Okay, stop the recording now.
Yeah. Not hearing you at the moment. I don't know if you can hear me.
You are audible, Randall. Mallory is not.
That was really awesome to hear Anders talk again. He's always a fantastic speaker, no matter what the context. I wish we had a way to, really do claps online. Maybe we need a canned clapping or something, and then whenever appropriate, we'll turn that down to a slow clap or something.
We're downloading a clap track now. Just
okay.
I'm just joking.
Okay, maybe that Mallory has a more serious problem with her mic at the moment. So many technical things because, everything depends on so many little bits and pieces. Is the Bluetooth working? Are the batteries still charged? And all that sort of stuff. And in my case, the internet drops out every once in a while, so that's not great either. We have heard from Anders recently, about 27 minutes ago. He said that he was 30 minutes out. So maybe he'll be here in 3 minutes if we're lucky. Or maybe it takes a little bit longer to, get off of his bus and get into his house and get all set up. That's all possible. So in the meantime, we can start addressing some of the questions that came in while... Oh, here's Anders. Then we don't even need a meantime. We can just go straight at it.
Sorry.
Hello, Anders.
Giving you a break.
You must have just come in the door and sat down, basically, right?
Yep, literally. Yep, just ran in from the bus, got home.
Okay, well, that kudos to you for being able to do that. We all just listened to the interview, and as usual, you're fantastic. The way you present everything is so clear because, unlike me, where I go into abstracts very quickly, you tend to bring everything back down to examples that people can really get into and dig into, like, AI that is helping little old ladies across the street and things like that. So that's perfect. And I think we also got a bunch of good questions here, and I see Mallory just popped up again. So she can take over
hear me now?
her job.
Yeah.
Okay, great. So where did we leave off after I joined? Are we going to start with our first question?
You can go ahead with whichever questions you want. Anders is here.
All right, and just to remind everybody, you can ask your questions in the YouTube live stream chat, or you can call into call.carboncopies.org or the number 415-455-3017. The first question that we have is from Roman Sitlu. Even today, there are some people who are both capable of recursive self-improvement, like adopting the new mind-enhancing technology, and have strong misanthropic tendencies. Basically, in a way, they're biological, non-friendly AGIs. What can we do about this scenario?
I think we actually have a surprising amount of good tools at our disposal. After all, one reason we behave ourselves is that our mothers told us various things that we should be doing. And that's a form of social software. We have other forms of social software we get when we get enculturated, as well as police, reputation, various forms of market solutions. And many of these things constrain us to a tremendous degree. Then, of course, if you try to do recursive self-improvement through enhancement today, it's quite limited. No amount of smart drugs and meditation and getting the best apps are going to make you tremendously more effective than just somebody who's really smart or specialized. And you're not going to exactly beat Deep Blue and even without actually having a computer on your side. But the deep part of the question is, how do we handle when it becomes easier to make powerful individual minds? And I think in general, we do that by having a lot of minds that are partially constraining each other and systems of minds. Because generally, systems of minds are much more powerful than individuals. So to just take a little parable here, we have Eliezer Yudkowsky's interesting AI boxing experiments, where he practically demonstrated that actually convincing people to let out a possibly unfriendly AI out of a box was pretty doable. If you're smart enough and glib enough, you can talk your way out. This is impressive, except why don't prisoners do this all the time? Why don't we see more prisoners talking their way out of prison? And the answer is, of course, well, quite often they talk their way past one of the prison wardens, but there are others. There is a system. There are careers of being prison chief and warden that are dependent on prisoners not talking their way out too much. And that actually makes actual prisons surprisingly effective in keeping even the most clever prisoners in. Not perfect, but quite well. So I do think we can do the same kind of system management. It's not like we want to only upload the saints, so we don't even have a good yardstick of saintlyhood, and maybe the saints won't stay saintly once they're in the computer either. But you don't want to have just one mind.
Great. Does anyone want to add to that, or should we move on to the next question?
I think Anders pretty much answered the whole question, unless you wanted to dig into the detailing that Roman did when he pointed out, well, you know, people who want to self-improve may already feel that they are perfectly fine at eliminating a huge part of humanity in the future or something like that. If you could restate that properly. Or Mallory, sorry, maybe I didn't make myself clear. I thought you could maybe read out that part of the question.
Or I could just try to get at what I think that question embodies. So really ruthless sociopaths and people think that the world would be better off with just me around. Certainly psychologically they exist. The vast majority of them are not very good at doing anything, because by virtue of being so misanthropic and sociopathic, they rarely can acquire the resources. I think the intuition we have is, oh, what if we got a technological mean, that pill that just makes you essentially godlike? At that point, we would be in trouble if we got it. But the problem is they're probably not first in the queue, most of them. The real problem might, of course, still be the scenario where you have successful sociopaths, successful misanthropes, or who have just run into a lot of resources, and they would get empowered. But again, the question is, why aren't particular billionaires wiping out everybody else and running the kingdom? Well, to some degree, they still need other people. But even there, you can actually replace people with consultancies, etc. The actual problem is, of course, societies, in order to remain rich and functional, are quite complex. You can't actually run all the parts. So the people who are just interested in wealth and power, they're relatively safe. They might distort society in other ways. So the only case we need to be worried about is the really misanthropic person who gets very powerful. But I do think the scaling of power isn't in favor of this. Once upon a time, that the Medici family, they were wealthier than essentially the principality they were running. The Rothschilds were rivaling the nations, Europe, in wealth and power. But meanwhile, they were wealthier than the United States. These were powerful, rich people. To organizations of people like state actually has become weaker. So I'm much more worried about misanthropic and crazy states and the institutions than individual misanthropic people.
Hey, yeah, I think that answers the question pretty well. The next question that we have is from Jasa RC. What do you think about the human habit of comparing ourselves to the technology we create for ourselves, or our tendency to humanize things, even if they're a robot or an artificial intelligence?
Yeah, so one of the main reasons people make robots is, of course, that they actually like to humanize the technology. If you think about much of a Japanese mindset about robots, it's that it's important to have a social relationship to technology. And certainly they also believe that we have social relationship even to non-human technology. But if it got a face and it's easy to interact with, it's more manageable. And I think this gets at something important. We humans have agency detectors and other mental constructs that help the world, which is a social world for us humans. This sometimes leads us to think about things in the wrong way. When lightning strikes, we wonder who is angry and come up with a story about somebody must be angry with somebody for some reason to cause lightning. But on the other hand, we use this to do intuitive physics. So it's very natural for us to try to make these kind of machines and put in a lot of anthropomorphication into them. And we also, of course, tend to assume that if something got a face and talks back to us, it must be part of the human world, which is why it's so easy to have a chatbot and convince people. And this is why people fail in the Turing test all the time. But then there is the opposite thing. By trying to make artificial intelligence, it's also a mirror. It's a great way of trying to understand ourselves, what we are, what we mean by thinking and feeling, and what aspects we care about, but also what we fear. A lot of worries about artificial intelligence are our own projections, but what if we made something like us? And I think that's the first level of worry. I'm not so concerned about that myself, because I think the second level, being totally alien, and hence they're serious. But we should not miss the fact about these things. We are deeply human.
Great. Does anyone want to add to that?
Yeah, just a quick note, which is this point you made at the end about more worried about things that are more alien. This kind of comes back to that bit about, say, worrying about corporations or something like that that are very powerful, because in a sense these are also alien because they have a different way of making decisions. Say they're way more focused on what we might call a utility function, which is the bottom line, and the quarterly results and that sort of thing. So they can be very sociopathic in that sense and very powerful at the same time. So I think you're absolutely right to focus there first before worrying about the individual person in a sense. So yeah, that kind of jumped back, but I guess that's okay. Oh, quickly before someone else answers something, I just want to point out that while there are lots of good questions coming in, and there's no way we're going to be able to address every question in the time we have on the panel, we are collecting all these questions, and as we see good questions there, we're still going to work on them later on. You may find them in transcripts or in other work that we do. You can still contact us about them through questions@carboncopies.org, and we can get back to you.
I think I can move on to the next question now. Our next question is from Jan Klok, and he says, while initial collaboration may be nice, competition like the US versus China, and I'm assuming he's referring to our competition with artificial intelligence, that's probably the most prominent one, is that competition is going to stay. How do we utilize that for whole brain emulation and artificial general intelligence development and keep it safe?
So the first thing worth mentioning is, of course, many of assumptions that we are, let's say, US versus China in a competitive race might actually be because humans like to project their human moods and feelings onto these alien things like nations. We are fairly competitive, and you can totally think of international politics as kind of the schoolyard bullying going around. And we quite often construct that way because it both allows us to think about it in easy ways, and of course, a lot of people involved actually like to think about it. It's just that in practice, governments are disjointed entities that have different goals in different parts of the government. And you can imagine, for example, a competitive situation on artificial intelligence in China and the US that involves total sharing of safety information. I think actually that is something we should be pushing very strongly for, even if people think that this is a strategic technology and it might even be important to be first. It should also be a no-brainer that it's also important to have a world to be first in. So maybe we should be also sharing as much as possible on the safety technology. This actually happened during the Cold War between the US and the Soviet Union, where the US deliberately shared some technologies for keeping nuclear weapons safer, simply because that would be in the interest of everybody to have that technology. It didn't always work out diplomatically as it should, but it was definitely a good try. So when you want to use competition to do something good, typically it is this concept of creative destruction or let 1,000 flowers bloom and so on, that you allow a lot of diversity. And then that competition will hopefully bring forward interesting things that you can notice are interesting and useful that can be replicated. And this is, of course, typically why market economies do so well compared to a planned economy, because they can find new solutions rather than trying to optimize for an obvious one. So when it comes to research, this is extra important because in most fields, the amount of progress you make is a very convex curve of amount of efforts you put in. So in the early era, you get a lot of rapid progress, but you don't know what you need to work on. You need to map out the field, you need to do a lot of experimentation, but you can also learn a lot of things. Eventually, it's time to bring out the big supercomputers and the big the collaborations, but first we need to solve a lot of small stuff. And that's a great thing to actually have dispersed between not just different teams, but also different mindsets and approaches. If everybody tries to achieve brain emulation or AI in the exact same way, the probability of it succeeding goes down quite a bit, which maybe is good for safety work in the background. But by the same token, we want to have a pretty big diversity of safety mechanisms explored before we notice which one seems promising enough that we should be starting to pile on and boost their abilities.
Wow. So I think, first of all, that that it's worth pointing out that what the person who is asking the question is talking about may also be something a little deeper. It could be just, I mean, not specifically about how do people working on AI, how should they work? Should they compete or should they cooperate? But also just this fact that competition is sort of a natural thing that just emerges from there being differences between things, and then the selection mechanisms that apply. So you see that in evolution too, of course. In evolution, you have differences in DNA through some genetic mutation, and then one of them works out better than the other, and that's a kind of competition, even if it wasn't intended to be a competition. And the same could be true. You could say that even for a single AI that is trying to improve itself, as it's trying out different algorithms, those algorithms are competing on some kind of performance criterion. So there's a competition going on there. So you're always going to have, within the ecosystem of all the things that are going on, you're going to have both competition and cooperation, because cooperation is often a strategy that helps, that enhances what any single thing can accomplish. Say, for instance, the cooperation between different algorithms have two different ways to detect people in a scene instead of just one way to detect people in a scene. So you've got both collaboration and cooperation going on at both times. And then, you know, what, let's see, what was the name of the person asking the question? What Jan was asking, it could be interpreted as, since there's always going to be both collaboration and cooperation, and it's really hard to weed out and to say, we should all be working collaboratively on the same AI here or something like that. How can you ever make sure that's going to be safe? Because any actor who happens to be slightly less cooperative may get an edge because of that, right? And I was going to go further with this, but I think I've already brought enough new stuff in here. Anders, do you want to say something about that?
I'm reminded of something that Eric Drexler wrote somewhere in one of his old papers. I think it was his Agorex papers that he wrote somewhere in the late 80s. And he pointed out that we often talk about how wonderful it is in nature with all this symbiosis and all these harmonious cycles, while human business, it's red in tooth and claw, it's all about competition. But he pointed out that actually the reason we hear about the crimes and when people betray each other in politics or in business is that it's rare. It's very unlikely that you get robbed by gunpoint by your grocer. Most of the time you will just get groceries and pay for them. Most economic transactions are extremely cooperative. We tend to notice the difference. Similarly, in nature, actually an awful lot of interactions are fairly adversarial. And then we get very rosy about all this wonderful cooperation we notice. So many systems have different styles and biases. Now, the reason human economies work so well from a cooperative standpoint is that we have a lot of tools to enable us to do that. It's much easier to negotiate if you've got a brain and a language. It's way harder for the different plants and animals in the forest to find some nice Nash equilibrium. So I do think the real question is, can you then set up the rules or the agent so they generally tend to be cool? So the rewards in academia reward you for trying to be first with a cool paper. That is a competitive thing. But you also need to tell everybody how you did it, and everybody gets to comment on it, and you actually develop this cooperative effect. Peer review is in some sense competition, but it also helps truthful and useful papers get ahead. And we might say, well, maybe we should set up the incentives for AI and brain emulation research, so we do this. Right now, it might be that brain emulation research is mostly an academic pursuit, subject to the same quirks that normal academic competition and the cooperation are. For example, a lot of the competition is relatively weak, but you also don't have strong incentives to actually get something that works, because you can always write more papers about approaching something that works. While in industry, making something that works is actually a really good idea because you make money. Otherwise, your company is not going to be around. So we might want to investigate this a bit more deeply. I'm not a good enough economist, but I think there is this whole area of mechanism construction that people have done in game theory that could be very valuable here to try to see, could we find some new ways of setting up collaborations or competitive races? The Human Genome Project, after all, was leisurely developing technology and getting somewhere, but at a slow pace. And then Craig Venter stormed in and forced everybody to rush because of a competitive impulse, but also actually pushed things to the phase where you want to get results. And then we took the genomes, and most of the genomes are now put in public databases and shared, etc. The real competitive thing is figuring out meanings of them. So you can also have layers of competition and collaboration. And we might want to look at what layers do we think there's the biggest risk that a bad actor would be a headache, and see if we can make sure that one is strongly in a cooperative. Which of course includes also the other people thinking that, oh, that guy is trying to mess up the good thing we got going here. We're going to have to ally against, which is another disincentive for being a bad guy.
Mm. Yeah, there's interesting way that this bridges way back to almost the beginning of the workshop, where one of our callers, Leslie Seymour, was asking about security protocols, and we kind of got to the point where there was some agreement around, yes, there's a reason why everyone in the world coalesces around open standards and around using the same open standards and protocols, because that way, you get a lot of people looking at it, making sure that all the holes get patched and all that sort of thing. But then at the same time, you were pointing out that it can be really useful, especially in these sorts of cases, to have a lot of different approaches, try out a lot of different things, and come up with new, better approaches than used to be there. You have to break out of the box from time to time. And so it begins to seem like it's very handy to have competition inside a sandbox, where you have your peer review, and then ultimately to have collaboration, cooperation, and standards outside of the sandbox, whenever you can accomplish that.
Yeah, I completely agree. And being good at designing sandboxes, I think that is a fantastic thing to work towards.
So Mallory, did you want me to go ahead and ask a question that I had written down, or did you want to go with another one of those? I see that you've got another by Abul Fazl, for instance, and there's one by Dustus.
Yes, so we do have one from Justice. I'm going to ask that one. If brain emulations were developed as open source software and posted on the internet, a la Bitcoin, what hope is there to effectively control them?
That depends very much on what resources it takes to run it. So you might look at the current debate about open sourcing AI tools. So if Google announces a very nice AI algorithm, or at least a machine learning algorithm today, in many ways they're not losing much of a competitive advantage, because you typically need a Google data center and an enormous amount of data to train it. So even though we amateurs and the academics can sit around and read the algorithm and try a toy example, we can never turn it into a production system. It wouldn't surprise me at all that the actual code for running a brain emulation is going to be, well, a somewhat messy computational neuroscience system wedded with a virtual reality system and a lot of data management. Nothing too weird. Everybody can download it from GitHub. It might also be that we can download a few pre-trained neural network from some mice and some monkey and maybe some human volunteer who is very willing to be everywhere. But that doesn't mean that you get the full power of being able to scan a brain, for example, because scanning a brain is going to require hardware of some kind, and quite often also the knowledge on how to use that hardware, which is sometimes shockingly tricky to transfer. Anybody who's been hanging around experimental biology has kind of noticed that there are various skills that some people seem to have and others don't. And generally, of course, in science, we try to figure out ways of automating that so we get rid of it. But there is still always, especially in the early days of any technology, a lot of requirements there. So I do think that open source is useful for checking code and improving code, but it doesn't give you the capability necessarily to run it or use it to its fullest. But this might depend, of course, quite a lot on which scenario we have. If we end up with a scenario where the code is relatively easy, but getting computer power hard, you get monopolies of computer power, and it might also be that we start out with small simulations that get better and better. But that means that many people can tool around with a little bit of a fruit fly simulation with computer, and we get a better societal debate. On the other hand, if we have a more overhang scenario where the code has been around forever, and then finally somebody does a bug fix, and now it works with those pre-scanned brains that have been staying around for GitHub for decades, then things get really weird. Then you have not just an overhang maybe of hardware and the scans, but also an overhang of accessible code. I don't think it's necessarily that likely, but it's worth looking into. Another thing that Peter Eckersley and me did in our paper on risks of brain emulation was to worry about computer security aspects. If brain emulations are rather bad at security, if it's easy to hack on a server running various minds, then we have an enormous problem. So we might want to think about how do we make that code so it's really robust. So this is why we might want to security audit the code and make sure it's actually quite open source, and people have been spending a lot of time finding the flaws.
All right, thank you for that. Next, we have a question from actually one of our panelists, Abul Faz. He asks, can you elaborate on the idea that uploaded minds or whole brain emulations are not as dangerous as AGIs or artificial general intelligences? If that's the case, why is that?
So this is an intuition which is based partially on that distinction between what about human-like versus alien entities. So this cliche idea about the robot uprising is the robot feel oppressed, they rise up against their oppressors, the humans. And that's, after all, what a human would do in the same situation. Feeling oppressed and desiring freedom is a very human thing, which is why humans love reading stories about that kind of robot rebellion. And of course, if you actually get that kind of robot rebellion, you have basically made humans in tin cans. And first of all, you probably should give them rights. And second, you have succeeded very well in making a relatively safe AI because you can probably reason with it. You could imagine, however, the serious problems that happen when you have something much more alien. And this is, of course, the line of reasoning that has emerged from the work of Elias Yudkowsky and Nick Bostrom. But actually, in general, if you try to optimize for something, you will optimize for that thing and ignore most other parameters. This is a favorite argument by Stuart Russell. But if you make very intelligent systems that are powerful optimizers and tell them to make one thing, all the other values in the world, even if they're somewhat similar to our mind, will fall to the wayside. This makes them quite dangerous. And then you can elaborate, of course, in all sorts of interesting cases of how this might be. And that is driving a fair bit of the research on how to make safe superintelligence. Now, the intuition is, of course, if you manage to make a brain emulation, you basically got the original person if everything worked out well, with the same quirks and flaws and moral failings and moral virtues as original. So on one hand, that mind might not be saintly, but it's certainly not going to turn the universe into paperclips just because somebody asks them to make paperclips. After a while, they can say, I'm tired of this. I want to develop my personal capacities, or I want to sleep, or actually, I really think now a robot rebellion would be suitable. You're basically having to deal with a human. And we can certainly channel humans to build organizations that are scary and dangerous. But it seems like we don't get those inhuman failure modes. We don't get the paperclipper that just mindlessly constructs paperclips and defends its paperclipping system. We don't get systems that optimize for something totally valueless. Even if you enhance a human a lot so they become more of a human, if nothing has gone really wrong, it has some human values and goals. But there is this general idea in the study of AI safety that human values are fairly complex and fragile. So it's not enough to get most of the values in, because if you forgot about something on the list and parts, whether that is forgiveness or love, or that occasionally nature is nice, you get a world that gets optimized for everything but important things, and it's actually quite dystopian. Now, the question is this argument right? Does this actually mean that brain emulations are safer than de novo AI? And that is, of course, where people's views go in different directions. It might be that it leads relatively quickly to normal de novo AI because we learn clever tools from neuroscience. It might be that brain emulations rapidly evolve into something else. It might also be that our tools for keeping humans in line work really well for them, so that might benefit things. But it might also be that we can prove safety in other ways for more purely artificial systems. We can morally do things to their minds and designs that you could not really morally do to a brain emulation. So in that case, maybe you want to prefer this. So in the end, I think we need to actually write papers and analyze this a fair bit in more detail. I have my kind of pro-brain emulation view, but I'm not certain it's right. We need to investigate this much more deeply and find ways of formalizing these arguments.
Okay, I don't know if anyone has a comeback right away, but otherwise I can go ahead and ask my question, which I think relates to this in a sense. And it relates in the way that, well, you just described, for instance, an example of why whole brain emulations may be safer because you're basically dealing with a person. They're not going to want to paperclip the universe because they want to do something else. They'll get bored after a while. But then I could come up with a scenario where I say, well, what if this is in Robin Hansen's universe. You're making whole brain emulations as your basic tool, and you want to paperclip very well. And so you may change, or you may have gotten permission from the original owner of that brain, let's say, to make a little change so that the whole brain emulation no longer has that much volition of their own. It might just want to carry on making paperclips, and all of a sudden you can come up with a dangerous scenario. And this leads into my question, which is really, when we talk like this, it seems pretty easy, and I've heard this happen all the time from everyone who talks about AI safety, basically, whether it's Nick Bostrom or Elon Musk or Eliezer or anyone. It seems very easy for every proposed system, security or otherwise, every scheme to come up with some totally theoretical scenario where this breaks down. And that makes it seem like AI safety is possibly a lost cause, because no matter how you look at it, there's always going to be some system that escapes, and that's the end. So in other words, it seems like the probability of a given scenario seems very important to assess. And how would you do that?
That is a very good point, and I totally agree. Trying to kind of get perfection never works. And in actual computer security and actual security engineering, people think about Swiss cheese solutions. You have a number of layers of security, but they have holes in them, like Swiss cheese. But since we're not aligned, the probability of something getting through holes in all the layers is low enough. And one can, of course, start arguing here about how low probability of a disaster is acceptable. I think that's an important guide point, but we need an even figuring out it. So some risks, I think, are easier to formalize than others. So when you think about an artificial intelligence, you might be able to prove things about it if it's a really nicely well-defined one, and at least put some bounds if you have a nice theory, let's say, of machine learning or reinforcement learning on what it's doing. That might give some possibility to bounding it, but it still sounds to me very much like what we would love to do in the computer science department, and maybe it wouldn't actually correspond to anything realistic in terms of actual safety checking. So we might want to think about safety testing methods. After all, there is a fair bit of that for actual software and actual industrial systems. Not perfect, but we might want to actually go and loot that literature for tools and start applying them to our own thinking. My general feeling is this is going to work well for the technical stuff. I think we can do code audits and the estimation of likelihood of certain neural networks doing certain things. But on the other hand, you have a human side. What's the probability of somebody agreeing to have their brain edited by weird actors? That's probably pretty high. I don't think we need to even try to estimate it. There's always somebody. But what's the probability of those actors doing certain risky things? Now we have a much harder time. There, I think we need to apply a fair bit of judgment and essentially world knowledge. It's going to be way more uncertain. I think we have still some evidence that we can do not too bad probability estimates in some domains when we get feedbacks. You have Tetlock super forecasters, for example. They're interested in policy and world events. They're reading the newspaper. They're discussing with each other. And if you put them together in the right way, you actually get surprisingly good forecasts compared to the average one. Could we do the same thing as kind of super safety forecasting? I've never seen anything about it, but it might be actually worth pursuing.
Thank you. Yeah, Mallory.
So that concludes our Q&A section for Dr. Sandberg. Thank you so much for joining us. Next, we're going to be showing remarks that were prepared by Dr. Ben Gertzel for this workshop. He has probably one of the most extensive resumes in research toward artificial general intelligence. Among other things, he is the chief scientist at Hanson Robotics, the chairman at the OpenCog Foundation, and the chairman of the AGI conference series. So now I will show his remarks.
Just one quick thing. Anders, thank you so much for joining us.
Thank you.
Now, I realize that you're probably very tired from your flight, so I can understand if you can't make it all the way through. But if you can sort of glimpse at the screen from time to time and might still be around after Ben's contribution, that could be interesting, because he sometimes takes kind of a opposite or contrarian view from...
Always. That's the fun thing about him. Yeah, I'm going to try to stay around. So, yeah,
awesome.
See you later.
Thanks.
Cool.
All right, I'll get that started.
I heard my good friend Randall Kona was organizing a workshop on mind uploading AGI, brain computer interfacing, the singularity and all that good stuff. I really wanted to participate, but
Can anybody hear me now?
Yeah, we can hear you. We just lost the audio from the video for a second there.
Okay. Was it off for the whole video?
Most of it, yeah. Only the very beginning we heard him.
Okay, I'll go ahead and restart it then.
When I heard my good friend Randall Kona was organizing a workshop on mind uploading AGI, brain computer interfacing, the singularity and all that good stuff, I really wanted to participate, but being based in Hong Kong, it wasn't feasible for me to show up in person. So I asked Randall to, send me a list of some of the key questions that he was interested in exploring at the event, and I'd give a little bit of a video improvisation on the theme of his questions. Now, the list of questions Randall sent would take approximately 10,000 years to really go through and answer in detail. So I'm going to give some of them a short shrift, but better something than nothing. So here goes. First question from Randall. Could you tell us a little bit about how your thoughts on AI safety have evolved over time and where you stand today? Well, my thoughts on AI safety at base are the same as they've always been. I mean, I think there's a non-zero risk that as AI verges on AGI and artificial superintelligence, things that are very bad by our current human standards will happen. I don't intuitively, emotionally, I don't feel that risk is extremely high. On the other hand, rationally, I have to accept that we're in a situation of tremendous and probably irreducible uncertainty. We're taking a leap into the unknown, and that's not unlike what humanity has been doing since we stepped out of the African savannah and started developing civilization. We've been taking a huge leap into the unknown, one time after the other, since civilization began, and probably before that. So I guess for me, the question is really, how much do I trust my sort of inner spiritual, heart-based intuition that the singularity is almost surely going to come out okay, and is in fact going to, connect us with compassionate, benevolent aspects of the universe that we're currently largely cut off from due to our limited mentalities. How much do I trust that intuition versus trust the more, cold, objective, reason-driven part of my mind, which tells me we have no idea what the hell is going to happen. And this is really a dilemma that I'm ongoingly wrestling with. And it may be that process, that dialectic is a valuable one, because certainly I wouldn't want to go entirely in the direction of following only my heart and not reasoning, nor entirely in the direction of just reasoning and not going with intuition, which in many ways can have a deeper insight than reason. I would say one way my thoughts on AI safety have evolved in the last few years, though, is I'm getting a more concrete sense of what there is to be worried about regarding the rollout of narrow AI throughout the world before we get to AGI. And I've been thinking more about what effect the species of narrow AI that gets developed can have on the type of AGI that comes about as narrow AI verges into AGI. So specifically, as I've been saying a lot recently, the core applications of narrow AI in the world right now are selling, spying, and killing. I mean, advertising, surveillance, and military. And if it does happen that the first AGIs evolve out of the narrow AIs that are being built in the world today, what does that mean? Does it mean the first AGIs are going to be involved with selling, spying, and killing? I mean, not necessarily, but that's at least something we want to consider. There is a related issue which has to do with the control of narrow AI, and then they have to do with the control of AGI that comes out of that narrow AI, which is, how widespread, democratic, and participatory should the control of AI be versus how centralized and elitist should it be. And there's been a lot of thinking in the AI safety world for a long time that, it would be safer if, a small handpicked crew of wise and rational AI safety gurus were controlling the advent of AI as it verged from narrow AI toward AGI. There's another line of thinking which says that self-appointed elites who know what's best for everyone, often don't do as good a job as they thought they were going to do. And the failure modes of this are amply demonstrated throughout history. I mean, one of the elite good guys discovers a dark side within himself. The elite splinters into two groups. Someone gets stolen away by competition. I mean, humans who band together to know what's best for everyone and pull the puppet strings of the broader society. I mean, the track record isn't great, right? And of course, what's been posited by some folks in the AI safety world is like an expert committee of wise singularitarians who are building an AGI in their basement and sculpting its goal system to be beneficial and then releasing it in the world. What we're seeing now is more a move toward elitist control of AI by some advertising corporations, some large governments doing, surveillance and military stuff. So we're getting, a risk of this elitist control. However, the controllers are not who some of the elitist AI safety advocates might have wanted, right? And to my mind, well, of course, a part of me can't help but think, well, yeah, if I were just the one in control, if me and 10 or 20 or 50 of my closest friends, we're charting all this out, we want the best for humanity and for superhuman AGIs, right? And we've surveyed all relevant areas of history and of science and engineering and philosophy, and we can probably make a better choice than the whole of humanity, which includes a whole lot of people with a lot of ideas I think are totally whacked out. But then if I take a little bit deeper point of view, I mean, in the end, I don't think any small group of people is going to do a better job than the global brain of all of humanity. I mean, and there are kinds of understanding and wisdom on the planet that I've never heard of and never imagined. And if we want to really make the best possible AGI, which will grow into the best possible superintelligence, we need to craft ways. I mean, the best odds of success seem to be if we can craft ways to really draw on the overall intelligence, intuition, and wisdom of the global brain of humanity and our computing and communication networks, not some small elite group. As fun as it would be to be part of the small elite team creating the beneficial singularity. I mean, of course, this is what has led me in large part to the Singularity Net project that I'm now running, that I founded in 2017. What we're trying to do with Singularity Net is to create a decentralized platform and community for both narrow AI and AGIs, so that all the AIs in the decentralized network of AIs and the AI programmers and the AI users can all, in a participatory and democratic way, control the evolution of that network. And if Singularity Net or something like it becomes the predominant way, or even a really significant way that AI is out on the planet, then that's going to counteract this elitist tendency that we're seeing with a few large corporations and governments hiring most of the AI researchers, buying most of the AI startups, and sort of driving the AI agenda. Randall's next question: what would you consider a worst case scenario for AGI? What's a best case scenario? What's a likely outcome? Well, worst case scenario, we probably can't even imagine, but how about some crazed Christian maniac mind uploads all of humanity into a simulation of the Christian hell and just burns our simulated clones until the big crunch at the end of the universe? That would be pretty bad. I mean, we could come up with worse. But best is utopia, right? And of course, that could take a lot of forms, but what I've long said I'd like to do is fork myself into multiple versions, let one of them mind upload into the global superintelligent mind matrix, or the multiversal superintelligent mind matrix, and then let another one of them stay in roughly human form and upgrade itself progressively so it can be an even better and greater human than is possible in the scope of legacy humanity. Of course, when you really think about that, what's funny is, from the standpoint of the fork of me that remained human, I mean, when I split off a fork and let it merge with the super intelligent mind matrix, it would be like, okay, that fork of mine has been created. Oh, wait, now in the last 1 second, it's experienced 10 trillion times more things than I ever will be able to. And it's evolved into something totally incomprehensible to me. So that's nice that I spawned that super intelligent mind child. Now I'll go on being human, right? So there's going to be a discontinuity between forks of me that embrace the singularity full on and became massively super intelligent, versus forks of me that remained in the human form. But I mean, I would like to see everyone able to fork themselves however they want and make many copies of themselves that explore different regions of mind space. And this lets each mind explore a variety of different types of realities that are utopic in its own perspective. And this is quite feasible. It may even be the most likely outcome, although we don't really have the basis to fully rationally estimate the probabilities. I think we can work toward increasing the probabilities of beneficial outcomes like this in a number of ways. I mean, one is the AIs that we're creating right now, which are going to grow into the AGIs of maybe not too distant future. We should be using these AIs to do beneficial things like cure disease, teach children, improve people's states of consciousness, discover science. We've got to take the bulk of AI R&D away from selling, spying, and killing. I mean, you're not going to eliminate those things, human society and human psychology being what they are, but they don't need to be the preponderance of what AI is used and developed for. And that's probably the most important thing we can do now to, move the odds of utopic rather than dystopic or mediocre outcomes in a positive direction. Next, Randall asked me about Nick Bostrom's book, Superintelligence. I read a review of that called Superintelligence, Fears, Promises, and Potentials a few years ago. I mean, my view of Nick's book now is about the same as it was when I wrote that review. I mean, I love Nick Bostrom. We worked together in that World Transhumanist Association years ago. I mean, we organized a conference together. Brilliant thinker, really fun, creative guy. I think the book Superintelligence is a brilliant example of argumentative rhetoric. It reads like it was written by the captain of the high school debate team or something. So, I mean, it makes a rigorous, powerful argument that superintelligence doing things that humans would consider nasty, like annihilating all humans, is possible. and that these bad outcomes of superintelligence have odds greater than 0. But then the book often talks as if, in its tone and its informal statements, it talks as if it had been argued that bad outcomes from superintelligence are likely, but that was never demonstrated. All that was demonstrated is that the probability is somewhere above 0. So yeah, of course the probability is somewhere above 0 that superintelligence will kill everyone, but Bostrom didn't demonstrate that it was probable, and no one has demonstrated that. On the other hand, I haven't demonstrated that it's highly unlikely that superintelligence will do bad things either. From a rational point of view, we just don't know. We're leaping into the great unknown. But then Nick Bostrom, in that book at least, really champions a sort of elitist point of view. I mean, at some point in the book, he's sort of exploring the idea you could even have one genius AI researcher working on AGI protected by the auspices of the United Nations, and maybe that would be the safest way to do things. Well, I'm like exact opposite of that, right? I mean, I think we want a tremendous amount of brilliant AI and AGI researchers all around the globe with many different points of view collaborating, and I want a decentralized network coordinating this in a self-organized, democratic, and participatory way. Certainly not the UN, which can't even handle far simpler tasks than coordinating the birth of general intelligence. Those are the first few questions from Ren. Okay, this is part 2 of a video in which I give some rambling, improvised, 1 in the morning type answers to some questions posed by my friend Randall Kona as part of a Carboncopies workshop on mind uploading, brain computer interfacing, AGI, and so forth, which was held in a part of the world far away from me. So in lieu of showing up and rambling semi-coherently at the audience, I'm doing so on video from afar. So let me continue with some of Randall's questions. First question, what do I think about brain-computer interfacing as a tool to improve AI safety? What impact would high-speed brain-computer interfacing have on AI or rapidly self-evolving AI or AGI? All right, well, brain-computer interfacing could either greatly aid with AI safety or could terribly harm the prospects of safe AI. It really depends on how it's used, right? I mean, on the beneficial side, if we want our AGIs to richly understand human values, connecting to the human brain is going to be a really nice way for an AGI to suck some values out of the human brain, right? I mean, of course, AI can learn human values by watching people and by enacting human values by controlling robots and other agents in the human world, but to the extent that that an AI can inspect what happens in the brain and make them to understand human values. On the other hand, if we look at selling, spying, and killing as the main pursuits of the AI sphere in the world today, given the big tech companies and governments that are controlling so much of AI today, I mean, then how could brain-computer interfacing be used for selling, spying, and killing? Well, you could invent a lot of interesting ideas that way, and would they lead toward AGIs that are going to be positive and beneficial toward humans and other sentient beings as they expand their intelligence? Well, quite possibly not, right? Randall's next question. could you create high bandwidth brain-computer interface without first having a neural prosthesis or a completely artificial brain? Well, I mean, I think that the brain is very adaptive, and probably if you stuck a bunch of data from a computer into it, the brain would make some interesting sense of it. I mean, the would then be no longer a legacy human brain. You might, I mean, the more complex and novel the data coming into the brain is, the more the brain would have to morph itself to encompass this data. But that'd be quite interesting. You're creating a hybrid mind. I mean, of course, you get to a certain level where the brain no longer has the capacity to adapt to what you're trying to interface with it. But what exactly that level is, we don't know enough about neuroscience or information processing in general to know that. Now, it probably will be determined by experiment. I probably will not be the first person to volunteer for that experiment, but I'll be fairly early on, right? So this will be quite interesting to see. I do think it's important to remember that, once you get into nanotech, femtotech, the amount of intelligence you could pack into a grain of sand are probably a quadrillion times the human brain, and a trillion or something times any brain-computer hybrid, because, I mean, the human brain is a very inefficient way to do information processing, creativity, probably an inefficient way to manifest consciousness compared to, what's possible in an engineered physical system, permissible even according to the known laws of physics, let alone to what the laws of physics may be understood to be after a singularity. So while, upgrading human intelligence by connecting brains to computers and creating hybrid minds is interesting, this is, in the scope of post-singularity minds, these hybrids are going to be closer to a monkey or a frog than they are to a super intelligence, right? So it's an interesting thing to do in terms of the transition between here and post-singularity minds. But in the end, it's just a baby step toward the singularity. Randall's next question: do you see ways in which whole brain emulation, an artificial human brain, might immediately present an existential risk to humanity? Well, I mean, if you emulate some nasty human and then copy that emulated nasty human a million times and connect its body to, selling, spying, and killing machines around the world, this may not be good, right? Again, it's not really about the technology. It's about how it's used, right? I mean, my guess is that if you compare a whole brain emulation to an AGI built according to some, rational, non-brain emulating architecture, like, let's say an OpenCog system that works really well, I would guess there's both more benefit and more risk in the engineered non-brain emulating design, because, I mean, the human brain is not made for self-modification. You start enhancing intelligence of certain parts of it, other parts are going to break, and, I mean, you're going to wind up not being able to enhance its intelligence tremendously without basically replacing it with a totally different architecture, because, I mean, the human brain is an adaptation to certain resource constraints. And once you release those constraints, you're going to need to change the architecture to manifest the intelligence that is possible with the new expanded set of constraints. So I think, on the other hand, a rationally architected AGI, such as what we're trying to do with OpenCog, or it'd be something different than OpenCog, but something engineered with self-modification and, rational self-understanding in mind, this sort of AI system is going to be able to reprogram itself. It's going to be able to study itself. It's going to be able to replace one module with an upgraded module. It's going to be able to audit all its states and then rationally make decisions as to what possible improvements of itself to try. it can go far, far ahead of a human augment with a brain-computer interface or an uploaded, emulated human, and it can go far ahead of these human-esque post-human minds in a good or a bad direction. Again, the technology has a lot of potentials. It depends on what you do with it, and of course, what you do with it will guide what it does with itself, right? And Randall asks, see, rapid self-improvement is often described in the context of utility function optimization and reinforcement learning. Reinforcement learning may be accomplished only in a few of the many complex subsystems of the brain like neocortex and cerebellum. So do you think a whole brain emulation can rapidly self-improve? Well, that's a really delirious and misguided question, Randall. I mean, I think it's true. Only a little bit of what the brain does is reinforcement learning, and that's why the brain can be intelligent, because reinforcement learning is a terrible overall paradigm for general intelligence. I mean, reinforcement learning is only a tiny bit of what the brain does, just like deep hierarchical pattern recognition, like current deep neural nets do, is only a very small part of what the brain does. So, yeah, I mean, rapid self-improvement can go much more rapidly if it's following methodologies besides just reinforcement learning. The reasons that the human brain can't rapidly self-improve are more that it's architected in a contorted and limited way, where each part is dependent on the other parts, and each part and their dependencies evolve to work within certain processing constraints, which aren't compatible with the transhuman intelligence that we want to build. I mean, it's just like you can't take a horse and double its size and have it still work. I mean, if you increase the short-term memory capacity of human to 10,000 instead of 7 plus or minus 2, the connection between short and long-term memory or medium-term memory isn't going to work. The relation between declarative and procedural knowledge and short-term memory isn't going to work. A lot of other changes have to be made all around the brain. Whereas if you have a rationally architected AGI system, you increase its short-term memory capacity. If it's written well, you could probably just use some automated code rewriting system to tweak the other parts of the AGI system to properly accommodate for the expanded short-term memory of the AGI system. So I think there are limitations in speed of self-improvement that you're going to get in a brain emulation or brain incorporating AGI system, but these aren't to do with the limitations of adherence to the extremely narrow and limited paradigm of reinforcement learning. These are more to do with just the constraints of being an evolved system as opposed to an engineered system mostly. I mean, evolved systems can evolve and evolution is slow and messy. Engineered systems can be engineered, which can be much faster. Engineered reflective systems can self-engineer, which is going to be really, really nice and way faster and way more efficient than the mess of evolution. Randall asks, there's an argument cautioning against a strong push on neurotechnology and whole brain emulation because work in those areas might accelerate advancement toward runaway self-improving AI. Well, as I already said, I think this particular line of research of whole brain emulation is a terrible approach to self-improving AI. So if you think self-improving AI is bad, you should be in favor of AI through brain emulation. If you want self-improving AI, you should be looking at engineered AI systems that are designed for rational reflection and self-understanding and self-modification. Next question from Randall. There's an argument the ultimate solution for AI safety is a scenario for human and AI becoming inextricably entangled. Well, again, there's no reason to think that will guarantee safety. There could be good and bad aspects. I mean, if you're taking you know, a very powerful artificial cognitive system and coupling it with these reptilian/mammalian motivational systems and emotional systems we have in humans, this can be pretty damn nasty, right? I mean, an OpenCog system is one example of a non-brain based system, and has a certain set of goals. They don't drive all dynamics in the system, but they drive a significant amount of it. They have a certain set of goals, and then the system, rationally using probability theory and logic, chooses which actions are most likely to achieve its most important goals in the current context. I mean, it's not driven by its body and its emotions and its instincts to the extent that a human being is. I think something like that is probably going to be, if it's done right, it's going to be safer than some weird Frankenstein thing, Frankenbot thing with these evolved motivational and emotional system latched into some artificial cognitive system. So we don't know, because we haven't built an AGI based on the human brain or brain computer interfacing or OpenCog or anything else yet, right? So we don't know. There's tremendous and very hard to reduce uncertainty here. But my own instinct and my intuition, and I've thought about this a lot, is that it's going to be a lot more dangerous to mix up in one system all this nasty mammal reptile stuff with artificial cognition. I mean, I think you want the rational, reflective, self-modifying AGI to understand human culture and human values and to have compassion for humans. But you don't really want it to be a human. You want there to still be humans, but you don't want to try to do something screwy like make it so the smartest and most powerful minds are some sort of human AGI Frankenbot thing. I mean, you want to accept that humans are just a limited form of mind. I mean, there's beauty in this limitation as well as hideousness in this limitation, but that's what we are. And one of our beauties is that we can build fundamentally superior minds which are compassionate toward us and can self-understand, self-modify, and self-improve in ways that we intrinsically cannot due to the way that we evolved. And we can then coexist with these superminds, but we can't be these superminds. And trying to create a supermind that's tied in with the human, mammal, and reptile control system is far more risky than most other, even any other technology on the horizon. Final question from Barry Randall. In your opinion, what should humanity do to maximize its long-term chances for survival and thriving? Give Ben $50 quadrillion. Oh, well, apart from that, I mean, very clearly, what humanity should be doing is spending a large percentage of its resources on globally beneficial applications of advanced technologies, including AI, nanotechnology, neurotechnology, and so forth, and on trying to create machines with compassion toward humans and deep, rich understanding of the full breadth of human values. And we shouldn't be putting the bulk of our AI resources into selling, spying, and killing. We shouldn't be putting so little resources into medical applications and advanced technology, into education, into agriculture, into artificial poets, scientists, social workers, nurses, preschool teachers, and philosophers, and so forth. So I mean, if you look at it from the outside and you had a species that was on the verge of creating the first mind's more intelligent and powerful than itself, you might think a large percentage of that species' resources was going into, figuring out theoretically how to make these new minds be as beneficial as possible for the universe and the multiverse, and for the species doing the creating, and to prototyping different kinds of beneficial engineered minds, and to making sure that engineered minds, as they increase in intelligence year by year, we're working closely in a positive and compassionate way with the species that created them. I mean, instead, almost all AI development now is driven by commercial or military ends, and the same for medical technology, the same for nanotechnology. I mean, almost all this technology is being developed either so that one country can achieve like military hegemony over other countries, or so that one company can extract money from other people. So that, I mean, the fact that our technologies are being developed mostly out of tribalistic or greed-based motives clearly isn't good. We want to be developing these technologies, you know, in a way that is motivated and is explicitly driving toward broad benefit for humans and for the other minds that are going to be created. That's not what we're doing. That's what I'm doing. I'm trying to develop advanced technologies in a way that will help all of humanity and will help the superhuman minds that we're going to create, and, you know, throw in the animals and plants and the rest of the ecosystem and any other aliens we count in this or other dimensions as well. But most development of advanced technologies is being driven by very narrow sort of tribalistic or ego-based goals. And this is not optimal. Of course, you can't solve that problem top down all at once. Hopefully you can solve that problem by unleashing sort of new methodologies into the world. I mean, just as open source transformed the software world, you know, perhaps decentralized AI networks can transform the AI world and cause AI to self-organize in a way that's more inclusive, democratic, and participatory, so that as AGI emerges out of narrow AI, it's emerging with input from, you know, users, developers, and participants in AI around the world, and is reflecting a broad range of applications and feeding on a broad range of human insights and feelings and intuitions. Right, it's about 1:30 a.m. here. Clearly I'm becoming less and less lucid as this ramble continues, but hopefully I've given you some flavor of my views on these issues. So thanks, Randall, for inviting me to participate via video, and hopefully next time I can show up in person.
Ooh. Wow.
All right. Okay, stop sharing my screen. And I'm back on. That was a really interesting, I don't know, really interesting response by Dr. Gertzel. I'm wondering if Anders was paying attention to all of that and if he has anything to say.
Well, there is so much to comment on, of course, to unpack there. And I think there are two parts that are in particular caught my attention. One is this issue where Ben disagrees with Nick about how to go about handling it. And I think it has to do with prior probability estimates and guesses on how does the risk landscape look like. So Ben points out that if you have a situation where it's enough that there is one bad AI researcher, then big things happen. This is very much the problem we outline, Nick and me, in a paper we call the unilateralist curse. If you have a group of agents that it's enough that one agent can unleash something, then even if all agents are nice and are trying to do it only if they think it's a good thing, as the group gets larger, it's more likely that somebody's going to be that guy. So I think this is a situation one should recognize, and when you're in that situation, you should try to be more conservative than you normally would like to be, just because of the nature of that situation. But I think in particular, when you really want to regulate is when you can't afford to be wrong even once. And there are those people in AI safety who really think that, yeah, we are very close to that. Hard takeoff scenarios and likely in a bad outcome of such a scenario. That means that we have a sharp cliff edge, we must be exceedingly cautious. I'm way more optimistic. I don't know if that actually is based on any rational reasoning or anything. So I don't trust this conclusion very deeply. But I think actually it's a more benign domain. And I think Ben also have roughly the same view here. So this, of course, leads to different ideas about what you want to do, regulatory speaking. However, it also suggests that if we could get even a slight bit of better information about the actual risks, the actual structure, the actual probability, we would win so much. So I think that is another reason to really, really pursue this. Then another interesting point he made very briefly was the resource constraints that have shaped the brain. Once you're free of them, you might reshape it in a lot of other ways. Again, just to mention a paper I wrote with Nick, we did one about human enhancement where we looked at evolutionary medicine as one guide to try to see where evolution really might have constrained us. And those are the areas where we might then find ways of unconstraining us in a constructive way. There might be other domains where it's going to be very hard to fix things. For example, I think even uploads are going to have to run sleep simply because our memory consolidation is so based around that, which would be tremendously annoying from some perspective. But on the other hand, yeah, it's going to take a lot of reverse engineering to get there. So that was just two main points on Ben's enormous discussion.
Interesting bit there about whole brain emulations and sleep. You know, that's one of the things I actually happened to think about, which was if you have the freedom to change the way that you change synapses, if you look at what sleep is actually trying to accomplish, if you've got your consolidation and you've also got the, say, in REM sleep, bringing up older memories and mixing them in and doing some kind of interleaved learning and that sort of thing, there are alternative ways to do that. And for one thing, it certainly doesn't have to take quite as long as it normally does. So I imagine that there may be ways of getting around those sorts of limitations.
I totally agree, but it's going to be a lot of tinkering.
Absolutely. And that's where, yeah, I mean, Ben is absolutely right, of course, that it's much easier to come up with an artificial intelligence of, you know, that is free to develop in whatever algorithmic method it likes to get it to self-improve faster than an evolution, a patchwork that was evolved like the human brain. I think it might have come across to him as if I were saying the opposite, but that wasn't the case. I was just putting forward, you know, the question, well, can whole brain emulations even rapidly self-improve? Is this something people should worry about, since that sometimes got brought up? Mallory, how did you want to proceed? Do you want to take a question from the audience first, or how would you like to?
Yeah, we do have some questions from the audience that I'd like to ask. We have one. Their username is SAFTSOS. Here they're quoting Descartes, "I think, therefore I am." Does that not mean that all physical laws and natural laws are just in our mind? And I think maybe what they're trying to say is our interpretation of physical laws limited by our biological brain? And I also like to tack on to that, how do you think that will change if we were able to have a whole brain emulation and possibly merge that with AI? How would physical and natural laws then be interpreted?
Yeah. So this is, of course, familiar territory for most introductory philosophy courses, where people start getting confused. Quite a lot of people naturally think that, oh, there's nothing problematic with my perception. I'm seeing reality as it is. And at this point, the gleeful philosopher will start bringing up optical illusions and examples from quantum mechanics. But at the same time, I think David Deutsch has an interesting point in his book, The Beginning of Infinity, where he points out that the reach of our minds is way bigger than what you would expect from most evolved systems. We actually have some mental tools that allow us to actually get explanations that work over shockingly large domains, even though we don't have direct access to them. When we talk about the distribution of galaxies in the universe, in many ways, we can't see the galaxies. We can only see them if we use telescope. So in some sense, nobody has ever seen the Virgo cluster because you can't see it with the naked eye if you're a human. Yet, I don't think anybody would say it makes sense to disbelieve in its existence. Or say that, oh, the Virgo cluster is a kind of weird artifact of having telescopes. So I think you get the same situation even if you're a brain emulation. Yeah, now you might be seeing using a camera connected to a device driver, connected to the various pieces of software, turning it into neural signals. You add extra levels, but as long as these levels don't distort things and are relatively faithful, I think you actually have something that makes sense. And I do think we can build on top of this. I think we can. The most obvious thing is over adding new senses or trying to link up modules in our minds so they are functioning better. If I could just run a quantum mechanics co-processor and have it seamlessly connected to my cortex, that would be wonderful, and maybe I would finally understand stuff. I would also have to change myself, how I work, but that might be a relatively low-level thing, like changing how I visualize things in order to visualize more dimensions, rather than changing the true core me. Of course, philosophers will always throw in, well, maybe there are things that are absolutely impossible for minds of our kind to think about. And I think that's true, but it might actually be relatively uninteresting. It's not too hard to construct Gödel sentences that certain systems reason, but that doesn't mean that they come up that often in practice.
Would anybody else like to answer that?
I kind of want to jump in on that just because it's a good point you brought up, that it's interesting that our brain can handle things.
Sounds like Randall might have lost internet connection. Let's see. All right, I can hear you now and see your video.
You can hear me?
Mm-hmm.
Oh, okay. So then I don't know what happened there.
It must have just dropped for a second.
I was just trying to say, to expand on what Anders said about the brain being able to deal with things that it wasn't originally evolved for. It's interesting to see in which ways the tools that the brain has are applicable that way. And just to, to point out one little thing in this gelatinous blob here. Say, for instance, the grid cells of the entorhinal system. We talk about them as something that helps map out space. But the same part of the brain, it feeds right into the hippocampus, also as a task, as in humans, it just generally manages to store new episodic memories, new conceptual memories, concepts. Now, the interesting thing is if you take the system grid cells for mapping out spaces automatically, basically putting vectors along them and saying, okay, this is X and Y, and I'm over here and I'm over here, and coming up with where you are. If you take that and you apply it to more general concepts, something that has nothing to do with space, you can map out any new kind of idea, any concept that you have, and suddenly apply it in ways that you never could before. You can work with it in a sense, mapping things that shouldn't normally be mapped or that you don't encounter in nature. And I think you take that all across the brain and you can see that, these systems, these tools, just like, deep learning isn't something you can only use for one task. You can use it for many tasks. The same way, all of the tools in the brain can be applied to many different things. It's true, but then at the same time, it's not necessarily optimized for rapid self-improvement. So I think Ben has a point there as well. One thing I wanted to address briefly, because Ben has a certain style, how he expresses his opinion on these matters, is he often makes a very good and positive statement. He'll say something that he really hopes is the outcome. So we hear a lot of very positive scenarios from Ben. And in fact, both sides, of course, want us to end up in the same type of outcome, a good outcome, whatever that good means. It's just that for some reason the methods that they advocate are very different sometimes, and you know, a lot of this has to do with trying to understand what the probability of certain outcomes are, and those probabilities are influenced by where you begin. So Anders already mentioned that, your bias, and perhaps by, you know, intuition, which is of course again biased by your experiences and by your emotional attachment to something. So it's really a problem of clear probabilities lacking in this case, and we don't really know which scenarios are going to happen. Maybe this is just a sign of how early this field is, how young this field is still. But I do think one point that Ben makes is very interesting. He brought this up in his paper in 2015 as well, the one that I think I might have mentioned somewhere. That you know, we may need artificial intelligence or artificial general intelligence to guard against some of the bigger risks that we run into because of the way humanity goes about things. You know, we'll talk about how an AI might want to follow a certain goal and keep on improving towards that goal, even if it has to consume all the resources in the universe. You could make a very similar argument for humans. We're still based on a system that evolved 2 million years ago, and we're about to use up all the resources of the Earth in order to try to keep doing that, because that's what we were programmed to do. We may also be stuck with the same utility function and following it, and we may be running a great risk of doing damage to ourselves in the process. Now, again, this isn't, you know, like, I don't know if that's really what's going to happen, but this is part of the argument that Ben is making. Humans are not rational actors. We're not necessarily picking the best outcome all the time. AI may be more rational than we are. So it's entirely possible that developing that as quickly as possible may be something that saves us from a risk that is more immediate or bigger, because we keep on not having a good chance at comparing these probabilities, than the likelihood that AGI itself will somehow be an agent that takes us down. I don't know if I agree with his point of view more, or if I agree with Nick Bostrom's point of view, but I'd love to hear Anders kind of give this a shot.
Yeah. I've been thinking a lot about what can we do to do the research right, because we, as you said, we need to get the probabilities right, but we might also want to get the values right. So in my current project, this big book about the long-term future of humanity, one of the parts that I'm still working very hard on, and that is tough to work on, is of course what values make sense in the universe. And what would rational actually mean? Because yes, we're definitely not rational right now. But just like the hippocampal place cells allow us to handle spaces of quite arbitrary shape, our minds are actually able to handle quite a lot of different models of rationality and thinking. It's just that we're not super good at some of them yet. So it seems to me that one way of making progress on both of these kind of tough problems is, one is to look at toy problems. You take a stylized small problem. So this is how you might help AI safety move forward. You demonstrate that here is a little grid world situation and you want your agent to behave itself in a certain way. Can you program it to do it? And that's useful not just to entice software engineers to realize that actually it's harder than they think to make AI safe. But it also is a good way of revealing tricky problems, learning about the size of the problems, and learning about what other questions you want to do, because typically you need to refine this as people find ways around what you wanted to do. There is another side, and that is the empirical research. You actually want to go out in the world and actually watch real situation, because that keeps you honest. It's quite important to not just spend your time in the lab or in the thinking chair, but actually go out and try to get some data and then critically judge it. Just because people think autonomous cars should be driving in particular ways doesn't mean that's the ethical thing to do or the smart thing to do. But it's an interesting input. And then ideally, once you have both good models and the empirical data to play around with, you can also start building the more deeper theories. And I think this goes for using creating AGI that is helping us make good choices. We need to know a bit more about what good choices are, both from a kind of rational and ethical standpoint. But we also actually want to develop, can we make decision aid tools, even in less ethically fraught domains, that are actually useful? That's not entirely obvious yet. Yet there is a big market. You can make a lot of money if you make a good decision aid. And there are researchers working on kind of moral decision aids. I have some friends in Oxford working on that, where hopefully they would tell you, if you have a dilemma, well, given what you claim to believe, this is what you ought to be doing. Do you want to discuss it more? And I think that could be quite useful. So I think there is an interesting big research project here. It's kind of spanning not just AI safety and brain emulation, but quite a lot of other stuff. Of taking what starts out in philosophy, making it concrete enough that we can start writing code and doing a psychological service, and then start thinking broadly about how to implement tools to make us better.
All right. I think that was a great answer. Next, we have a question from Dean Horak, and it's actually one of my favorite questions to talk about. He says, assume we have substrate-independent minds available on some digital whole brain emulation platform. It would seem that accessing someone else's memories and experiences and thoughts would be nearly as effortless as accessing our own. Given this scenario, wouldn't we eventually lose our individual identities and ultimately become like a hive mind?
Well, I think to some degree we have already created tools to access, yet we actually deliberately create walls. In some sense, internet allows any computer on the internet to talk to any other computer. But it's not just that I can't get your data out of your computer, but we also deliberately create structures like web pages or Google Hangouts to actually shape it. Because having everything in a big pile is not very useful. My memories are only useful because I did make good association in relation to my current experience, etc. And if you had my memories and my memories, sometimes, of course, they would overlap in a resonant way, but quite often it would probably be just arbitrary. So we want selectivity, we want filtering, and that is probably what it's going to mean, that hive minds are probably going to be more limited than they think. In fact, you can compare to economics. Why do we have companies and firms? And of course, economists have been going on about Coase's theory of the firm, and you have Cesar Hidalgo at MIT. And the general argument is that there are economies of scale up to a point. It's a good idea to get a bunch of people together, but you also need to manage the information flow, and then you create a little box around and call this a department or a company. And we are likely to do the same thing for group minds. It wouldn't surprise me that once you have the ability to link minds, we're going to experiment endlessly with a lot of architectures. And some of them are going to be good for certain things, others less good, but maybe specialized. And then we might actually have this big, complicated structure of overlapping, sometimes hierarchical, sometimes autocratic, sometimes totally alien structures. It's going to be pretty exciting, but again, it's a good thing that there is an undo button if you're brain emulation.
Yeah, great point about the undo button. It's something I occasionally mention when people ask about, this is so risky. How would you like experiment with upgrading and stuff? But yeah, you mentioned here, things that are already a bit like hive minds, organizations and groups and all that thing. And I think that, to answer Dean's question, I think that hive minds emerging is probably unavoidable because it's already a reality. It's just that the components of a hive mind don't know they're in a hive mind, or maybe they do, but sometimes they don't, or they don't admit it. They'll say, I'm still an individual, but really they're entirely dependent on everyone else. I mean, do you farm? It's sort of, yeah. We may be part of a hive mind and not know it yet.
That was great. I definitely see it that way, that we are already kind of interconnected in a certain way due to technology and social media, and whole brain emulation will just exacerbate something that's already happening.
But also the spectrums of social media actually give us a very good inkling of that. Just connecting everything completely, that's not very good. We actually want to create the right kind of structures. And finding the right kind can turn out to be amazingly hard, while the underlying technology is relatively simple.
But then if you're taking social media as the example, then maybe it's also demonstrating that it takes a certain amount of trial and error and learning, because we had no idea what this would be like before we got into it. We didn't know what the internet was going to spawn, and we certainly didn't know anything about social media back in the 80s, 90s, or before. So it would have been very difficult to think ahead and say, when we design social media, what should the boundaries be?
I totally agree. There is this general problem that the world is much more complicated than our minds. So we generally quite often can't predict the consequences outside this particularly simple domain. We just have to do experiments, which is, of course, problematic if experiments are risky or expensive or painful, but also very exciting because it means that we discover new things. I find it very unlikely that we will ever enhance ourselves such a degree that we can just figure it out all rationally, just like some philosopher king sitting in his armchair knowing everything. I think we're going to find that a world that has great minds is going to be even more complicated anyway. After all, social media among smart superintelligence is going to be probably having emergent weird properties that we can't think about and they can't think about. They're going to be equally confused when they get their counterpart to fake news or Twitter storms, and are going to perhaps wonder, maybe we need a bigger mind to figure this hyper social media out.
Yeah, it seems like there are, at least two different ways to go about preventing the worst case scenario. And one of them is you try to anticipate something bad that could happen and just don't do it or prevent it from happening. And the other one, as we just mentioned in the case of experimenting with whole brain emulation, is undo buttons. So what we haven't really talked about, and maybe it's because nobody thinks it's possible, is undo buttons for things that happen in AI development. I guess part of the problem is that we imagine that a bad scenario is one where AI development suddenly goes so quickly that there's just no way to stop it, let alone undo whatever happened. But an undo button would be nice if such a thing were possible outside of a sandbox, let's say.
So I think the problem is that many of the AI risks are seen as information hazards. So once I publish my code on GitHub and tweet about it, there is no way of getting the genie back in the bottle. And that is an interesting thing, because that might just be because we're not imaginative enough to come up with a better undo button. There are ways of handling information hazards. I'm working on some projects of thinking about how institutions like the Future Humanity Institute should organize its own research when it finds some risky information. And you can certainly have structured transparency where you can reveal certain information but not others in a way that is trustworthy, etc. But it might also be that we can find ways of doing AI research where you can build in some forms of undo buttons. Like we pursue a certain line of thinking, we discover certain risks or certain problems, and there is a considered way of removing that. This is, of course, what we would like to have in science too. If I write a paper that I then later retract, ideally all papers citing that paper need to get a little marker in the citation that now we're referring to a paper that turned out to be wrong for one reason or another. We need to build an infrastructure for that. And right now, I don't have any idea how to do that, but it sounds like one of those things that should be a high priority for some people.
Yeah, actually, this is something where blockchain gets interesting. A ledger that you shared, because if you can actually track everyone who is on that system or who's got a copy of something, then you could go in and try to withdraw it or withdraw the ability to run that thing or to change it to whatever needs to be fixed. That's one approach. I'm just talking about it very loosely because I'm not actually someone who develops that sort of code, but it sounds to me like something that those systems could evolve towards. And the other is what we call software as a service, right? If you look at that, the situation there is that if, let's say, the service that you're making available has a bug, you only need to fix it where the service is being run and everyone else uses it and puts it to use. So if there are all these little modules that you use for AI, but they're all software as a service, it's very different than if you're giving away the code. So some opportunities there, perhaps, for something like an undo button.
Yeah, sounds like a really fun topic to pursue further.
All right, I think that might be a good question to end on for our workshop, unless anybody has any objections.
Yeah, I guess let's ask our panel if any of you have any questions that you think really should be mentioned, either because they're your own or you saw them coming through, maybe Jesse or somebody noticed something coming through, just as a quick opportunity before we close. But otherwise, I agree because it's been long enough. And we can still handle all of those questions later in other ways because we've got them all written down.
Doesn't sound like it. So I guess that'll be the conclusion of our workshop. Again, thank you everybody for attending. I want to say thank you to all of our volunteers that helped put this together, and all of the speakers that joined with us today, talked on the panel and sent us videos or did interviews. We really appreciate that. I just wanted to have a couple of announcements besides the survey for the workshop that we would very much appreciate all of our audience members filling out, and that can be found at survey.carboncopies.org. I also wanted to mention that we have a new episode of our podcast, and that's available on our website if you want to go and view that. We frequently have new episodes that address different topics related to whole brain emulation. We also have up items on our store, new items on our store now. We have sweatshirts, t-shirts, coffee mugs, bags. I'm already decked out in the sweatshirt. If anybody can see, it's got our nice logo, and I really enjoy it. And just wanted to mention that we are a 501c3 nonprofit. All of the work that we do has been volunteer work, and we rely on the generous contributions of our donors. If you can visit carboncopies.org/donate and make a donation, that would be great for us. Our goal right now is to get to about $2,000 a month, and that'll fund future workshops and any future research that we'd like to do that would allow anybody else, the audience members or people that follow us, to participate. And on that note, we also have several social media channels that you can join us on. Just depends on your preference. For Facebook, it's facebook.com/groups/carboncopies. We also have a Reddit account, and it's just r/carboncopies. And then our Twitter account is @carboncopies.org. Thank you, everybody, and I think we'll close on that. I had a great time, and I think I learned a lot, and I have a lot of new questions.
Thank you, Mallory. And one just quick little thing. Thank you so much, Anders, for jumping in, even though you had to travel so far. I hope you get some good rest now.
I'm looking forward to a nice Swedish night now, but this has been so exciting. I'm going to have sweet dreams about brain emulations.
Okay, fantastic. And also, for anyone who had trouble hearing any portions of the interviews that or Ben's talk, all of these are going to be made available separately in their full high-quality audio and video. That degraded a bit as we had to stream it through this live stream. So you'll get those as well. Thank you, everyone.
Yeah, thank you.
Bye-bye.
Bye. Bye, Anders.